Hey guys, let us prepare for the trial exam on Monday for those who are writing paper 2 for maths. Now, there are three major topics: analytical geometry, trigonometry, and Euclidean geometry. Right, analytical geometry, not really that bad, but it can have some nightmarish type of questions. So, well guys, prepare very well. Make sure you've been doing your work. I have made tons of videos where there's full papers as well as some just, floating questions, if you will. So have a look at the channel if you are lost, but it may be very difficult to find the right pieces of information in the last minutes. But I'm going to try and assist you to prepare by just showing you some possibilities that you can explore, even though the time may not be on your side. But there's nothing that can be left to its own devices until it's over, right? We just have to keep trying. So without wasting any more time, guys, let's just have a look at these analytical geometry questions. I'm going to do one which is typical of question 3 and do one which is typical of question 4. Then I will highlight and perhaps point you to which type of questions you may want to perhaps practice. And one thing for sure is I will have this document with the past exam question papers on analytical geometry, and I will even indicate which questions I would suggest you have a look at. And those who are my students have my WhatsApp number. You know very well that no matter what time you are doing these questions, although you should not be doing these after 12 midnight, especially the day before the exam, you should be asleep. So anytime before that, you are at liberty to just hit me up. Either you send a screenshot of the question that gave you troubles, and perhaps I can give you a better response, if not a comprehensive one. Anyway, so you know what to do, folks, and let's just get to the business without wasting time. Question 3 here tells us that in the diagram below, point M, you see, we don't have the coordinates. It means we need to figure out how will we find those coordinates. Point T, which is a point in the second quadrant, we see by the quality of those coordinates. Point N, again, this is suggesting that we probably would have to think about how to find those coordinates. And point P, which is a point in the first quadrant, by looking at the coordinates, are vertices of a trapezium, M, T, and P, okay? We can see it. Having Tn parallel to MP, again, that's indicated. Now, point Q, which is a point in the first quadrant, is the midpoint of MP. If it is the midpoint of MP, it means we can say MQ is equal to QP. If it is not indicated, guys, please ensure to do so that you don't lose that part, because sometimes it may just be very important in some solutions. Now, PK is a vertical line, and we can appreciate that indeed it's 90 degrees. And SPK, which is theta there, it's already indicated. The equation of NP is minus 2x plus 17. Okay, that's fine. We can take it out. This is y equals minus 2x plus 17. Please ensure to indicate these, folks, because it can get very messy. Right, now with all of this information, what can we do? If we look at this, we'll see that this is a vertical line, right? If this is a vertical line, it means the coordinate, the x-coordinate of K is the same as the x-coordinate of P. So this suggests that point K is basically 7, but since it's on the x-axis, y is 0 there. Again, these are very important pieces of information to consider. Right, now let's have a look. Furthermore, we can see that we've got the midpoint Q, one point P, we can work out using our midpoint expression, those coordinates of M. So we've got the A game right there. Now that we have points on that PQM, we can actually find the equation of that line. From the equation, we can actually work out the coordinates of S if we need to. And seeing that we can find that equation, we can even work out its angle of inclination, seeing that theta there is also unknown, so we may have to find theta. So at this stage, we may have to consider looking for this angle of inclination. We can call it alpha if we choose. Right. What else can we do? Well, we can see that, again, this line PM is parallel to line TN, right? And so that means the gradients are going to be the same. Taking that gradient and substituting this point into the equation, we can actually work out the equation of Tn. Now the equation of Tn together with this equation, they are essentially intersecting at n. So we can use simultaneous equations to work out the coordinates of n. So it looks like we can solve pretty much everything on our diagram so far. And if this is the case, we don't necessarily need to skim and scan these questions. But sometimes you may want to do so that you can pick up the questions you can answer easily and quickly. Okay, let's answer these questions. So question 1, we have to write down the coordinates of K. So that's easy. If we need to write them down, and we already determined them, so we don't need to justify. So 7 is to 0. And in fact, I just justified. For a vertical line, it's a line parallel to the y-axis, such that the x value is the same throughout. The only thing that's changing is the y values, depending on the height on the x-axis. On the y-axis. So we get our mark. Easy stuff. Usually it's for the x-coordinate because the y-coordinate is automatic. So 3.2, we need to determine the coordinates of M. And we saw that we can use our midpoint expression. Again, when it says determine, you can do it by inspection, you can do it by calculation. It doesn't really matter, but let's just do it the standard way. We know that point M is such that x at M plus x at P divided by 2 should give us x at Q, the midpoint. Likewise, y at M plus y at P divided by 2 should give us y at Q, the midpoint. So this implies that our M is going to be x at M, that's what we want, plus x at P, which is 7, divided by 2 equals 1. Likewise, y at M plus 3 divided by 2 should give us 1. Now the gymnastics kick in, guys. It's either you know or you don't. 2 times 1, that's 2, minus 7, we get minus 5. Right? And then 2 times 1, that's 2, minus 3, that's minus 1. Okay? So we've got it nice and easy. Of course, guys, if you've been a fan of my channel, you know exactly how this is done. So we can say substitutions to some identifiable structure and the answer. But remember, folks, a question that says determine, it can be done by any means necessary. So even an answer only would be acceptable for 2 marks, because 1 mark for the x coordinate and 1 mark for the y coordinate. So here there's a bit of freedom to do how one wishes, depending of course on the question. Now we again need to determine the gradient of PM. So we can say, well, the gradient of PM is going to be y at P minus y at M divided by x at P minus x at M. Right, so y at P is 3 minus y at M, we got minus 1, divided by x at P, that's 7, minus x at M is going to be minus 5. So this is equal to, this is 4, 12. So 4 goes to itself once and 3 times to 12. And that's a very fairly gentle gradient. We can see that it's not that steep and it's positive. So this is acceptable. Okay, guys, one can do it through a calculation. And of course, for 2 marks, we get our marks for substitutions in our formula that we can recognize. Or someone, again, may just do it by inspection. Remember, guys, once you are so good at this, you can actually do this without even needing the calculation. So you can just easily say, well, 2 marks for the answer. Now, what is the story here? How would you do it by inspection? Of course, you can just look at point Q. Just look at any 2 collinear points. Look at point Q. Let's say, how did we move point Q to P, as in the change in X? Sorry, the change in Y over change in X. So we can see that, okay, it's a rise over run, isn't it? So we started from 1, we ended up at 3. So that means we moved up by 2. So we've got 2 on the numerator divided by, then we say ourselves we moved horizontally from 1 to 7, that's 6 units. So we've got 2 over 6. 2 over 6 is as good as 1 over 3. So by inspection, it can be done. Okay, cool. So answer only here is accepted for 2 marks because the question said determine, did not stipulate, sorry, it did not force anybody to perform a calculation. But when the question says calculate or perhaps show, that's a different story. Okay, you need to show everything. Inspection is not a show. So please remember that. Okay, 3.4. But again, there can be a mixture of things depending on the complexity of the question. So don't hold on to, just one aspect of things. Just consider all possibilities. Right, 3.4, we need to find the size of theta. Okay, and we saw that we needed to dive into this triangle. So as you can see, triangle SKP is essentially going to give us more because we've got 90 degrees here. We've just found the gradient of that line. So we can determine its angle of inclination. Then from 3 angles of a triangle, we can find theta easily. All right, so that makes life a lot easier. So let's see. We will say, well, let alpha be the angle of inclination of PM or MP, right? Such that we know that tan alpha is going to be the gradient of MP or PM. So this implies that our tan alpha is going to be a third. Therefore, our alpha is going to be the arctan of 1 over 3, which gives us, let's put it on the calculator. Unfortunately, we cannot guess this one. Arctan 0.33 recurring, or should you say 3 recurring? But either way, you just get 18,4352, 3 decimal places, just to protect our answer. We can say then, in triangle SPK, what do we see there? In this particular triangle, once we name it, we don't need to say PSK, for example. You can just say angle S plus angle K. Again, we don't need to say SKP or PKS plus angle P. Even that, we don't need to say SPK. this is equal to 180 degrees, okay? This is from the sum of 3 angles of a triangle, which is what we just mentioned. Then we substitute. S is our alpha here, so this is 18,435 degrees plus K, 90 degrees, it's given, plus P, which is what we want. In fact, P this time is theta, equals 180 degrees. Therefore, theta, we'll just go for the jugular this time. So we'll just say 180 degrees minus the sum of 90 plus 18,435, okay? So this gives us an angle of 71,57 degrees to 2 decimal places. Usually our final answers can be rounded off to a minimum of 2 decimal places. All right, so this is easy, guys. Can you see this one needed a bit of structure? Without one, it would have been a bit more challenging. So please, guys, don't forget Euclidean geometry. Don't forget trigonometry. Analytical geometry is the most integrative of the geometries. But don't underestimate Euclidean geometry in terms of integration of all the other topics as well. Right. So we're getting 3 marks. So what is important here is the angle. Right, very important. And of course, substitutions into some identifiable structure and our answer. Of course, these could still be candidates for marks as well as that. There's plenty of things. But remember, folks, if we start talking about some angle, for example, alpha, we must have introduced it before we speak about it. Learn to just state things nicely and clearly before proceeding to use those things. Don't assume an examiner understands. Remember, you are going to be a professional tomorrow. You will need to kind of find a way when everybody else is lost. And after doing so, you will have to communicate that to those who can actually speed up the process. So please, folks, learn to communicate effectively and clearly and being flexible at all times. Right, so we've done that. Easy 3 marks. We are told to then determine the length of PS. Now, PS is the hypotenuse side of our triangle. And if we hear that statement, it means we are likely to use what we have. And of course, if we did not want to use what we have, what could we do? We could find the equation of MP. Because we've got 3 points on that line. From those points, we can actually determine that equation. From the equation, we can work out the x-intercept of S. From that x-intercept of S, we essentially can use our distance formula to find that. Again, you could see that that's a lot of work for just 3 marks. So is there a better way? Well, if we look at that triangle, it's a right-angled triangle. And we know that technically we would know what this size is, isn't it? It's going to be the y top minus y bottom. So that gives us 3 units. Okay? And at the same time, what do we have? We've got the value of theta. Calculated it now, it came out as 71,57 degrees. So we can use that because this spells out cos of theta, adjacent over hypotenuse. And the hypotenuse is the unknown. So we can go back and say in triangle SPK, we understand that cos of angle P is equal to the adjacent, which is now going to be PK, divided by the hypotenuse, which is PS. Right, we substitute. This is cos of 71,57 degrees equals PK is basically 3 minus 0 divided by PS. Always, guys, show the steps whenever you can so that you don't get victimized by the strictness of, the guidelines on that particular question. So obviously, guys, this implies that our PS will be 3 divided by the cos of 71,57 degrees. Right. Okay, let's see, guys. It's late, but I'm really struggling to sleep, I'm struggling to sleep. Goodness. Ndenza ntoni ngokule calculator nayo? Ngiqhela kabi, ifuna ukungiqhela kabi, Nandifuna ukuqhela into engakwazi ukuthetha. Right, okay. 3 divided by the cos of 71,57. I was just confirming that my 71,57 is correct, because it's so easy to not get it right. So we can make a conclusion that PS is 9,49 units to 2 decimal places. Okay, so folks, that's it for now. We can say maybe this calculation substitutions answer, again, depending on the approach. Either way, guys, if one shows a stepwise approach, no matter what approach one chose, and everything is correct and the answer is correct, you still get full marks irrespective of the marking guidelines. But when the general instructions are broken and maybe the local instruction is broken, at this point the local instruction is very easy. Once it says determine, it's an open-ended question, so it doesn't really become strict, although we need to really think about being free, considering the general instructions. We cannot forget that we show everything we are using to determine our answers. So 3.6 says determine the coordinates of n. So we know that, well, this is one of those heavy questions where we need to really put some structure into this. And we saw the plan to do this. We needed the equation of Tn. So we can say, well, line Tn as a vector here, it's going to be y equals, okay, maybe let's start by saying stuff. So we know that the gradient of Tn is going to be equal to the gradient of MP, or let's just say PM, to avoid a bit of too much repetition there. Okay, now we know that these are parallel lines. Okay, parallel lines have equal gradients, therefore the gradient of Tn is going to be a third. Right, we can say therefore, or this implies that the line Tn as a vector will be y equals a third of x plus c. Then we use point T, which we have -1 and 5. So we will have 5 equals 1 divided by 3 into -1 plus c. Therefore c, okay, maybe let's not say that. That implies c is, now this is going to be 5 plus a third, so 3 by 5, 15 plus 1, that's 16 over 3, so that should be 16 over 3. Okay, engage your mind as much as you can. So we've got y equals a third of x plus 16 over 3. Excuse me, guys, yeah. Sometimes I'm allergic or something. And that's what is killing me slowly. Now, folks, we have a plan. Once we have the equation of Tn, we know that then at point n, we understand that this third of x plus 16 over 3 equals minus 2x plus 17, isn't it? Those two equations are equal, so we solve simultaneously. So you cannot run away, guys, from algebra. It always will haunt you. Now we move minus 2x to this side. A third plus 2. 3 by 2 is 6 plus 1 is 7. So we get 7 over 3. X equals. Now this is 17. We bring in 16 over 3. So 3 by 17 is what? It's 51, right? So we're going to say 51 plus 16. That gives us 67 over 3, okay? So 67 over 3. Wait a minute. What am I saying? We are subtracting, not adding. So we're going to have 17 minus 16 over 3. Please do the right thing, guys. So this is 35 over 3. Okay, so you can see that x here is going to be, we multiply by that 7 over 3 flipped. This means 3's will go, 7 to 35 goes 5 times, so this is going to be 5. So if this is the case, it means y is going to be minus 2 into 5 plus 17. Right, we can use any one of the two equations. So let's see there, that's minus 10 plus 17. That's just 7. So we can make a conclusion that n is the 0.5 is to 7. Okay, we need to show the coordinate pair there. So this is one of those questions where a bit of structure and a systematic approach applies. So essentially, guys, for me, this substitution is key. The equation was key. The technique of simultaneous equations, each one of the coordinates, provided we do present them in the ordered pair. That's what the question wanted. If we don't, we may be punished, even for a correct answer, because, guys, this is not about just knowing how to do the right thing. It's also knowing as to when to do the right thing, and it is also knowing as to why the right thing has to be done, because that way we become complete. All right, so enough of the little chit chat here. Let's get to business, guys. So we've got 3.7. Right. Now 3.7 says, if A lies in the Cartesian plane. Okay. Now we will notice that A actually has a y value of 5. But we also see that T has a y value of 5. So this means these 2 points are horizontally related. A and T are points on the horizontal plane. Or we can say same horizontal plane. Right. It sounds like we are running into some problems of those higher grade type questions. There's always one, guys, so be prepared to do it. Now, what are we going to do? We will look and say, right. Oh, the question says, write down the equation of the straight line representing the possible positions of A. Now, we're told to write the equation of a straight line. Now, we know that A is either less than 0 or A is greater than 0, right? Because a point on the Cartesian plane that has a positive y value is either in the first quadrant or second quadrant. So that's why we know that, okay, we can say that. And of course, we know that it's either in the first or second quadrant. Now we need a line that will place A, no matter where A is, as long as it fits the description that it's on the same horizontal plane as point T. So we know that if we draw a horizontal line, maybe let's choose a different color. Yes, there's colors sometimes. Let's just draw a horizontal line, and take it to, through point T, so that we can have what we're trying to achieve. All right, so so we can appreciate that A can be anywhere along this line. Because if we want the possible positions of A, they can be anywhere along this line. Because as for the other lines, yes, they may still, A could be a point perhaps on this line, we don't know. Could be a point on that line. But if it is a point on that line, that means it has to coincide with T. So no, not very likely. Could it be a point on this line? The answer is logically no, because on this line, it means it has to be point T, and we can clearly see it's a separate point. So that means this point cannot be on MT, it cannot be on TN. But is it possible for it to be on NP? Yes, because we can see this horizontal line cuts there. So there's two lines in which this can be. In fact, three. Point A, if we are to look at possibilities, can be here. At least this is a point we know, of course, and anywhere else. It can be on this line, NM. Yeah, it's possible. It can be right on the y-axis. It's possible. It can be just before the point T. So those are the possible positions, at least for now. We need to consider these possibilities. So guys, please, man, enjoy your subject. Just love some complexities, because this is what we call problem solving. This is what shows us that after we've learned, we've mastered things. So now, guys, remember the question says equation, not equation. So you're not going to write A is greater than 0 or A is less than 0. Those are not equations. The word equations means equality. Left-hand side equals the right-hand side. But that's an inequality that we have there. So no one is allowed to present that. At the same time, we need to show a straight line. As we can see, there's plenty of straight lines here. So which one actually captures the position of A better than the rest? It's the horizontal line, isn't it? Because anywhere on that horizontal line, point A can exist. So this one is better than the rest, because others, they only put point A, in a specific position rather than anywhere. As we were told, this is on the Cartesian plane, so it can be anywhere in the first quadrant, anywhere on the y-axis, anywhere on the second quadrant. So the best line for this business is to write 3.7.1 that y is equal to 5. Okay, 1 mark for that. Again, that's a higher grade question, because students would not necessarily know what this means, or at least analyze. So this is why I'm giving you all of these things, folks, in a very calm and slow manner, so that you can assimilate this. It's not about performance at this stage on my part. It's all about making you better and stronger. This means even if you see a question for the first time, you should be in a position to sit back and be like, okay, what makes sense in this given scenario? Remember, it doesn't have to make sense to your marker or anybody else, but at least to you. What sense can you derive from what is given and what is in front of you? And as I can tell you guys, getting used to doing things the way I'm showing you, you start to become limitless. I promise you. But if you expect you're just gonna bump into the right thing, every time you get to one, you have another thing coming. This is why sometimes I do not really encourage students to obsess over the memorandums, because I know a lot of people will tell you, don't do any question where you don't have a memo. I don't have a memo for these questions. Of course, some I can recognize from previous exam question papers I have treated with my students, but I don't really care if I have the right answer or not. All I care about is, can I have a perspective about a particular question? And if I have one, I will put it to the test. Of course, this is when I consider different ways in which I can look at it. If they all agree, then I know I have an answer there. But again, you do this, guys, when you're not in a hurry and you're not facing an exam anytime soon. But when facing an exam, well, yeah. But don't get used to having memos before you can feel you've done it right. You have to know you are right by knowing exactly that you applied the right principles, because in the exam, you're not going to see a memo until you are done writing. So at the end of the day, this is why most of you guys fail multiple times, because you think you're going to have to see a memo to confirm. And now when you're not sure, what do? You end up, But again, guys, hey, I said, forgive me if I say things that perhaps make you feel, it's just my opinion. And as you can see, my opinion is very dynamic. It's not static. So, yeah, take whatever I say with a pinch of salt. At the end of the day, you decide who you're going to be. Weak, average, or good, or excellent. All right? Right. Let's do the last question here before I waste too much time. So we've got 7.3, not 7. I'm on when I'm on 3.7.2. If I'm on paper. Now you can see, guys, there is the suplex city. There is the suplex city there. For sure, we're going to have to sweat here. Let's see. Hence or otherwise. Wow. Okay. Hence or otherwise calculate the value or values of A for which TAQ is 45 degrees. Okay. Fine. All we know is that this dude, T to A, is a horizontal line. Now, if we take it down to Q and we are sitting at 45 degrees, so this means we need to think very hard. Let's say, for example, we assume that A is over here, just before the y-axis, but after point T. Do you see that angle? Will you appreciate that angle is not acute? Because this is the angle we're talking about. So we need to be very critical about this. Again, guys, there's no way you can solve this question in a hurry. Unless, of course, you've been copying and somebody showed you this beforehand. You wouldn't. So you can lie to yourself all you want. It's not going to work. You just have to work your magic nicely. We can see that this is not possible because that's an obtuse angle. And 45 degrees is an acute angle. So you've got the guidance right in front of you. So make sure you use it well. So we know that it's not possible for point A to be between point T and the y-axis. Could it be between this point on the y-axis and the point on this line that we showed? Let's say it's here. Is it possible? Well, the most likely thing that we can see, if we connect this, well, it's an acute angle, but certainly not 45 degrees. This is very close to 90 degrees. Again, this defeats the purpose of placing A between this coordinate and that coordinate. Whatever they are, at this point we don't care. We're just exploring our possibilities. So we say, okay, fine, how about between this point and that point? Of course, we're just looking. We're not sure. If we connect this to point Q, we see quite a very acute angle. This is suggesting that, my friend, we may have found you. This is possible to be the angle we're looking for. Right, so we can say, fine, this point A could be in this position. So we can easily call it A. Yeah, this is where A is. Okay, I'm just going to put it like that. That's where A could be. Because if it starts to be in those positions, we start to see something like 45 degrees. Now we saw that A cannot be the point again before T. And it is not certainly at T. So what about a point after T? If we connect that point, for example, we'll see that, okay, we have what looks like an acute angle also. So this is possible. Of course, don't worry about the triangle now not looking to scale at this stage. But these are the possible areas, meaning point A should be a point that is before point T horizontally. Or it should be a point between this intersection of our horizontal line. Say, for example, that point with NP as well as NP. Okay. So this is just the possibilities. At this stage, we're just looking. Of course, this is a construction. It's not there. It never was given. So these are just the possibilities. Okay, maybe the angle is fine. We can leave it alone. So that is what we have. So we are saying this should be 45 degrees. This should be 45 degrees. That could be. At this point, we're not interested about the scale factor. We're just interested in what is close as possible to what we are looking for. So now what are we going to do next, guys? This question. Remember that vertical, that horizontal line is suggesting something that, okay, this is the angle with the horizontal. If this is 45, if we were to draw this down here, we would still have 45. So the angle of inclination of each one of these lines, this and that, this would be plus 1 because tangent of 45 is 1. That would be minus 1. Tangent of minus 45 is minus 1. Okay. So that we could have. Yeah. But now we don't know where A is. All we know is that A has coordinates A and 5. And here we've got A and 5, of course. Right. Okay. Hey, the time is flying, guys. What can we do? What can we do? Of course, these are the types of questions that you just go past, okay? Don't obsess if you can't solve it. But if you have been practicing questions of a challenging nature where you have to place a point on the Cartesian plane and look for possibilities, this becomes a very fun question. Right. Now, let's see. Lord. I don't see as well as I should see, I don't see as well as I should see. Okay, this question is crazy now. We cannot have our time wasted, But here's one thing I propose we could do to get ourselves out of this mess. If, for example, we draw a vertical line, if we just draw a vertical line from point Q up to our horizontal line that defines point A, because point A can be even directly above point Q. Maybe we need to consider that situation where we say not necessarily point A, but what about a point directly above point Q? Maybe we can call that point, we've got T, N, M, S, K, P, T. So we can call this point R. Now, a point directly above point Q will also be perpendicular to that line of ours. It will be perpendicular because this is a vertical line and that was a horizontal line. Now, this could tell us that the coordinates of R is going to be the same as the X coordinate at Q, but the Y value is going to be 5, okay? That's something to consider. Is this going to help us do anything? It looks like it can help us do something. You know, this one looks almost like perfect. You can almost tell that this angle should be equal to that, because when that is 90, this is 45. That angle should be also 45. So this is good. So maybe let's change this point A a bit so that it looks close to 45 degrees as well, because there's something that is coming to mind now. We know that this distance right here that we have should be the same as, maybe something like that. That looks fair. It does. Let's say where this is, because remember point T is this point. So point A could be there. And of course we've got A and 5. So what about we say A is over there? So the angle looks all right. Of course, I'm not trying to draw it to scale, but it looks promising. Now we can appreciate that, guys. If that angle is 45, that one is 90, that should also be 45. Okay? That angle should be 45. And if that's the case, this simply means that this line should be equal to that line, should be equal to that line, right? Because those are isosceles triangles. So again, triangle stuff is coming back. Now I think our job is to look at those two triangles. Let's just look at them nicely. So if we look at those two triangles nicely, we will see that, okay, all right, okay. We've got 45 degrees here. Maybe let's put it nice and black. And that is also going to be 45 degrees. That is also going to be 45 degrees. Right. So this looks like we can do some trig ratios on each, because this is 5 marks. We can do trig ratios on each, or we can just do trig ratios on one big triangle. Yeah, we can do it, but the problem with that, the big triangle is not going to be very helpful in that we have an unknown A, so it's going to cause us a few uncomfortable problems. But if we split them like we have, I think we stand a very good chance of doing better. Okay, so to start this one, we need to be a bit constructive. We can say, well, construct as shown. Sometimes, guys, you know what? Some things are very boring. Construct as shown the positions of A and join those. What can I say? We can just say construct as shown on the diagram. Remember, guys, sometimes you guys are provided with a diagram sheet and you annotate it. Okay, there's no excuses there. Because you don't want to say a lot of words, because I can say a lot, But if I just say construct as shown, this is very important. You can just say such that R has, or we can just say such that R with the coordinates 1:5 lies, or maybe we can say is collinear with A, T, and A. Because we don't know where point A is exactly. Of course, guys, you know what? Yeah, but I'm trying to be as complete as possible. Oh, guys, 50 minutes. This is horrible. Right. What can you do? If you want to learn, you will learn. If you don't want, thank you very much, comrade. Go look somewhere else, where you can find quick answers. But in the exam, you're not going to find those. And you will cry. That I can tell you. If you don't have patience, you're always going to fail. If you're not going to fail, you're not going to meet your target. If you meet your target, it will be by luck. And you won't be lucky again. So be very careful, guys. Don't have things that don't make any sense happening in your life. Rather have things that you know, even when things go wrong, you can hold on to them. Right. Enough of that. What can we do now, guys? We can just say in triangle R A Q. Right? At least if we specify that, what can we say in RAQ? We will see that essentially the tangent of 45 degrees, right? That angle over here. It's going to be the opposite, which is RQ, over the adjacent, which is RA. So this implies, we know that 10 of 45 is 1. So this is over 1 equals RQ is y top minus y bottom. So this is 5 minus 1. So this is 5 minus 1. Let's just show that calculation to avoid too many small calculations. And then adjacent is going to be A minus 1. And then we cross multiply. So we will see that essentially A minus 1 is 4, right? Therefore, our A is equal to 5. Okay, so we got 5 above. So that means this point A can be directly below point N. So A is right below N vertically. Doesn't matter for now. As I can tell you guys, sometimes if you draw the sketch properly, you will get to the right region. As you can see, we got to the right region, but not exactly the right point. But what is nice is that a calculation that is done perfectly will correct us, will place us right where we need to be. Right, so A is equal to 45. We can say also in triangle, this is not nice, but anyway, we're gonna see. We can say in triangle A, let's just start with the A this time and say ARQ. I hope someone will understand which one is this. It's the blue one. We know also here that the tangent of 45 degrees here is going to be the opposite side, which is RQ divided by RA. This implies that 10 of 45 is 1 over 1 equals RQ is again 5 minus 1 divided by, this time it's going to be 1 minus A, right? So we cross multiply here. we get 1 minus a equals 5 minus 1. That's 4 times 1 is just 4. Therefore, a is going to be, so we transpose a to the one side, becomes positive, and 4 to the other side. So 1 minus 4 is minus 3. So that's it, guys. We've solved the possible values of a. Of course, if you have a better approach that is not as lengthy as this one and very labor intensive, because there's a lot to say, there's a lot to consider. Either way, if we do the right thing, guys, we do well. But I think what was key here was point R being placed on that line directly above Q, because that could have been a possible position for A, but it helps us to solve the problem. And of course, to then show a construction. At times, it becomes very cumbersome. So it's best to just say construct as shown on the diagram and make sure that the diagram is annotated accordingly. And this is done. All right. Okay. All right, guys. So this is how I would suppose we get these marks. For me, this substitution and answer is key. This substitution and answer is key. And I would say for the construction and stating the point R, it was a necessary step to follow. Without them, I don't think I would see any quicker way. But again, a second look, a third look, a fourth look into the same question can actually reveal some much sweeter and quicker ways to solve it. But at the same time, this is what happens in a fly. So you just have to freestyle as best as you can. Right. So this is it, guys, for that question. As you can see, those 25 marks at the end didn't go so cheap. Sorry, those 22 marks. As you can see, folks, this is a lot of marks. There is a lot of work. There is a lot to consider. And you can see questions can be quite complex. As you can see with that last question, if you're not a student who practices well, you will not survive that question at all. Because even that 1 mark, you wouldn't know what to do if you don't always picture things in a, wider perspective, not a narrow perspective. Right. All right, guys. So here is what I can suggest you look at. This is the question paper from November 2016. You can look at this question 3 from there and practice all these questions just to get yourself a bit more to working with different geometric figures and seeing if you can recall most of the Euclidean theorems as well as the trigonometry and algebra that applies here. Okay, so you can have a look at this question, and if you run into any problems, if you are one of my students who has access to our WhatsApp group, you can just drop those questions and my team can just destroy those questions for you, and hopefully you will understand within reasonable time. So try this question. I suggest you do it as an extra question 3. Let me show you another one you may want to try. You may want to try this question. This is February, March 2015. Question 3. Again, you can try these questions. As I said, you see the ones that I've marked red or black, whatever like that. You will find this document where I got these questions in the description, and I will leave it marked as I have here, perhaps to give you an idea of what you can try. This is if you don't know what you need to do. But even for those who know what they need to do, you may want to challenge yourselves with these questions, because if you are ready, you can chew upon this in an instant. Maybe let me suggest one more. Okay, here's another question. This is February 2017. It's the question 3 as well. So these questions can really push you to the limits, guys. So try these questions, especially for questions like 3.6, See if you can handle these questions. If you can handle questions of this nature, mind you, the supplementary papers are often the most difficult, because the questions there are always a notch higher than the standard questions you often get in November and anywhere throughout the year. All right, so guys, that's it for the practice that I can suggest for you. Of course, you can go wherever you want to go and do as many as you want. But the key at this stage is not to doing many questions, but is to ensuring that you understand your work and that you can perform at the necessary, you can perform at a reasonable level, if not at the standard level. And of course, you can surpass that by going a notch higher. Right, so that's it for the analytical geometric question 3 type of questions. Now let's treat the one with the circle. All right, guys, so let's have a look at this question 4. Of course, you can do many. I will suggest some again, like we did with the question 3. And I hope you will find these questions meaningful in your attempt to getting better marks. But remember, folks, don't think, a number of questions is going to make you better. What makes you better is understanding your work from studying, practicing long beforehand. And if you've been consistent, you should not worry. Yes, stress and anxiety is going to kick in. And these may try to suggest that you are not quite ready, but you actually are. So don't let those things don't let those things to derail you and to make you feel like you're not ready, because they will start to even shut down some of the things you already know well. So just know, man, you cannot control everything, but you can control most of what happens in and around you. Right, in the diagram below, O, the origin, we know the origin is the origin. And N with coordinates 2 and Y, again, we need to figure out how are we going to find that Y coordinate of point N. Are 2 points on the circumference of a circle with center M, right? Tangents at O and at N meet at R. So what do we know? We know that tangents from the same point outside the circle to the same circle will be equal in length from the point of origin to their points of tangency. Okay, only to their points of tangency from the point of origin outside the circle. Then after that, it's a different story. Okay, don't make the mistake of overly, projecting to that. Now, what can we do here, guys? Sometimes it's always very important to always ask that question. What can I do? Well, if I join the center to N, I'm going to see a perpendicular relationship. Same if I draw a point from O to M, that should be some perpendicular relationship, because the tangent is always perpendicular to the radius of the circle. Okay, doesn't want to do it nicely. Of course, these are not necessarily there, it's just a consideration. Now, as you can see already, the structure that I'm creating, the radii themselves are equal to each other. So technically, when I have a quadrilateral like this, where the two adjacent sides are equal, this is a kite. This is a kite. So we can already think of properties of a kite somewhere in the back of our minds, because this is what we're going to have to deal with. At the same time, this very same kite itself is a cyclic quadrilateral. Why? Because we can see that the opposite angles are supplementary. You see the angle at the origin and the one at N inside our quadrilateral. Those are 90 degrees, so they add up to 180. So that's a cyclic quad. Again, we may have to consider properties of a cyclic quad. So think about these things, folks. Just a little bit, not too much, of course. Now let's see, what can we do with this information? Well, this can help us to determine the radius of the circle. OM will tell us what the radius is going to be. Using the distance formula, of course, because it's a slanting line, okay, or a diagonal line, if you will. Right, and then what about the coordinates of R? Well, the coordinates of R, the way we can do it, if we need them, we will have to consider we will have to consider finding the equation of that line OR. Of course, radius is perpendicular to tangent. We can get the gradient of the tangent. Since we have the y-intercept at the origin already, this is going to be the line y is equal to perhaps some value ax, This is the type of a line that this is. So it's going to be some y equals ax, where a is the gradient. Right. So that's fine. Now, what can we do next? We may need to find the value of y. How will we find the value of y? This forces us to perhaps think of finding the equation of the entire circle. Because if we can find the equation of the circle, which we can, we've got the center, we will find the radius, so we'll have the equation of the circle. From the equation of the circle, we substitute point n. We will find the value of y. Once we have the value of y, we will need the equation of Rn. Again, using the radius here, we get the gradient, substitute point n, we will have Rn. So here we will have to use simultaneous equations to find the coordinates of R. Okay, so simultaneous equations are back at us again. Okay, let's quickly try and answer these questions as quick as we can. So we are asked to determine the equation of the circle. See, makes life easy. We have a plan for it. So we know that, well, the circle center M is going to be x minus the x coordinate at the center, all squared, plus y minus the y coordinate at the center, all squared, equals r squared. Now we've got a point on the origin. So we've got the origin here. 0 is to 0. So we will substitute 0 minus 4 all squared plus 0 minus 2 all squared equals r squared. So therefore our r squared equals 4 squared is 16 plus 4, that's 20. So this is going to be 20. So the equation of our circle is going to be x minus 4 all squared plus y minus 2 all squared equals 20. Nice and easy. Right, so writing it in this manner is good. The substitution and the final business day. R squared was a means to an end. Okay, so 4.2, we need to find the value of y. So we saw how we're going to do this. It's very easy. So we can say, well, with this equation, x minus 4 all squared plus y minus 2 all squared equals 20. When we substitute n, which is 2, is to y, what are we going to say? We will see that 2 minus 4 all squared plus, so y minus 2 all squared equals 20. Man kutheni ndikhe ndicimele isirashi ngathi vele kwenzekeni la. Hayi man. So this is 2 minus 4, that's minus 2 squared, that's a 4. We transpose, that's a 16, so we get y minus 2 all squared equals 16. Now we take the square root on one side. What we do to one side, we also do to the other. Right. So this implies that y minus 2 equals plus or minus 4. So therefore, y is going to be equal to, let's say y minus 2 is equal to minus 4. So when you transpose the 2 there, it becomes plus 2. Minus 4 plus 2 is minus 2. Or y equals, let's say y minus 2 was equal to plus 4. When you transpose the 2, we get 6. Now, which one is this going to be? Remember, this is in the first quadrant. So this means y here at n, because that's what we're looking for, should be 6. And we can even strike this one if we like, just to avoid trouble. So that's the story. So y is equal to 6. Because of the position of that point on the Cartesian plane. Right, so substituting this point into the equation was key. And of course, now this looks crazy. This one is, and that one is 3 marks. Maybe for rejecting that one, I don't know. You guys tell me about it. I don't know why this is 4 marks though. It's crazy. But yeah, if the answer is correct, the method is clear, we get full marks irrespective. Right, because we did not break the general instructions. They protect us to some extent. But remember, the local instructions take precedence over the general instructions. But when the local instructions are quite open-ended, like it is the case here, we then use our general instructions to protect ourselves in case we don't approach things the same way as the memorandum. That will be official. But if the answers are correct, we get full marks, provided we did not break the general instructions, at least. So let's go for it. So 4.3 says, determine the equation of OR. Again, a determination, it's an open-ended question, but of course we know once we look for an equation of a line, it's definitely not going to be by inspection, is it? Never. Unless we know something. Right. So we need the gradient. Then we know that's all we need because the y-intercept is 0. So we can just say MOR multiplied by MOM should be minus 1. Now we need to justify this. We know that the tangent is always perpendicular to radius. Okay, don't overlook these reasons, guys, because one can just guess that this is the case, but not knowing the reasons behind. So that can be an issue, especially when there's a suspicion of copying. Remember, always think of the enemies to your success. You may do well only to find that somebody copied. And now if you're in the same school as that somebody, you show up with answers that are questionable, you will have your marks retained. Be very careful. And you may find yourself rewriting because we cannot determine whether you did this without the influence that seems to be not acceptable here. Right, so we can say this is going to be y at m minus y at o divided by x at m minus x at o, right, equals minus 1. I'm thinking, okay, this is a different question, by the way. Yeah, we need to show the formula here. Right, so the gradient of OR times, we substitute y at m, is 2 minus 0, divided by x at m, that's 4 minus 0. Yebo, yes, equals minus 1. At this point, guys, we just go for the jugular. Do we need the gradient of that radius? Maybe, maybe not. I'm not sure. But I'm thinking that's all I can use that radius for. It doesn't help us with anything else, so we don't really need to show it. But let's just do it for the sake of saying if that is a mark and maybe we make a mistake, we don't lose this mark, because hey, guys, you never know. You may just perform some dangerous calculations here and then find yourself in trouble. So this can protect. You see, showing every step sometimes protects when the going forward is wrong, you know. So therefore, MOR is going to be, the negative inverse of this is going to be minus 2. Isn't it? Yeah, man. That's the one. That's the one. We can say, therefore, OR, that vector there, is going to be y equals minus 2x, because the C value is 0. So we don't need to look for it. All we needed was the gradient. Kuphela. Nje. Ha. Nazo ke mntwana isikolo. This is valid arguments. This gradient is key and our final equation. You hear? Yes. Because the essence of that equation was the gradient. But at the same time, guys, there's plenty of ways one can look at this. One may say, well, that rule doesn't get a mark, but one gets a mark, for example, substitutions, and then say a mark for the gradient and then putting the equation together. If the answer is right, the method is clear, full marks will be awarded. Okay, so let's look at 4,4. 4,4 says we need to calculate the coordinates of R. Can you see the instruction? Very clear this time. No manga business, but the real deal. So we saw that when we planned, we will need simultaneous equations to rain down on point R. And the best way to go about it is to find the equation of Rn. So these 6 marks, they look scary, but this is not a really difficult question. It's a standard grade question, by the way. Right, so we can say, well, we understand that the gradient of Rn multiplied by the gradient of Nm, we should get minus 1. Right, we know that the tangent is always perpendicular to radius. Right, we go on and say, well, the gradient of Rn into, this time we've done the formula above, we don't want to waste our time anymore. We can just easily say, well, we can take the y at n. The y at n we got, what did we get, Kanen? Did we find something? Here one, point, oh yeah, we got 6. So this is going to be 6 minus 2 divided by x at n, it's 2 minus 4 equals minus 1. Right, so we can go on and say the gradient of Rn into, just to protect ourselves in case we run into some serious problems. This is 6 minus 2, that's 4. This is minus 2, so 4 divided by minus 2 is minus 2. Okay, yeah, that's fairly steep. I accept. Hey, sendiyazibuza ngokuba kwenzeka ntoni phaya. So we can make the conclusion, therefore, that the gradient of Rn is going to be a half, right? And you can see there that it's much gentle and it's a positive gradient, so we can accept this. All right, we can accept it. Now, folks, what is this thing? Kiyona mang ntwena. Kiyona yona ntwani. Right, so we can say, well, this implies that Rn is y equal to a half of x plus c. Then we substitute point n, 2 and 6. This means 6 is equal to 1 over 2 times 2 plus c. This implies c is going to be, now this is 1, transpose we get 5. Therefore y equals a half x plus 5. Does it make sense? Yes. That y-intercept is somewhat lower than the y-intercept of n, but above point R. So that's okay. 5 is not bad. Yes, we may have made some bad calculations, but the answers are quite satisfactory. We can, to some extent, accept them. Right. Now, what do? We can say then, at that point R, we know that a half of x plus 5 should be equal to minus 2x, isn't it? Because the line of OR is equal to the line of what you call the line of Rn. So simultaneous equations, folks. No stories to tell. Right, this implies we take the minus 2 to this side, it becomes positive. So a half plus 2, then 2 by 2 is 4 plus 1, that's 5 over 2x. It's going to be 2, 5, right? Equals minus 5. Therefore, our x is going to be, now what do we do here? We're going to take, it's going to be 2. It's going to be 2. Sorry, minus 2. And that makes sense because that's where we expect a negative x value. Therefore, y here we can substitute into the simpler one, minus 2 into minus 2. Yes. And so this is going to be basically 4. All right. Okay. All right. We can see point R is a point above this one, but certainly a point below that y-intercept of the other line. So makes sense. It's 2, maybe 2 units above. We can accept. So we can then conclude that our point R is basically minus 2 and 4. Okay, so that's easy, guys, not complicated. So please learn how to structure your answers, folks, so that you don't get victimized because of illegibility of your work. It's not like when we say write legibly, we don't say write beautifully. Just say write in a manner that can be followed by anybody with ease. Yes. All right, 6 marks in the bag somewhere. So what we need is this gradient. Yes, and this substitution and that equation was key. The method of solving simultaneously, finding the x-coordinate and the y-coordinate. So 1, 2, 3, 4, 5, 6. Although we will still need to present our answer in the ordered pair. If we don't, there might be an issue. And we don't want to suffer if the examiners decided to be strict in that sense. So, again, this is nice. This is easy. No questions about it. Let's do 4.5. 4.5 says determine with reasons the type of quadrilateral presented in MNRO. What did we say? Yes, it's a kite. How do we know? Well, we just saw that a pair of adjacent sides are essentially equal. When we have a quadrilateral with a pair of the adjacent sides, meaning they have a common angle, or they emanate from the same angle or point, so they not angle but point, they come from the same point or originate from the same point. Those, once the pair is adjacent and is equal, and also on the other side, then we know this is a kite. So again, we were told to determine. We can just jump for the jugular. It's 2 marks, but then provide a reason. We can say KMNRO is a kite. How do we know? Because there's two pairs of adjacent sides. 2 pairs of okay, but I think we need to say something before that. We can say, okay, in quad MNRO. I think we jumped too soon. What do we know? We know that NM is equal to MO. Okay. These are the ready. Right? We can say also we know that Rn is going to be equal to Ro. What is this? These are the tangents. Come on, son. Son. We say these are tangents from same point. Okay. That's all. We can make a conclusion and say, therefore, MNRO is a kite. Reason, we can say 2 pairs of adjacent sides. 2 pairs of adjacent sides are equal. Be careful of mathematical language. You need to understand what do we mean when we say sides are adjacent, and what do we mean when we say sides are opposite. Be very careful. There's a difference here. Very different. But you see, sometimes the problem is it's very difficult to separate the two, because if you look at these two sides, if we were to draw OM, sorry, ON, then we could easily have NM opposite MO, but in a triangle, MNO. But since it's a quadrilateral, the opposite side or the opposite sides in a quad is OM, for instance, and RN. Those are the opposite sides in a quad. Adjacent sides is going to be OM and NM, or it can be OM and RO. Either way, we have our answers there. But someone may argue and say, but this is Euclidean geometry stuff. Yeah, the question said with reasons, man. So what do you want me to do? I have to say it. You get it? So, yeah. So if you asked me reasons, you're telling me Euclidean ways of presenting this answer. And again, I have used a lot of calculations here to understand what I'm looking at anyway. So this is good enough, guys. This is good enough. So it is a kite, and like that. Of course, there's plenty of areas to give marks. That can also be given marks. But again, remember, this is applied. Euclidean geometry is applied. We're not really looking for it per se. So it's more on the answer that we want this thing done. Literally a lot more about how we got there. Although we still have to show how we got there. Okay, so another student may sit and be like, well, this is analytical geometry. What can I do to prove my point? Well, if we construct RM and NO, what do we know? Yes, you do know what you know. We can see that these two, we can calculate the product of their gradients. If the product of their gradients become -1, we know that these are perpendicular because diagonals of a kite intersect at 90 degrees. That's the one. So again, here perhaps you're much safer using analytical method. But again, if a question said determine and it didn't specify how, There's nothing that stops you from using anything that you know in maths. Remember, this is maths, guys. It's not just a topic. A lot of you make a mistake of thinking, I'm writing paper 1. I cannot use theorems here. No, who said that? You are writing a maths paper. So when a theorem applies, you need to state it, because that's the only way you can justify for using it. And if you come here, analytical geometry, even though this is analytical geometry, no one said you have to write only analytical geometry related, topics according to the textbook or whatever. If the question does not dictate how you're solving the problem, you solve it by any means necessary. This is a maths paper after all. And bring that person to me who victimizes you for not using analytical methods. For example, using the Euclidean technique to prove what that quadrilateral is. And then they come and tell you, no, you are not supposed to use Euclidean geometry. Then tell me, why did I know a tangent is perpendicular to radius? Why did I have to use it if it doesn't apply? So there's a lot of gray areas here that a lot of people get trapped in, and they don't realize that this is not the case. A maths paper, guys, will be answered in a mathematical way, whatever that way it may be. Unless, of course, the specific question is clear that you are not to use anything else but a particular technique. Only then you can be victimized nicely, and I would support that victimization. In fact, I would inflict more on you and rain a whole lot of anger on you for not adhering to instructions, because then what are you doing? But if the instruction is like determine, and without specifying how, well, who is going to tell you how you're going to do it? At the end of the day, it's a maths paper. All right, guys, I'm a bit tired. That's why I'm talking a lot. So, folks, we can just imagine those chords. You may even, not chords, but diagonals. And we can just say, okay, fine. If you like here, you can just say draw diagonals RM and NO. We can say the gradient. We can say then M RM times M NO is equal to, now the gradient of RM is going to be y at M. So this is 2 minus, what was the value? We got minus 2, ne? Man, we're not using x values when I come. This is 2 minus, what was the y value, Paya? It was 4 at R. So that's going to be minus into, okay, sorry, minus 4, sorry, what am I saying now? Divided by the x there, it's going to be 4 minus 2 is going to be plus 2. We then multiply this by, at this point we can jump in, guys, because we've used a gradient formula somewhere in our calculations on this paper, so no need to waste time once that has been done before. But if you haven't, you have to show us, because we can't have a situation where we cannot see that actually you know what's right, so that you can be protected if there's questions about copying. Okay, guys, remember, this thing can hold you back even when you are just a victim of it, because you did not do the wrong thing, but because you present your work in a manner that is shaky and very questionable, under questionable circumstances, you will be punished for not doing anything wrong. Makes me remember when we were young. If you're working with some younger guys and you're older, and the younger guys mess up, do you know who would get the hiding? You, the older one. How can you let them do the wrong thing in front of you? But if you give them a hiding, you will get a hiding again as to why do you hide these ones instead? Okay, do you hide? No, why did you hit these ones? Why did you hit them? You were supposed to report them. You see this thing. And when you come and report them and then you get criticized, are you stupid? Why can't you control the situation? You're old enough to know what's right. So guys, I'm telling you, you just sit there, don't know what the hell you should do, and then you just make a decision and live by the consequences of that decision, no matter what they are. At the end of the day, whatever you do the first time around, when faced with a new situation, you're bound to be judged, wrongly sometimes, or rightly sometimes, or perhaps in a very confused way sometimes. But what matters is you learn to refine how you do things so that you minimize too much rubbish associated with what you did, but rather more positive reinforcements being put towards you, or at least even personally. But if you don't start, you will always be afraid, and when it matters, you're going to do something and someone is going to say something negative, and you'll be crushed for life. So you decide. You decide. You decide. Is it you decide or you decide? Iyole. Now, masiyenze naliyane ke ngoku. Thini le nto phana? Sithole bani pha? Besifumene u-6 napha phezulu akunjani? Bese sathola u-6 pha. Inamba enkulu. So phana ku-R ku-N ngu-6 minus u-0 pha kwi-origins. Bese siyayidivide ke ngoku, yayibona? Siyayohlula kahle kahle. Ukudivide ngesixhosa kwahlula ke mntana esikolo. Although ngesingesi xa yenza i-direct translation uzothi separation, but no, it's not necessarily separation or splitting. Xa sithetha ke ngoku mathematical language, xa kuthiwani mathematical, benifuna uthini ke ngosendibhudile, whatever, Xhosa mathematics. Division kukwahlula. Although isixhosa ke sintsokothile guys, igama elinye lithetha into ezininzi, funeka ulibeke kwintoni, kwimeko, as in the circumstance or the context. Funeka ulibeke kwimeko ethile ukuze uliqonde uba lithetha uthini. If uzavele uligibisele nje ngoba uyalazi uba likhe lisetyenziswe, uzavele nje ubonakale uba wena uyabhibhidla nje xa uthetha, awuthethi, uyabhibhidla, amazinyo abolile. Bese siyakuhleka ke thina, ungena impukane nakwezo gap kanye khona apho iphinde iphume. Yo, hayi mfana. Siba njalo man, sumatha. Matheleni. Sakunxelisa ipitikoti. No pitikoti. Kodwa ke seniyazinxiba mose ipitikoti ngoku vele ningasinxityiswanga. Hayi. Asingayapho. Ndizawuphambana futhi ngoba ke khona into endihlanisayo ngaleyo nto endiqaba uyithetha, kodwa ke andifuna uyithetha ngoba kaloku yeyi, social media le dodi le nto le. Abona ingathi iyasebenza ke hey, ke batlile ke bua ntho e mpe man. Wa bona he jwale e re ke ska iketla hobane ke tlo bua ntho tse mpe. Dintho tse ding busula, ba re ke tse di busula. Ha ke batle ho bua ntho tse busula mona. Ke batla ho bolala ntho tse monate man. Ntho tse monate mashotja. Wa bona mashotja jwale. Okay guys, andazi theni ngaqhubeki ngose ndiyabheda vele. Right. So this is 2 minus 0. And of course, what do we get? Now, I don't like to stagger my answers, but I'm going to do it anyway. Right. So this is minus 2 divided by 6. So this is going to be minus a third. If we look at this one, this is 3. So minus a third times 3 is minus 1. We can make a conclusion now that therefore we understand that Rm is can be perpendicular to Naumann. Yes. Yeah, because that is the one. And if this is the case, we can say therefore, again, I'm staggering my answers. We can say MNRO is a kite. You see a kite, not a kite, a kite. You see a kite? Yeah, that is a kite, this one. So why is it a kite? Because the diagonals, not diagonals, diagonals, meet or intersect. Diagonals intersect at right angles. Okay, or we can say diagonals are perpendicular to each other. Yeah, man, this one looks like analytical stuff, ne? But it's not a must when the question doesn't say must. So you cannot tell me that, hey, you're gonna solve it that way. I'm like, hey, bugger off, man. You're talking crap here. You cannot come here and tell me those things. Don't wanna hear that one. But if you tell me that I have freedom to say whatever I want because you allowed me to by the question you posed, so why are you trying to punish me now? No, it's not allowed. All right. Okay, all right. Nice. So guys, many ways of killing a cat as long as you make sure it's dead. And I can tell you though, it's not that easy to kill a cat. It's a serious situation to try. It's not an animal that is killable, but it can kill with ease. Right. Okay, let me not say it's not killable, but it's not easily killable. Right. How do we answer this one? Of course, this is a guide and the reason, and one may consider the analytical method, but we can say no man, you're talking nonsense now. This is the statement and the reason. It's a mark, this one. And that one, the calculation and the conclusion, that's the other mark. You see, it's like this, is like this, is like this. Right, guys, I will then highlight to you folks what questions must you attempt to try and fortify your ability to answer analytical geometry questions. But remember, they can be as varied as they can come. So keep an open mind. Don't lock yourself into thinking this is going to come. So don't even fixate on this. Rather fixate on the technique. And this technique is just showing you guys that you need to know things. And you need to know many things. Right. And there's a bit of luck, of course, in the exams. You always get some luck. All right, guys. So one can try this question, you know. Again, as I said, folks, the description is going to hold a document which has these questions I'm showing you. You can download it for yourself and, you know, enjoy some questions. If you don't know what to do, of course, but remember, be mindful of time. You also need some rest. All right. So try this question and see if you can handle business here. Although you may find yourself being asked a lot of questions, but hey, what can you do? But of course, a student who has been studying properly and has done term 2 well, students should be focusing on those types of questions because those are the questions that determine whether you're weak or strong. Otherwise, the others, they fool us into thinking you know maths when you actually don't. Right. Again, folks, here's another one that I think is quite interesting because it incorporates a lot of Euclidean geometry and you name the things. So try these kinds of question papers. This one is recognizable. I think it's 2019 or so, somewhere there. But work on these things, guys. If you run into problems and you are in our group, you are safe. But if you are not in our group, you probably are not as very safe as you wish. But again, you probably belong into some other kind of group. Even your peers, your classmates can assist. But remember, during the rush hour, which is the day before exams, nobody cares about anybody else when it comes to the students usually. Because, I mean, wouldn't be sitting there trying to study, trying to figure out how much you should do, and then somebody else here is trying to make you do their work, you know. But yeah, we the fanatics. I mean, I'm not a teacher. I am not a mathematician. You know, Moss. I am nothing. I'm nothing. Yeah. But I'm a fanatic. So if you have some ideas you wanna bounce with me, do so. Of course, make sure you do it early enough so that you can rectify those little things that you may probably looking for. And yeah, again, guys, these are trials. So this is just a pre-final exam technically. So you may as well use these ideas shared here to prepare strongly for the finals, because the trial may have escaped already. There's nothing you can do about it. It's too late if it is too late. Only a miracle can save you, and of course miracles do happen. But don't think when the miracle happens once, it's gonna come again. You have another thing coming if you think that way. Don't be like a lot of people who, I don't want to mention who they are, but they believe, you know, things are just going to keep happening miraculously. Well, yes, the teaching should be miracles do occur, and they can occur, but most of the time they happen when you least expect them. Sometimes when your desperation aligns with your wishes and your prayers, because your luck came right at that time, well, you may say, I prayed for a miracle and it happened. But don't think every time you pray for a miracle it's going to happen. No, that's a shortcut, by the way. And God hates lazies. He doesn't accept them in heaven. So think again. You see, when those pastors are talking crap in church, telling you that you're going to pray for a miracle all the time, no, it's not going to happen, guys. Forget it. Even when they align people in front there and they're saying they're going to pray that miracles and breakthroughs happen in their lives, guys, that's debatable. But again, maybe I'm looking at it wrong, you know. Sometimes I have a very bad perspective into things, you know. Some people may be offended even. But again, guys, if you're a fragile soul, I send one wrong mawulapha kule channel yam. Ngoba uzovela ukhale njalo, uzathi sokuthi ngathi bendiyiva mosile rubbish, ngose yaphambana futhi, hayi suka lo muntu uyahlanya, uzawuqumba ubaleke uphinde ubuye, uzaphinda ndifumane ndinje, andawuze ndife ndinje, ndizotshintsha, ndizawufa ndinje ngoba ndazalwa ndinje, nandizalwe ndiphaphile and ndizohlala ndiphaphile, andizonyaba ke ngoba abantu bafuna ndinyabe, hayi ndibe igusha ezawuthi ngoba kaloku yona ayizazi uba mayiyephi, ihlala yoyeme kwezinye, igqibela seyilahle nekhaya ingazazi uba indawoni. Sanuba igusha ibani ziibhokhwe. Yabona bhuti, e bohlale hampe. Okay, e re ke ska re hampe, e bohlale haholo. Ke yona tsela ya ho bua he eno, e seng hore bohlale hampe. Re rata hantle haholo ntho e mpe, and ha ke rate ntho eno hobaneng re bua ka ntho tse dimpe. Re bua ka dintho tse mpe nako le nako, le ha re bua ka ntho e ntle re tlo re e ntle hampe. Hobaneng o tlo re hampe ha o qetile moo? Ha o ya tshwanela hore hampe man, e re e ntle haholo kampa e ntle ho fetisisa, wa bona. Takatso tsa hao mohlomong ha ke tsebe, le wena o tlo ikgethela hore e ntle haholo ka baka la eng. Okay, ha re tjhong jwalo he, re ska re e ntle hampe. Jwale ke lebetse hore ne ke reng wa tseba, se ke le ntatemoholo ntate, ke ntatemoholo monyane, a re ka Sexhosa ndingumadala mbijana, futhi ndinempandla guys. Yho, xa ndiziyekile into lezam ndinempandla ebomvu apha ngemva enqentsu. Yes, indenzela iintloni le rubbish yempandla, ndiyazi man. Testosterone yantoni le ndenzela impandla ndingimancane. Hayi man, ke ntate phatlana jwale. Okay, a re itlwele he, ke le ntate phatlana ke le jwalo. Guys, those are the questions you may try, and you can contact me and we can talk about it through WhatsApp if you have my WhatsApp. But I may not respond always, guys, because I am busy with revision with my students at the moment. So I will answer, but if you're in the group, automatically you will have the answers. But if you're not in my group, you may not really win in the last minutes, of course. But going forward, you may win, because I have left my contacts, guys, on the description of my channel. So it's up to you if you use me or you don't. By the way, I'm user friendly, but at a pinch of salt, right? Yeah, be very careful. I can be dangerous. You know, most I'm from the Cape. You know, most what happens there. Dangerous stuff happens there. All right, guys. So there is another one that you may want to perhaps look at. It can help a lot. Okay. I mean, this is when you're feeling yourself a bit more and you're like, yeah, I'm taking down that 4.5.3. As you can see, is 7 marks, guys, and it's a killer, right? Right. So, folks, it's up to you what you do. As I said, this document is going to be in the description. This memorandum that I'm doing is going to be there. That analytical geometry document or whatever compilation is also going to be there. And the questions that I'm highlighting that you probably would want to have a look at are also marked there as you see them now. So do your best. I hope you're going to achieve your dreams. Now we switch gears to trigonometry. All right, guys, so let's treat some trigonometry now. So we're going to handle this Q11. Of course, guys, there's plenty of questions one can attempt. But, you know, key here is to just try and highlight as many things as possible. So a question that seems to capture much is very good. Remember, trigonometry, guys, is algebra. Think of it that way. Trig is algebra. Trig is algebra. Trig is algebra. You understand me? But what is so different about this algebra? It is in a geometric sense. Yeah. Now you get it. Now you get it. You get it. All right, guys. Enough of the nonsense. Let's get to business. 11.1. If sine 61 degrees is equal to P, so we know what we need to do here. So sine 61 degrees is equal to the square root of P, sorry, not just P. So we always show this as a ratio because remember these are trig ratios. And we know, we will be told not to use the calculator. Now if I can ask students, where is this angle 61 degrees? It's an acute angle. So it's in the first quadrant, unless otherwise stated. So we will have to draw ourselves a nice, you know, terminal arm diagram there. The terminal. So we call this the terminal arm, okay? That's the one. Right, so sine of 61. Remember, we know this is the acute angle, measuring it in the anti-clockwise direction on the Cartesian plane. So opposite over hypotenuse. So this is a standard circle with a radius of 1 centered at the origin. Now we will know that, okay, automatically, if not automatically, that angle, I got ipeni yami 10 ngoseyinga ndenzile umsebenzi omhle na kanti seyichaye ntoni banoyithakathile abana lezi updates, guys. Yabona ke hayi man bana yona ufuna ucaphuka ke tyhini yabona hayi man yabona 29 degrees. So that's the one, guys. So we need to work out all angles that we can work out and work out all sides. We know that x squared plus y squared gives us r squared. We know this through the Pythagorean theorem. We don't need a second invitation to deal with this, guys. Please. So funa ucengwa yenze lento man. Kavele uyenze ubone uba kuzakwenzeka ntoni. Kuzavele kwenzeka imimangaliso. Uzabona izimangaliso nje ezimangalisayo. Uve nawe uba umangele. Uyibona? Aso umangele. Hayi ke. Bese kumangalisekile. So x kangoku guys is about positive square root of 1 minus b. Why? Because that is the positive x-axis. So that point in the first quadrant has a positive x value. So that's the thing. So this thing I've just done, folks, is very important. But what is nice here, there's no instruction that says there's no instruction that says do this without using a calculator. But let's assume this is the question because it's often the question. But when there's no mention of a calculator, you will see something like this, which is again suggesting the same thing. You see, in terms of p. So this means no calculator, because how will we do this in terms of p if we're using a calculator? We won't. But we need the diagram. So it's another way of trying to hide the facts that we have to use the diagram. The diagram. So there is the diagram. Okay, guys, enough of the crap. 2, 4, 1 degrees. Is it degrees or degrees? Well, we need to show that this is the sine of 180 degrees plus something. You see, it's going to be 61 for sure. 180 plus 61. We get 241. Now we use the reductions. This is the third quadrant. This is minus sine 61 degrees. Now we use this one. It's going to be minus the square root of b. Because sine of 61 is p, right? So this one is easy. Guys, we always get a question like this that just seeks to have reduction formulae, whether cofunctions or same functions. This one, when it is led by 180 or 360, we use the same function. When it is 270 or minus 90 or plus 90 as the leader, it is going to use cofunctions. Key of the matter is that this is reduction formulae. So we'll always get a question that seeks to check if we can apply reduction formulae without being prompted, but seeing it for ourselves. So we want cos of 61 degrees. Again, we can see this is a direct question. Now that we have worked it out, it's going to be square root of 1 minus p divided by 1. So this is nothing but just the square root of 1 minus p. Again, there will always be questions as direct as this, provided there has been some working. As you can appreciate here, I did not mark this. This reduction is key. But we cannot just jump into that reduction, guys. We need to show that we did not use a calculator, although we did, but we need to show the method, right? If that is missing, get 0 ntwana. Skampotsa hore bani. Wa tseba le wena hore bani. No jwetsuwe mona hore o sebedise ntho tse itseng ka mona. Empa he ba tshoka hore re ska sebedisa calculator ho yona question ena. Ho tsho hore he. Le haeba o ka hlahella le minus sine 61 re sa mbone sine of 180 degrees plus 61 ho tsho hore ho lokile fela ntho re batlang ke hore ya mafelelo ka mane tlase mane e tshwanetse hore e be ka sa p le sotho se mpaleile jwala ke sa kgona le ho skwa hantle a ke tse o etsaetseng ho nna mona ha ke kgone ho bua hantle fela ke ibone ntho eno jwale he e etsahetse he tla etsa jwang nna ntho e bohlokwa ke hore re fumane x then re tle le answer ka mona ke tsona tseo he mmaraka wane o hlahetse kae calculating from Pythagoras theorem and then doing the things that we must to can be done wena sisixhosa esinjani izosithethayo sisixhosa esisingesi man zange wayiva loo nto lwakhona isixhosa sesingesi ikhona uba ayikho kuthiwa mna ke ndithi khona yayiva so 122 simthole kanjani 122 ndiyayiqonda uba khona inyakanyaka esiyenzile phana xa ujonga la 29 itsho le nto inuka la 29 ngqo 180 minus 29 leya nto leya heyi uyaxoka 151 lwana ke ngu-122 sidibana phi naye ngu-61 times 2 lo wana. Yeah, man, it's double angle identities. Now, questions like this, guys, as you can see, this terminal arm related questions, you're always going to get a reduction formula related question. You're going to get a direct question. See, reduction formula was number 1. Direct question was cos 61 degrees. Then we get some flavors of identities. So it's always like this. So that's just how one can anticipate questions here. But remember, as you have seen in the channel, there's a lot of ways we can ask questions in this section technically. So it doesn't mean that it has been asked like this all the time. It's always going to come out this way. No. Be open-minded. So this is the same as cos 2 times 61 degrees. Sesiyayibona ke ngoku. Space reduction formula. Now we want this in terms of p, so we need to change this in terms of sign. So this is 1 minus 2 sine squared 61 degrees. Okay, we're using identities. 3-step approach, guys. Yes. This is 1 minus 2. Now the square root here of p is like so. But now it's squared because we're saying that sign must be squared. So this is going to be 1 minus 2p. Igqityiwe xa nje. Ubungayaphi. Sawuzibone. Injalo njengoba injalo. Now, what matters, guys, is this reduction. And substitution here. And final answer. If not answer. Yeva yango. Answer cervicalis. Bazakuxelela abafundi anatomy of the human body. There's a nerve or a connection that is called answer cervicalis. Yabona amagama amakhulu ke lawo. That's Latin. Anatomy if ungayifunda xa ungabe uzafunda medicine. Usuyazi ke ngoku ndihle ndikuxelela ukuthi xa ufunda anatomy uyazi uba the normal is Latin. The disease is Greek. Hey, these people are very discriminatory. They made sure that the nice things, the normal things are called in Latin. And the ugly things and the bad things were given the Greek names and any other names that you can find. Wena, ayithatha planda. Ndifunda ezincwadini kalo. Funa ndibuza ntoni ngo. Tyhini. Xexa man, kuxexa. Khanixeke futhi ke phezulu. Now, this one says, hayi ke ngoku ndiphendule ntoni kanti apha yabona sendiphendule inyongo ke ngoku yabona imfetsi imfetsi angisatsanzi masekunjena ke mayi you see mayi sitsho zaselokishini yabona mayi sithi manje sithi mayi hayi mayi fits. Awunkeni. So, ngikhulumise Joe. Alright, okay, alright. So now you see, guys, be careful of numbering. As you can see, I'm doing this as if I'm writing an exam, although I'm explaining at the same time. Okay, this is to emphasize how these things are best presented. Of course, you've got options. You can just flow, like falling from the sky. Things are just floating all over the place. But sometimes some of you are taught that way. I don't blame you. Others just indlavini vele. Ubungazibonisa into right asoze ziyenze. Sawenza lento ezicinga. Aphezi kwabo zenze noba kanjani. Noma kanjani. Noma kanjani. Wedali wami. Ngeke ngikushiye. So fast lahlane noma bekujuka betha ugesi enokumlama ngikuthanda unjalo noma kanjani wena awuphi ngo awuselusana sansinxiba isinapkin. Right, cos 73 times cos 15 degrees plus sine 73 times sine 15 is 15. Right, now we can smell some compound angle identity. Cos, sine, yes, and yes. Right, now we sit and think, but we don't have 73 in these angles that we have. But obviously, if this question is posed here, it has something to do with these angles. Now we look and be like, 73 is something related to 29, is it not? Maske siyibone, 73 divided by 29 is like no. Okay, now we're like, okay, failishile lento. Now saphinde siyithini lento. Qala singazihluphi ngezi angles. Sithi okay, ingathi ezi angles zisiqhela kakubi. Kwenzeka ntoni apha? Let's first recognize this is a cos compound angle identity. No question about it. Because cos of the first angle times cos of the second angle plus sine of the first angle times sine of the second angle. So we can see that, okay, first we need to contract this thing using identities. So this is the same as cos of first angle. But now we always take the opposite sign when we contract it. So the second angle is 15 degrees. Like, all right. Okay. All right. It's negative 58. So this is cos of 58 degrees. Now you are like, all right. Okay. Now this guy comes in. Finally. Yawena man, konini sikulindile. Ufuna nje uspicisa. This is the same as cos of 2 times 29 degrees. Right. Now, what do we say here? Well, we still want this in terms of p, So we can use cos, we can use sine, who cares? At this point in time, I would rather we just go for the cos way. So this is the 2 cos squared 29 degrees minus 1. This is going to be 2 cos of 29 degrees. Remember, cos is going to be adjacent over hypotenuse. So this is now adjacent to 29. Right, so this is going to be now root p divided by 1, which is just root p, you see. Masivele singabusayifaka la 1. I got a masifake. Singabizi hooligans. Xa basiyithathe phi le nto scope. Right, root p divided by 1. Siyayisquarisha sithi minus 1. Sibe sesiphuma nayo ke ngoku impendulo phana. Sithi sino 2p minus 1. Gqityiwe ke ngoku. Gqityiwe. Nya. Sigqibile. Phelile. Right, guys, so as I said, folks, the reason I chose this question is just to emphasize the fact that question 5, it's usually question 5, is related to stuff like this. And most of the time, it is asked in 3 ways. Direct stuff like cos 61 from the diagram or any other angle that we can have on the diagram. It can come using reduction formulae. It's always going to have them, whether co-functions versus same functions. And we will have to really see some double angle identities as well as compound angle identities. As we can see here, the last question married compound angle identities as well as double angle identities within itself. Now this contraction, guys, is key. Nice and easy. And this expansion using double angle identities eventually is key, and the final answer. The substitutio at this point doesn't look very valid, but you might want to argue if you want. You see, Moss, it's a free country, this one. It's a free country, this one. Ungabamameli ababathetha into engekho ngeli lizwe. Alikho kodwa ke ilizwe elingenazingxaki zalo. So ke yeah, nekuyiqonde nale bakuzohlala kunengxaki apho kunabantu. Into engumntu inochuku xa ithanda, ingakumbi xa ifuna kwenzeka into ngentando yayo ngaphandle koba abanye abantu bacingela. Baninzi abantu abazicingela bodwa, yiyo loo nto ufika bethetha bengaphezi. Kodwa ke njengoba bazizibhanxa vele bathetha nje khona into itshintshayo. Into embi ke kuba kodwa baqalisa ntoni uchuku, sigqibela sesingavani nje ngenxa yabo. Mnandaba, nani ke nizezibhanxa uba niyilandele yonke into. Ke fanele uba nivele nivane kakhulu, bazovele bahlabeke babone uba nje bangophunguphungu nje. Right. Let's prove the identity. So again, guys, identities is part and parcel of the trigonometry that is expected. Okay, guys, let me not be too relaxed. It's time consuming lentolena. Now we need to just keep working. Cos x minus sine x minus the cos of x minus sine x divides by cos x plus sine x. We need to prove that this is equal to 2 times the tangent of 2x. Of course, the complicated side is the left-hand side. It has too many terms there. Now we can reduce this to that single trigonometric ratio. Sometimes you may get a question given the left-hand side and say simplify to a single trigonometric ratio. Sometimes you can put in this left-hand side and the right-hand side. Say take one side to the other. You see, this is the same question but asked differently. Sometimes you don't see it, you guys, but yeah, this is what it is. Sometimes when you feel yourself a little too much, you may want to take it from the right-hand side back to the left-hand side, and you can if you follow the right principles, but then you need a bit more logic, mathematical logic, to survive there. Otherwise, there's crocodiles on that river. They may break your legs. Right. So we will say the left-hand side is cos x plus sine x divided by cos x minus sine x minus cos x minus sine x divided by cos x plus sine x. Okay, now folks, we can see that there is a common denominator here. And the common denominator is not just a common denominator, but it's a common multiple, because it will be the multiple of the two denominators. So this is what we call LCM. And by the way, there's no such a thing called a common denominator, if you sit back and think about it. But again, you can twist what this implies in your mind and make it make sense. But in a true sense, it does not. And you can go cry about it or not. It still doesn't change. It does not exist. It's imaginary. Even that is ridiculous, because you cannot put any sense into saying LCD. I don't know why the new books sometimes they amaze me, you know. The new books amaze me a lot. And they are appalling, to be honest, to say the least. They are not quite attractive. The new books are ridiculous. Of course, to someone who is very enthusiastic about the subject and who truly understands the subject and who does damage in the subject. But you know, weaklings will always say it's all good and dandy because they don't know any better. So sometimes the sad thing is that people's ignorance is what flies around, spreads like wildfire over what is reasonable and perhaps best. But that's how it is. The world is full of, you know, misinformation, disinformation, and ignorance. Right. Let's go on. This is the one. Okay, so yeah, papa now. Teta la way pof. Anyway, so guys, when we divide, we take this and divide into that denominator. You will see this, and that will divide to 1. This survives the division. Then this we multiply to the numerator. So we end up with a basically cos x plus sine x all squared minus. And then we do the same. We take this whole denominator, we divide into that denominator, and what we literally do, we will see that that and this will divide to 1. This survives the division. We then multiply into the numerator, and we end up with just cos x minus sine x all squared. Some people would like to think of that if we have our LCM, we just simply cross multiply the denominator into the first fraction's numerator and that denominator into the second function's numerator. So technically one can think of it that way, that we do this because this is essentially the quickest ways to get business done if you don't know what's cooking. But sometimes shortcuts will leave you hanging. Don't hold on to them too much. Just know them as spices you can put in the meat. But you see, what is best in the meat is just salt. You cannot tell me that you don't know how to put salt in the meat. And spices. Those things are not salt, man. Aye. Those things don't make your bones strong, man. They don't make your muscles work, man. In fact, they do the opposite, man. All right, man. Yeah, man. Right, man. Okay. Right, guys. So this is a crazy question. As you can see, Kidi Maragaze 6. That means a lot of work. So this is going to be cos squared x plus 2 sine x cos x. Now, this is all quadratic stuff, guys. So if you don't know, you don't know, unfortunately. So that's that. And then this one is going to be minus into cos squared x. This is going to be minus 2 sine x cos x plus sine squared x. Ow, madoda. Yini man kundenza kanjena man. Sendenza so kaloku man. Hayi. You are not allowed, most, to do these things. I am the only one who's allowed to do anything because I don't account to nobody. That's a stinking attitude to carry in your mind. Never do it, never say it. So when you sort the denominator, that's a difference of 2 squares factorized. Now we contract this thing. We reverse it. So we always do reverse operations when we can. So this is going to be cos squared x minus sine squared x. Okay. Already we can smell the coffee here. Right. We already know, folks, that these are identities. This is an identity. This one. So cos squared x plus sine squared x, same angle. We've got squares on cos and sine. That's 1. So this is 1 plus. Now we can see that this is an identity also. This is the double angle identity of sine expanded. We can actually contract it as well. So this is basically the same as sine 2x. Minus. Again, folks, cos squared x plus sine squared x. That's 1. Square identity, grade 11. So we've got 1 minus. This is a double angle identity of sine. So this is minus 2, sine 2x. Right. So we continue. So this is going to be 1 plus sine 2x minus 1 plus sine 2x. So those ones essentially cancel each other out. So we remain with 2 sine 2x. Divisors. Now that cos squared x minus sine squared s is the same as, not s but x. This is the same as cos 2x. That's the cos double angle identity. Now sine over cos is basically 10. Can you see, guys, when you are systematic, you don't run around the place all crazy without a structure and form. And of course, those who attend and watch my classes, do they watch my classes? No, those who attend my classes already know how to see what to do here without going around in circles. Otherwise, it can be horrible, but sometimes you cannot avoid it. Now, Bafetsu, the technique of doing these things is mark worthy, you see, because LCM stuff, that's BODMAS, but sometimes it may not carry marks, you see. But this identity right here is mark worthy, cos squared x plus sine squared x. Every time we use identities, folks, that's a mark. That is a mark. That is a mark. That is a mark. Now it says means Naz's marks, but I think Leopala, no, it's not. This one is BODMAS, grade 8 stuff, not important. But reversing the difference of two squares is, so 1, 2, 3, 4, 5, you see? 5 marks, but maybe the square identity, we don't need to mark it twice, you see? Yeah, I don't think so. Right, but is there anything truly? No, the mark is here. And using the 10 identity. So let's see, 1, 2, 3, 4, 5, 6. Yeah, because that one was the square identity. We used it twice, so we're not going to give marks twice for the same thing. Yeah. Anyway, guys, 6 marks is in the bag. Whether somebody says this is done differently or it's done like this, it's fine. So siyenzile cutting. Yoba siyenze kanjani asinandaba nalonto. 11.2.2. We then have to answer stuff and say, or in fact, sendinga yonke inyaka nje perfect kanimmeleni yazi ndini wami. So fika kodwa ku-Euclidean makunje. Okay, I think ngizofika. If ndiyayeka uthetha. Let me just do ngo, okay? Right. Now, determine the value of x in the interval 0 to 180 for which the identity is not valid. You see now? When is this identity not valid? Now, guys, these are the things that can be very bad if one is not good. You see. This identity is not valid when 10 to x or 2 10 to x. In fact, when x is 90 degrees, you see, because 10 has an asymptote, so it's not defined, so x cannot carry that. But if you will, you may look at that denominator, but if you see that denominator as well, it's not so nice when you look at it the way you do, but yeah, you might think about it. But all I can say is that, look, in this case, we just need to focus on the right-hand side and say, okay, this, we know the tangent has asymptotes at 90 and 270, so stuff like that. So we know that this happens when 2x is equal to this happens when this is equal to 90 degrees, right? Plus k times 180 degrees. Eish, itheni ngolento yanibhayizisa ngo. Kutheni ngathi yanibhayizisa nje? No, 210x cannot be equal to 90, man. Sizoyithini? I think ayizospana, but ngibona 2 marks qha, guys, like seriously. But anyway, the question says determine. It did not say calculate. So at times you may want to just think about it, logically speaking, because there are some instances where you're not going to survive doing a calculation. Like you can see now, it's not happening. This is not happening. Yeah, it's bad like that. So let's see, guys. You can't calculate this. And in fact, if you calculate, it's going to be a long route. So I can just say when x is an element of, right. Is it an element? No, it's equal to a set. Yes, not an element. X is a set of these values, because a set is a different thing to saying it's an element. I think that makes sense. If not, go and read grade 8, grade 9 stuff. Or even before that, we talked about sets, I think in grade 5, if not grade 2. Can be confused between those two grades, and that's why I thought. Right, nice. We know that this thing must be 90. When x is 90, what happens here is 210 times 2 times 90. Uzobona izothi error, hayi 10 izothi 0 ngoku. Imake 10 uzonika u-0 ngoku. Okay, iba 45 ne? Yeah. 2 10 2 times 45. Yeah, man, iba 45. By inspection, guys, 45 degrees. Yabona usesiya inspect asinaxesha lalonto. 45 degrees. Enye nenye izazibonela uba mayithini indawo. Right. So this is a list of items. So we separate them with a comma. It's not a semicolon. See, a semicolon talks about a sequence of things in maths, at least for your grade level. A comma is just a list, okay? Right, remember this, because there may not be a sequence into this per se. Okay, when is this happening again? Multiples of 45, isn't it? Yeah, 45 times 2. But 290 akafuna uphuma nanto uza no-0, understand? Or because it wins 180. Because yenza 180, so 90 akaspani, usinikeza u-0, and u-0 is defined, so fine. So must you see 135 times 2, so sithi 210 of 135, because now that's going to be 45 times 3, right? Sibe sesithi leyana ke ngoku times 2 nayo, sithi mat error. So this is going to happen when this is 135 degrees, if not degrees, by inspection, because the question said determine. So we know any 10 function has restrictions around asymptotes. So we just think about where could these asymptotes be. As you can see, 90 is misleading if we use it, but 45 is very leading. We know why. Because the period has halved anyway. This thing now completes a period at 90 degrees. This means 45 becomes an asymptote. Or you can say the old asymptote divided by the coefficient of x in that function is going to give us 45. And that would be where the new asymptote is going to be. So there's many ways of looking at functions. But again, guys, I cannot teach you this, under the circumstances of a revision like this. But if we don't mention these things when we solve these problems, you will probably not get the idea, you see. So the purpose of the review is to try and give as much ideas as possible, so that whatever we may not get to in terms of a question in an exam of some sort, you can already think about how to deal with those issues as you see them come through in the exams. Right. So as we can see here, we know that 10 has asymptotes at 90 to 70. But now our function is saying 210 2x. So that means we just look at the new asymptotes for a function like that. You'll just say old asymptote divided by the coefficient of the angle x. That's 45. So already you have a solution there. This is just by inspection now. And you just choose multiples of 45 here. 90 will not work because that's when it finishes the period. And we know that the 10 function finishes a period in style, not in an asymptote. Yeah. Yeah, it doesn't finish it in an asymptote normally from 0 to where the period is on the positive don'ts. It's not an asymptote, the end point. This is why it doesn't work. So master these functions, you will not have any issues, guys. As you can see, the answers are just what is needed. How you did it, it's your own problem, okay? But those who are really, masters of algebraic manipulations, one will have to choose any one of these denominators. One may have to choose any one of these denominators, because if any one of these is 0, then the identity becomes undefined. So you can choose any of these denominators, equate them to 0, and solve for x. It will not lie, okay? It's not going to lie. But the easiest is to use that simple function, because we can imagine things there without calculating. But no one said don't calculate for 2 marks. You can, but you're not going to get extra marks. That's just the idea. Right, okay guys, let's not prolong that argument. Say 11.2, 11.3. So we've got 11.3.1. Given sine x equals cos 2x minus 1, show that 2 sine squared x plus sine x is equal to 0. Show that. Wow, okay. Let's take what we are given. So this is 1 mark. So we know that, okay, sine x is equal to cos 2x minus 1. So what are we going to do? We're going to do this. We'll convert this to sine. So we know that sine x is equal to 1 minus 2 sine squared x minus 1. Okay, we're using the cos double angle identity expansion, using sine because we see sine squared there. And then this takes us, but now this doesn't give me what I want, my lord. Oh, it does. We transpose everything to the right hand side. Of course, these two will cancel each other up because they are like terms. So when we move that, we get 2 sine squared x plus that surviving sine x, then we get 0. Don't see just 1 mark and think you're just gonna write one thing. Sometimes it's all about the stuff. Of course, this part here is what gets the mark, doing the double angle identity expansion. Then the transpositions and stuff is gymnastics a student needs to know. 11.3.2 says, determine the general solution of this equation now. Okay, now can you see this, guys? It's already taking us back to what we have. Sometimes the statement may be hence, because that sort of idea was just to help us to not struggle. Because if we did not, we would find ourselves doing things we don't need and end up not getting to a solution. So when the examiners know it's easy to get lost, they become a bit friendly. Say, okay, students, fine. We know you. But now we want the general solution. Maybe we can do it here. So let's see. This is sine x equals cos 2x minus 1. Which implies that 2 sine squared x from above plus sine x is going to be equal to 0. Now this is a quadratic. We take out the highest common factor, which is sine x, into 2 sine x minus 1 equal to 0. This implies that sine x is going to be equal to 0, or sine x equals a half. Okay, now we dance with the things. So when it's sine 0, sine of 0 is 0. And when again? 180. Right. And when again? 360. Okay, siyayibona ke ngoku le nto yakho. Itsho njalo, siyibonile, sesiyayibona injalo yonke le nto. Now guys, we need to bring out all these solutions. So we know that this implies that dx is equal to the shift sign of 0. So I'm going to write the solution. You need to know how to do this, guys. Shift sign of 0 is going to be 0. So this is basically 0 degrees plus k times 360 degrees. Or x is going to be, we say 180 minus 0. So this is just going to leave us 180 degrees plus k times 360 degrees. Or these other ones, x is going to be equal to, now the half is going to be 30 degrees, isn't it? So this is going to be 30 degrees plus k times 360 degrees. Or x is going to be equal to, we need to consider the second quadrant here. So 180 minus 30 is going to be 150 degrees plus k times 360 degrees, where k is an element of integers. So please, 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 if you haven't learned how to do general solutions, do it and bury it. So technically here, the 6 marks, guys, whenever we factorize, we know most, and we get these marks. So 1, 2, 3, 4, 5. Maybe to know that we can use what we have been using above. That's good enough, okay? Again, guys, there's no stories about general solutions. This is algebra, and most likely quadratics, and some special techniques. I did give a worksheet on trigonometry, guys, and trig functions. So if you guys paid attention, you will be in a very good position. But if you did not, it's your problem. So we have 1 degrees times 10, 2 degrees times 10, 3 degrees times 10, 4 degrees times times 10 of 87 degrees times 10, 88 degrees. I didn't know 10 go tabhaliswa la way times 10 of 89 degrees. Okay, so as we can see, the angles are increasing by 1 degree all the way until the end. Right, now we can see that the last thing is odd. Very important to always notice that from 1 degree to 89 degrees, that's an odd number of, degrees added in a natural number system type of thing. Okay, so what are we going to do here? We said the examiner is looking for the answer there. So we can say this is all equal to. Okay, first and foremost, what can we do here? We know that 10 of 1 is basically the same as sine of 1 degree divided by cos of 1 degree, times 10 of 2 is the same, sine 2 degrees divided by cos 2 degrees, times 10 of 3 degrees divided by cos 3 degrees, times 10 4 degrees divided by cos 4 degrees. Then this happens. Now the issue comes here. Now as we can see, we're given the first 3 terms and the last 3 terms. Now we need to manipulate these last 3 terms, perhaps to make them look like the first 3 terms. So we know here that this is the same as sine. Now 87, we need to use cofunctions here, at least That's the idea I get in mind. So this is the same as 90 degrees minus 3. Do you see what this is now? Oh, right. Okay. So this is the same as divided by cos 90 degrees minus 3 degrees. Right, times. This one is going to be sine of 90 degrees minus, of course, 2 degrees divided by cos of 90 degrees minus 2 degrees. Right. Maske sithi uyinciphisa. Qale sithi bese siyayinciphisa kancinci. Eish. Yabona. Ayifuna uncipha masiyeke. We can try to squeeze this one. This is going to be sine of this is 90 degrees minus 1 degree. Okay guys, I hope you can see this is cos of 90 degrees minus 1 degree. Ne? Yeah. This is equal to, this one stay as sine 1 degree divided by cos 1 degree times sine 2 degrees divided by cos 2 degrees, tan 3 degrees divided by cos 3 degrees times tan 4 degrees divided by cos 4 degrees times. Now we can use our cofunctions. Now 90 minus is going to end up as cos 3 degrees divided by, this is going to end up as sine 3 degrees times. So this is cos 2 degrees divided by sine 2 degrees. This one is going to be cos 1 degree divided by sine 1 degree. Iyo ke ngoku lento seyabonakala. Okay. After this konje bekukhona sabo something here. Masingayilibali. So there was supposed to be some and then siya multiply. Now folks, you can already see that when we multiply fractions like this, if we have something on the numerator and something on the denominator, eventually they will divide to 1. So this divides that to 1 because this is a product. And this divides that to 1 because this is a product. Same story, guys. Yeah. I'm 10 not 10. I wanna sunphaphela wena. 10 uyangiqhela. Hayi manisaphinda futhi. Yo. Sendiyozela guys. Afanele ndiyolala ke ngoku. Sekufanele Euclid yenza nini? Ngitloyenza nini njalo? Yabona ziyasuka nje. Telescoping effect of some sort. Now umbuzo zizawusuka na eziya? Asazi sizobona. Kodwa ezinye sesiqinisekile ngazi ba zizawusuka. This one is also salia. Now the question is about this friend of ours. Is this friend gonna go? Well, now from odd to odd, what is this? This is odd numbers. Ne? From 1 to 89, this is odd. Now folks, we always have to think about shortening this thing. Let's say we had to, now I want to see, we want to take an odd number of these things and see what happens. Let's say we take the first 3 because the total was odd, isn't it? From 1 to 89 was odd. Let's take ngathi ufuna ungichana kancinci konje sayenza njani nalento. Sayenza njani? Because we can see there's a telescoping effect of things, but if this number is not even, what's gonna happen? Is everything gonna go away or is it not? A sun. Distakile ke ngoku, but I want to believe everything is gonna go, but remember it may not go. So don't be fooled. The telescoping effect is quite attractive here, but we need to be sure here. Okay, let's just consider maybe not 3, but let's say there's 9 things here. Got 1, 2, 3, 4, 5, 6, 7, 8, 9 for that matter. So we've got 9 issues here. And we know that this one takes the last, this one takes the last, and then like the next one like that, that one like that. So do you see there's something that's going to remain? Something is going to remain here. But now, what remains is in the middle. Very middle. Now these things are 89. So what would be in the middle? Let's say we had 9. How many terms before 9? So we had 9 terms, and then we know that 1, 2, 3, 4. We had 4, 4, and there is a middle there. So if there are 89, there's going to be what? How many terms are going to be there? Ish, guys. But you see, a smaller model gives us a better perspective that the very middle term doesn't go away. But now we need to find out. Now 89 divided by 2. Of course, we can just do that because this is the same as saying 9 divided by 2. If we say 9 divided by 2, we get 4,5, right? So 4,5. 1, 2, 3, 4. That becomes the 1. Of course, what do we add now? Do we add 1 or do we subtract 1? Because it love to calculate the middle term that are ordered in this thing. You see that statistics thing now. For me. If what the middle term is going to be a half of n plus 1, isn't it? So it's going to be half of n plus 1. Let's see. As you see, test. It's half of n plus 1. Itin kanje masibone 1 over 2. Or n upper by 9. Sitting with 9. Space city plus 1. It's negative 5 indeed. The position of our middle term. So it's about 5. So we can use the same formula here to picture what would be the most middle term. So sorting band can go half of n is 89, and it's 1 from 1 to 89, so by 89 plus 1. Masbonic. So this is going to be 0,5 into 89 plus 1. So this gives us 45. So that means the middlemost term here is going to be 45. Can you see? So this is very interesting. Now, what do you know, guys? You know that basically sine of 45 degrees divided by cos 45 degrees is the same thing. It's 1 over root 2 divided by 1 over root 2. Now, when we sort this out, it's going to give us 1 over root 2 times root 2 over 1. And can you see that also goes to 1? So sine 45 divided by cos 45 is the same thing. Because even in terms of cofunctions, those things are just going to convert into one another. And that is 1. So the middlemost term, although it survives, it still remains 1. You understand? So at this point, we know that everything goes away. But I don't know if we need to mention this, but we know that, okay, this friend here will take something else out, and we will end up with a situation that says we've got 1 times sine 45 over cos 45. Now, at this point, it's quite horrible. So this is 1 times 1, which is just 1. This is just to say we understand that there was going to be a survivor here in the telescoping effect of all these terms, if you will. Or we can say items in the product. But there would be a survivor. But this survivor is so favorable that we can chow it. As you can see, guys, integration of topics helps a lot. Sometimes you may think doing statistics is a joke. As you can see, it has helped us now, because we were trying to find things, and guess what we got the idea from? Just making a smaller model and studying that, and we can apply that into the big model, and we have our solutions going, because we are able to test things in a smaller scale and be comfortable with things, and then we can apply them into the larger scale, and we know we're gonna cook instead of being cooked. All right, guys, so in essence, folks, this is just to say, please, folks, know your stuff, and there's no excuse for not knowing it. As you can see, this is a higher grade question that demands a student who is well aware of the subject and not scared of a challenge. Those who are not well aware, they will definitely flinch here. And you know, most, if you flinch, you miss with the gun. If you don't flinch, you stand a chance of hitting the target. All right. Right. So that was a nice question otherwise. All right. So folks, where is this thing? We know that the thing is here. The thing is the core functions. Setting up the core functions was key here, but now everything is going to be 1 mark. Knowing that this friend is going to survive, I think that is good enough. And knowing that everything as a result will telescope to 1, I think that's fair. And essentially the answer. Although, guys, there are many ways one can decide this is to be marked, but as long as we understand our stuff, we are fine. Okay, we are 100% fine. All right, so that's it for that question, and we walk away with those 29 marks that are essentially not as easy as one would wish, but it's not about wishing, it's about doing. So guys, trigonometry, I like that this question was packed with everything that's needed. That often is there. We had trigonometric identities there. We can see that terminal arm diagram was cool. We had general solutions. We had, that's a way of getting points of intersections between 2 graphs, by the way, which is nothing but simultaneous equations in trigonometry. And we had some simplification here, which came in a very strange way. It's not so common, but you can see that it was asked in the past. It has been asked recently, and it can be asked again. So please know your things, folks, and know them well. All right. Now, folks, I will tell you some examples that you may want to look at, and hopefully it will help again to fortify your course here, whether for these exams or for the final exams. This video will still be relevant for preparations, and don't think looking at a ton of videos it's gonna be okay. No, that's passive learning at most. So try to use just one little resource that you have for the most benefit. Then you can use these others as a way of keeping the lights on, you see, effortlessly. Anyway, let me show you what you can do now. So guys, you can perhaps have a look at this question. Just see if you can find some ideas about them. And of course, if you get stuck and you're part of our group, you can just shoot your frustrations about this question and we can have a look at it. As I said, for the analytical geometry, this document will be in the description by the time this video premieres, which will be probably in the afternoon. So I'll perhaps premiere this video at around, say, maybe 3 p.m. in the afternoon. I think that would be the best time. It gives everyone a chance. I'll try to not make this video too long, of course, but I will not do all these examples to avoid wasting time. This is for the student. I've shown how things are done. Try to apply that in these kinds of questions and see what you come up with. Right? Try that one. You will find this document in the description with these highlighted suggestions. All right, guys, so again, here is another suggestion. Students, please do these suggestions. Trust me, there's nothing that beats trying something that you just come across without questioning it too much. You will be surprised how so many of these things will have some similarities with what you're going to face. But sometimes don't hold on too much on what you saw already, but focus on how you've done the work more than what you've done, how you've done it, and why you did what you did. That's what matters here. Again, if you're in the group, you happen to do this and you feel overwhelmed, talk to us. I've got very bright students in that group. They will give you answers like that. Okay, so I'm happy to have such a bright bunch of kids. In fact, these are not kids, you know. Yeah, they're not. These are young adults, essentially. So I'm very happy and I feel blessed, you know, to have students who are capable of standing their ground. That is very easy. It makes my job a lot easier, you know, because I don't have to then explain everything. And when I do it, I'm just making sure that they are forever clear. Not that they don't know or they wouldn't know. So throw it there, guys. Someone in the group will know what to do and perhaps give an answer. And don't shy away, guys, of giving an answer, even when you're not sure. You don't have to be right. As long as you give a perspective, it can actually enlighten the very person who's frustrated, because you may have a half-cooked idea there. And that idea might just be what they needed to solve the problem. So it's not about really solving, it's about sharing ideas so that people can have a better way of looking at things. So again, you can show us what you're struggling with and we will try to assist. I will also try not to sleep before 12 midnight, but after 12 midnight, guys, you don't pose questions and expect an answer. If you pose the question, I'll probably answer it in the morning around 5 a.m. when I wake up. Okay, so I may still answer, but I may not within the time that you need the answer if you ask after 12. But before that time, I'll try to stay as awake as possible. And yeah, after the class, as tired as I will feel, of course, but I'll still be awake just to make sure you guys don't go and botch that exam. Right. Okay, guys, so one can try these questions as well. This question 8 and question 9. These are very nice to look at. And I am sure, folks, if one does these kinds of questions, especially these ones I'm suggesting, folks, if you can handle these with comfortability, you are ready for the exam. If you are not, this means you need a strategy for that exam. Okay, we'll talk about the strategies that one can use depending on their level of preparedness, and hopefully that might help to just make you survive the exam at least. Because if you can't win, at least survive. Right. Okay, guys, now we are done with this. We're going straight into trigonometric functions because that's a topic that we need to know. All right, guys, so let's get to trig functions. Okay. So this is going to be this question 7. So I'm just writing this question so that if you perhaps download the document in the description and this memo, you can actually recognize what question it was and yeah, do the things that need to be done. So we're given in the diagram below the graph of f of x equals sine x plus 1. Now we need to study this. Of course, guys, I'm not going to go into too much detail. I've already done this a lot of times in the videos when we were doing full papers. I don't know, my tablet is misbehaving. Maybe it's tired, I don't know. Now we can see this is the standard sine function shifted up vertically by 1 unit. So we expected the maximum to be at 1. It's going to be at 2 this time, and that's what we see right here. And the minimum will do the same. It was supposed to be at -1. Now when we add 1 to that, it goes to 0, and we can see that is the minimum now at 270. So that's where we would get a minimum, which would be minus 1. Instead of being here, it has moved up to there, right? Same with minus 90, it would have been here, but now it has moved up like that. So easy. Now it's drawn for the domain of minus 90 to 270. No problems, no issues. Right, maximum is at 90 degrees as we expect, so that's good. Now 0 was supposed to be at 0, it's going to be at 1 because everything shifts up by 1 unit. So we go on. Is there anything else? Coefficient of the angle is 1, so that means the period remains 360, so nothing changes in the period as well. Right, let's get to the answers. So 7.1, we are asked to write the range of f, so we know that the range is going to be a set of y values such that y is between and including those constraints 2 and 0. But we can state that y is, however, an element of all real numbers. So this is the more complete way of writing a story like that. Of course, you can do anything else somebody else teaches you or tells you. Right, 7.2 says show that sine of 1 plus x is equal to cos 2x. 2 marks, are you serious? Show that sine x plus 1 is equal to cos 2x. Sorry. I was wondering what's happening. I am not finishing the question. So it says show that this situation can be rewritten like this. Of course, you can clearly see this is to help us deal with the points of intersections between the two graphs. Okay, so let's write it. So sine x plus 1 equals cos 2x. Now we can clearly see that we have factorized here. And what we factorized is essentially, hey, let's go back. What? There was a question that we factorized. Did we do the right thing? Yeah, it's similar to this question. Can you see? Hey. Because if we take 1 to the other side, it's exactly this function that we have. Wow, what a coincidence. And can you see, we then factorized it like this. So this is exactly asking us more or less the same thing. But here's the problem. I can see that, yeah, man, there was something cheeky here that I did. You see, I ended up with a negative here, which is not supposed to be the case. This was supposed to be a plus. Okay, again, that was just a silly mistake, guys. So this was meant to be minus a half here. Okay, so minus a half. So we can see that when is sine negative in the third quadrant and fourth quadrants. But now let's go back to that question actually. So there is our lovely question, guys. So we messed up here a little bit. We messed up a little bit. It was just general solutions, so we don't care about quadrants here. Right, so just general solutions, great. So now we just have to make adjustments now. This one becomes minus 30, which is an angle in the fourth quadrant. Minus 150 is an angle in the third quadrant. So that's it. Just need to insert those negatives. Not a lot to change. Okay. All right. Okay. Apologies for the mistake there. But it's not that costly. Now back to our question. So this is more like us repeating what we did above. So can you see sometimes these questions repeat in a different sense, but same things after all. So this implies that sine x plus 1 is equal to cos. We can say this is 1 minus 2 sine squared x using our identities. Then we move everything to the one side. So this is going to be 2 sine squared x plus sine x plus 1 minus 1 equal to 0. This implies that we will have 2 sine squared x plus sine x equal to 0. We then factorize, so this is going to be 2 sine x plus 1 into, we just have to write it the way we are asked to write it. If we write it our own way, this means we are not adhering to instructions. You see, these kinds of things are very strict. So be very careful. When something is shown in a particular way, we need to present it in that particular way. Although we know that multiplication is what property is this? It's associative. When the order doesn't matter, and this libel. Again, learn those things from grade 8, guys. If you forget, go and revise, so that you are a walking textbook. Okay, you must carry that textbook in your head. You can't carry those emijolo enhlobeni yakho. Carry izinto zomgosi, politics, media, social media, public figures. Forget about those people. What you need to carry in your head is the book. That's your responsibility, and you need to do chores. You cannot tell me that you're going to be this type of a student who says to their parents must, do all the work and all they have to do is to study. What kind of an adult are you going to become? One who just zooms into one thing and cannot do what is important. Remember, you still have to live life despite any responsibilities you may pile on your shoulders. Of course, it's all your choice, by the way. Nobody forces you. So we cannot beg you to then do what you chose. No. You choose what you choose, but still, remember, you have to live. If you're a child in a home, you're going to sweep the floors, you're going to mop the floors, you're going to polish the floors, you're going to wash them dishes, you're going to cook, you're going to wash your clothes, you're going to make your bed. And all of these things you're going to do while you also find time to study in between. A smart student would study early enough to then feel tired at the right time to do a certain task, like making your bed, cleaning the house, making breakfast and stuff. So you wake up earlier than the time you wake up to do those chores. By the time you get to that time, you would be tired of studying whatever you're studying. Then you do those chores as a form of a break. That's a healthy way, by the way, to do things, because that kind of gives you a complete distraction from books. At the same time, it's not too, should I say, it's not misleading, or can I say, it doesn't strip you away from the main course. Because when you're doing chores, you're actually doing what you know and you understand, and you don't really have to now start wasting time with other things that will exhaust you. It kind of replenishes you. By the time you're ready, you're panicking. Okay, I'm losing time. But you've done most of the chores. Then you go back. Then you feel like, okay, I cannot go on anymore around 12 noon. At that time, at least your parent, they would also be friendly, or your siblings. They would decide, okay, we're going to cook lunch for this freak. All you can do is just wake up, you stop, you wash your clothes, or just a few. You don't need to wash all, just wash those that you need for the week. Then as they hang there, you eat your lunch. You come back, you are fresh, you are ready. You keep going, Come supper time, you can stop studying and cook the supper yourself. That gives you a healthy distraction. And then you do whatever is necessary, you chat to the family, you sit at the dinner table, you eat, all is good. Then when everybody goes to sleep, you go back to your thing. I promise you guys, there's no way you won't win. I've done this thing. done it. Go ndingumfana bendisenza konke okendikuthethayo ekhaya. Sathi sesibhala i-finals mfana wam sabe sisamente endlini pha. Ndandifana bengidaka boy, xova isamente. Izandla zirhwexa kwedini, zazirhwexela naphezu kwamaphepha e-final. Sasilungisa indlu, sasisakha indlu ekhaya nobhuti. So ndandingudaka boy, alibeke ebondeni udaka. Phinde ndincedise sometimes kwenza kube fine. Sifake ii-tiles, ndathi ndigqiba ii-exams sabe siwugqibile nomsebenzi wokulungisa indlu. Bethu uDisemba sandisipholile, indlu nee-tiles, isamentiwe, i-bathroom is-sorted. Sekumnandi ngathi akuzange kwenzeka nto. Sendifuna ukuthi ke guys, hayi indaba ye-excuses zoba xa ufunda uzusebenza ekhaya kuba dom konke nje lo. Kuba dom nje okungapha kokuqonda. Kho mntu uhlalela ukufunda. That's why you make the worst adults. Because nina nifuna ukungenzisa umsebenzi obalulekile. I-chores guys angeke uzibaleke. You can't. They are just a way, a healthy way actually of not distracting yourself with other things that can actually derail you completely. Because once you start watching movies and then start, watching social networks and all the rubbish that is in there, that thing, guys, has a tendency to have a negative effect on your studies because it makes you feel like studying is torture now. Because you can't do something that is nice as a form of a break from doing something rather very demanding like studying. If you start doing nice things during the study sessions, you're playing. It's not gonna work. You just feel tired more by the time you have to go back. In fact, you're going to hesitate to go back. When you do, you're not gonna last. So I warn you folks. But again, you choose. Right, we've done the things. 2 marks only. Yeah, where is the mark? Is when we convert this. The second mark is realizing that we have to factorize because factorization gives marks. Okay, right. Okay, so 7.3. Now, we need to determine the general solution of this thing. Can you see, guys? We've done it above, but we have to do it in this context now. Well, we know that sine of x plus 1 equals cos 2x is the same as 2 sine x plus 1 into sine x. We don't need to now go into, we don't need to go into the things. We just go for it from here. This implies that sine x is minus a half or sine x is 0. So we can say therefore x is equal to, the question said determine, guys. You see, that's why I'm not going to waste time. But you should know what to do here. This is going to be minus 30 degrees plus k times 360 degrees, or x is going to be minus 150 degrees plus k times 360 degrees, because this is when sine is negative, right? So, or we can say x is going to be 0 degrees plus k times 360, because we know sine of 0 is 0, or x is going to be 180 degrees plus k times 360 degrees, where k, epsilon, most those things. That's it. That's it. So easy 4 marks here. So essentially these solutions, nothing else. Okay, that's what matters here. Right, so 7.4. We need to use the diagram on the grid, right? Now we're going to use exactly what we have to draw the graph of g of x equals 2 cos x for the interval that we were given. So this is easy, guys. If we know the standard cosine function, we can see here the only difference to that is the fact that the coefficient of that angle is 2. So this means this graph is going to be a lot, it's going to complete its cycle at 90 degrees, not 90, but 180 instead of 360, because we have the period. Right. So we know that cos of 0 is 0. Sorry, cos of 0 is 1. So it's going to start at 1. Then at 90, it hits the x-intercepts. But now, what's going to happen? The old divided by 2 is going to lead us to the new home, 45, right? Right. And then we know that essentially the next point was going to be at 180. Now 180 was going to be what? A minimum. But now this is going to be 180 divided by 2. The minimum comes here. Then the next one was going to be at 270. It was going to be an x-intercept. Now we divide that by 2. It takes us to 135. So folks, when you know these things, you know these things, right? Right. As you can see, this graph is just doing the things. Again, there's no questions about what should be done here. Right. So this is what we have, guys. If you know the cosine function, you're not going to flinch here. Let's just connect the dots. All right, guys. So there we have it. So we've done the graph. Again, when you know this, it's very easy. If you don't know this, guys, it means you have not been looking around my channel and everywhere else, of course. So please, guys, make sure you are aware of things. Of course, certain things I've exaggerated here, but it doesn't matter after all. Right, so the graph is there and it's the right shape and how we expect it, okay? Good. So we can see that intervals of 45 degrees gives us the critical values for this function instead of the original 90 when there was no manipulation. So of course, guys, we get 3 marks for the shape. We get we get a mark for the shape. We get a mark for the end points usually. And then we get a mark for any of the intercepts, all right? Including minimum and maximum. Sometimes it may be a mark for the shape, a mark for maximum and minimum, a mark for, the intercept. But the endpoints are usually also very important to show. Right, so we can just say C sketch or C graph. Right, so we get our 3 marks here. Right, so let's see, 7.5 says, determine the value or values of x for which f of x plus 30 degrees is going to be equal to g of x plus 30 degrees in the interval that one. So you can see that the points of intersections here are very clear and very loud. There's this point of intersection here. There's that point of intersection there. But then there's these silent ones we don't know how to interpret. So there's that point and that point. So our job here is a bit hectic in that we need to find those points. What are they? But they're not too difficult after all, because we have our general solutions. These general solutions are going to help us, right? Right. So essentially, just before 45, that should be minus 30, right? Because we can see that this general solution is giving us the vibes, and we can see that this is almost, of course, the graph is not to scale, but if we get to take this point back, you can see it's almost halfway. If we draw a parallel line to this one, so if we just draw a parallel line, you can almost picture that this is halfway, almost halfway. Of course, we didn't draw this properly, but who cares? So that should be 30 degrees. So we know that, okay, friend, you look nice, and we also like nice things. You can say, nice things, this could be minus 30 degrees. Minus 30 degrees. Okay, that should be the one. So we can see, okay, not so difficult to find. And of course, The other one is at 180, and we saw 180 was part of our general solutions. But then we've got this lovely point over there. What is that point? What could it be? Yeah. So that one is that one. That one is that one. So there are many ways of finding this solution. We can work it out using our general solutions, or we can just use the graph nicely if we are smart enough. If I can tell you that, you see this interval from the maximum to that point, as we can see, this is just before the x-intercept from a maximum. We can do the same and say this is from a maximum to that point. So this is a maximum. To that point, as you can see, from a maximum to that point just before the x-intercept, because this graph is symmetrical, so these points are not going to lie. So we can just decide for ourselves that, okay, how much did we go from 0 to minus 30? That was 30 degrees. So that means from 180 we can add 30 degrees. So let's see. 180 plus 30 degrees gives us 210. So this means this should be 210 degrees right over there. Again, we can use our general solutions. How will we find this? Think about this situation right here. So let's say k is 1. When k is 1, we get 360 minus 150. Do you see that? So this solution would give us that piece there when k is 1. We can work it out using that solution because we cannot read this one quickly and directly. But as long as we know that beyond 180, less than 360, that's the, less than 270 here is the third quadrant. So what would be that point in the third quadrant? We can see that solution gives us solutions in that quadrant in a way. Right. So guys, learn to use and use wisely. So we now sorted. So we can just easily say, okay, when is the graph of g of x plus 30? Now the issue that we need to also account for is this plus 30 degrees. So what is this? When this appears on the function itself, it means the actual point is shifted to the left 30 degrees. So we will see that, okay, this is easy. We know that they are equal, g of x is equal to f of x at these points. When x is equal to 0 degrees, okay, let's start with the negative. So we know that these are equal at x equals minus 30 degrees. But now we're going to shift this 30 degrees to the left. Every point, or x is going to be equal to 0 degrees, but we're going to shift it by subtracting 30 degrees. Or x is going to be equal to 180 degrees, and then we shift this one to the left. Okay, or x is going to be equal to, of course this is done on the rough work, guys. We can just write the answer only here. Or x is equal to what is this, 210 degrees, and then we take this one 30 degrees to the left. So the solution that we need here, we can say x is going to be equal to a set of these values. Minus 30 is minus 60 degrees. 0 minus 30 is just minus 30 degrees. 180 minus 30 is just 150 degrees. And then 210 minus 30, and 210 minus 30, 180. Yo, dilibele iwes ngobnansi interval kodwa besiyibonile. So these are the only ones, guys, in this setup, okay, where these graphs are going to be equal. So we just shift those that we see. But now here's the catch. The catch is that, there's no catch, guys, because minus 60 is still within this range of minus 90 to 270. So yeah, it's just the shift, and the shift is not so big that these ones fall outside. So all of them actually count. So bafowethu angazi ke mase kuvele kube 3 marks kodwa zi4 as solutions. Yabona ke? Hayi man, yabona. Yabona, because for me guys, this is a solution. Of course, an answer only here is fair because there's quite a lot of them. So I don't know why this is now all of a sudden. Hey guys, man, maybe the examiners are doing this. Sometimes I see this all the time. They can say for these two 1 mark, for these two 1 mark, and then say for showing that shifting maybe another mark. But guys, if the solutions are correct and there are many enough, technically speaking, the challenging ones here was the minus 60 from the minus 30, as well as the 180 which came from the 210. Those are the most difficult ones. So we can say perhaps the minus 60 and the 180 are the ones that each get a mark, because there was a lot we needed to do. We needed to find those. We can easily say this is a mark and this is a mark because of where it came from. We had to work those out. And then we can say this minus 30 is normal. Yeah, the minus 30 is easy because 0 is quite obvious. So this one and this one together, these two together essentially give just 1 mark because it was easy to read them on the graph. The others we needed to work on our general solutions. Yeah, perhaps that's where this is, because any of this other stuff is just rough work. We don't need to show it per se, but showing it is no crime at all, as long as our conclusion is clear. Right? Because the question said determine. So it protects us from doing other things before we get to the solutions. Right. So let's get to the next one. 7.6. So 7.6 says, consider the following geometric series. Yawena awuphi kwedini nisenze maths ayi bafana bami. Yabona ngokuba nikho inspired, andazi ba intoni ezawuni-inspirisha kwi-maths. Yabona zonke izinto ekudala ndizithetha. Nazi ekwathi misbehavior le way. Xa ithanda ayifuni ukusebenza njenza into zami ngendlela. Yabona ke ezi-updates zinenzela into enje. Okanye sekukhona ukukhathala kule pen, mayime kancane. Mhlawumbe ibhetri seziyaphela. Right. We need to consider this geometric series, and we are told it is geometric. Now, if it is geometric, it means there's a common ratio. So R here, we will see that we've got cos 2x divided by 1. So R is basically 2 cos 2x. Right? Or is it really the same? Let's say 4 cos squared 2x divided by 2 cos 2x. Right, so we know that this square will take that whole thing, and then 4 divides 2. So all we remain with is 2 cos 2x, okay? So we indeed have a common ratio of 2 cos 2x. Again, guys, know how to play with the games. Not how to play with the games, but you need to know how to play the games. Kuyayibona ke goje, sekuyayibona ke goje ukuthi letho lena hayi man. Ikudlala lokuthile. Ikudlala kwekelelo kalaka. Konje bathi intoni ngesport ikelelo. Lami lesport akusasiyati kahle goje. Ukuthi masikhuluma le malimi lana kakhulu la kuhleti khona goje. Akusayati ukusikhuluma kahle. Hayi empa ke laba basihati bayayati ukuthi sikhuluma kaje la khana ke khethu. sikhuluma kaje lakhana ke khethu asidlale siyasebenta. Right, let's sebeta ke asebeteni ke konje impa ke yabona ukuthi la dohluleka kuyiqetha letho lakho ethi sesinke page lentsha into uthi umsebenzi wethu lakha ukhabe kahle. Right, use the graph of G to determine the values of X in the interval 0 to 90, for which this series will converge. When does the series converge kanene? Sesiyayiqonda ke ngoba tyhini namadoda. Kaloku i-converge lento xa i-common ratio isenza izimanga ezifana nezi. This converges, the series converges when R is less than or equal to 1, but greater than, so include as lingana, funeka ibe proper fraction or R. Because xa ilingana no-1, akho 1 izakwenzeka. Akho kwa-series futhi ngaphezulu. Ivele imosheke iba yinto eyi-1, so yeah. Hayi man, ibona ngasothetha into ezininzi sanibona yabheda ngo. Okay, this is the one. So this implies that we can show these simplifications, guys. We can just easily say this is 2 cos 2x must be greater than -1 but less than 1. But we were told to determine again. No one said calculate. So we can just say, okay, we know what the common ratio is. And I've shown how one can look for it if at all there is an issue here. Now we've got to deal with this issue right here. So can we see, guys, this is the graph of G times by 2. So of course we just need to get rid of the 2. So if we divide by 2, it's a positive number. So this implies that -1/2 is less than cos 2x, which is also less than a half there, right? So just get rid of that 2. Then we remain with cos 2x. Now this is G. Can you see? Now we are supposed to use the graph to determine the values. We have to use the graph nango. But I think we cannot do this without the graph. So of course, first of all, we have to do this algebraic manipulation. Then we can solve the values of x that will satisfy this in terms of degrees, because we need to find x. So now we can use the graph. So let's look at the graph. Where's the graph of G? Here's our graph of G. Kuyelo samthola ngotha hando umama wethu samthola uthando. That was weak. A swag man didings. A sneer joke, this one. Use the graph of G to determine the values of x in the interval that this thing is the thing. Now we can see, guys, that this thing must be less than 9. This must converge. If it converges, is it converges or converges? -1/2 must be less than G of x, because cos 2x is G of x. That must also be less than 1/2. Now where is this half situation? Sesiyijongile ke ngola graph ka G sinayo into ethi yewena man thengathi usiqhela kabi kodwa usiqhela kamnandi ndiyacinga. Between 45 and 90 man, there's a 60 somewhere mos. There's a 60 somewhere mos. Kodwa isozibe hayi man, because of 60 ngu-1/2. And because of 60 uzosinikeza u-30 degrees. So cos of 30, not 45, but 30, u-1/2 nanti apha. Then xa simthatha simfunda ezantsi phana sithi hayi man bezoba ngu-30 izoba ngu-30 degrees phayana man. Sesikubonile ngu-half ke luwana phaa kwi-y-axis. Sithi sikujongile and ke ngoku ibisithini le nto kanene ithi phakathi ko-0 no-90 sesiyifumene yokuqala. Eyesibini izoba yi-half apha. Masiyiqala apha kodwa siyiqale sithi half encinci phana ilapha apha ikhona. Then sibe sesiyayithatha ke ngoku siyibuyisele phaa. Ya nantsiya ke ngoku ibuyele nayo seyazibona nayo bayi. Hayi vele ndajikiswa sendabuyiswa emva. Nantsiya. So sesiyayazi uba izakwenzeka phi kanene le nto. Phakathi ko-45 no-90 le nto lena ifanele uba ngu-60 lwa. Because izoba ngu-60 degrees yaqonda. Why? U-60 xa simultiplya ngo-2 120. 120 yafana no-180 minus 60. That's second quadrant. So that still gives us a minus a half. Sesiyibonile. Naziya ke ngoku eza values phana sizifumene. Ngoba kuthiwa masebenzise idraft sebenzise idraft nathi. Kuzoba yi-5 marks kodwa le nto le. Umbuzo what is included now as our values? Yes. Singabe sesithi therefore x ke ngoku guys must be less than or equal to 60 degrees but greater than or equal to 30 degrees. That's it. Apho ke kuyenzeka ke ngoku siconverge. Yeah. Siyaconverge phaya. Kungenjalo asizuconverge because lena isixelele ngenkani bafuneka kube njani. So we needed to do this manipulation, and then from the manipulation we then went to the draft and we're like, okay, in the draft where do we get these things? And then we got the things. After we got the things, we then answered the answers. Singoma kwekweta yazi loo nto leyo. Doorkeeper vale zoncango sezingenile, sesiphethe induku zethu singoma kwekweta sezingenile. Doorkeeper vale zoncango sezingenile. Sesiphethe induku zethu singoma kwekweta sezingenile. Sesiphethe induku zethu singoma kwekweta. Ndandikwazi ucula ngoku ndandisakwazi. Ngoku ndiyayiloza qha. Ndadla amazambane atshisayo ngoku nakhanywa. Yeah. Guys, diniwe mna. Kodwa ke bendinikrobisa nje uba ke ii-questions ezine-functions guys zifuna ukuhandlishwa kanjani. Yaqonda? Ziimarks zamahala ezi. Akudlalwa xa kunje guys. Ndiyakuxelela. Yabona ke ngoku imark yokuqala ilapha. Siqale sifumane la common ratio, yiyo nje imark yokuqala. Eyesibini yokwazi ukwenza laa nto yesilungu, uyayifumana? Yiyo ke le mark yesibini. Kube sekuba yile mark nale mark eza values kaloku nazo ukuzifumana kube ke matsapa hodikhumana wabona hodikhweja. Then to understand that this is the graph of G kaloku sibe sesiyinika nayo leyana imark, uyayifumana ke ngoku. Ungaba sandibuza ntoni enye futhi? Ayikho. Ngaphandle uba ufuna ukundihlanyisa. Ungandihlanyisi. And then ke ngoku guys, into ebalulekile, inequalities, they mean any other values in between, they're included. There's no need to state that x must be an element of all real numbers. That inequality on its own is saying the things that must to be said. or that must can be said, if they can be said, not showed, but said. Right. Siyigqibile, guys. So these 19 marks could be very tasty and very juicy. Xa uzazi indaba zakho. Ndikuzamile mntana esikolo ndakubonisa izinto ngendlela emnandi. Ngoku ke mntana esikolo, to avoid a situation whereby I do more than is necessary, ndirhalela ukukushiya ngoku ndikubonise nje qha wena omawuzenze wena. Uba unengxaki undixelele, siyavana phaya kulaa group kaWhatsApp. Alright ke mfundi obaluleke kakhulu, wena wendlovu, nantsi yakhe. Khawuzame leya question ke mntana esikolo, sikubone uba le mbudane bendikunikeza yona uyibonile na. Ngoba ndiyazazi mna ndiyazibhudela. Yabona ke sana, masingaqhela. Kutheni ufuna undirotheyithisa nje? Khange ndithi rotator mna, andikhange ndiyitsho loo nto. The qha mna faka ebhoksini le nto ingazubola, ingazuthintwa ziimpukane. Alright guys, try this question. It's very nice. I think it looks familiar, and I think at some point I did this question. I don't know, I don't remember, but it is familiar. Either way, if you want to practice now, having seen what we did here, try this one and see what you can do about it. And if you struggle, let me know. I will assist. Here is another one, folks, to do. Please do this question, or question. Is it a question or question? Please do this one as well. Sometimes, usually, this doesn't really get to 19 marks like the other one, but you never know, hey? You never know. So this one, yeah, try this one as well. It looks familiar too. Either way, whether it is or not, just try this one and see what you can do. If you struggle, let me know. So guys, I'm not going to point out every single question there is that you can try. I have also shown a lot others in the videos that this channel has. So please revise those if you can. If not, don't worry about it. Fact of the matter is, on Monday, you are sitting for an exam and you're going to have to respond to questions. Whether you are ready or not, they will be looking at you in the face, and you're going to be looking back in them right through their eyes. And if they don't blink, then you will blink, okay? If first question has panyas, kuzawuphanyaza wena. Masiqithe. We're going to the 3D structure. Alright guys, let's continue with 3D structure. Again, there's plenty of questions that can be asked here, guys. I'm just going to point you into those that you may perhaps want to try. If you struggle, as I said, if you're one of the guys in the group, you know what to do. If you're not, well, doesn't matter. Don't even worry about it. It's probably not even relevant. You never know. Right. Question 10 says, in the diagram below, RS is the height of a vertical tower. Right. So if it is not indicated, we indicate it. So this is already perpendicular to some imaginary horizontal line there. T and Q are 2 points in the same horizontal plane. Usually this gets shaded, but don't get used to it. Okay, as the foot S of the tower. And we can see that technically this is spelling out this plane. Now the point T, from point T, the angle of elevation to the top of the tower is 60 degrees. It's indicated here. RTQ is theta. That is also shown. RQT is 60 degrees. That is also indicated. And TQ is K meters. We have it over there. Nice and easy. Right. So we have what we are given. Now the strategy to 3D problems, guys. If at all you don't know what to do, you calculate all possible angles. Okay, that's the first thing you want to do. We calculate all angles that we can calculate. Let's look in here and see what we can do. This angle we can find because we've got 60 and theta, so this one should be 180 minus 60 is going to be 120. So this is going to be 120 degrees minus theta. This is from 3 angles of triangle RTQ. Done. We've got all those angles now. Now we can look at another angle and say we can calculate that angle R in triangle RTS. That one will come out as 90 degrees minus 60. That becomes 30 degrees. Again, from 3 angles of that triangle. Those are complementary. Or we can just say 180 minus 60 is 120 minus 30. Okay, so 180 minus 90 is 90, man. 90 minus 60 is 30. Sure. So that's the first thing we do, guys. And then the second thing that we do, we then start with a figure. I'm just going to say figure this time. A figure that has at least 2 angles and at least 1 side given. All right, so once we've calculated all our angles, at least we need to focus or start. Maybe we can say start or focus. Sometimes you never know which is which. So we can start or focus on a figure. It could be a triangle, it could be a quadrilateral. As you know, we almost always have these working on our shoulders. But sometimes you may have a circle here with some chord that is known and some angle and circumference. You never know, guys. That's why I'm saying any figure, any geometric figure that is familiar, it can come. And then the third thing, we work towards the common side between two recognizable figures in the diagram, of course, because remember the diagram is the whole thing. These figures are the elements of the whole. So I don't know if I make sense, but if I don't, I don't. Okay, guys, now I'm getting this sense. Right. So guys, and then of course the last thing that we do, which is the simplification. Now number 4, we just use our 3-step approach, because that's the one thing that we're gonna do and do all the time. Okay, 3-step approach. That's it with 3D structures, guys. So this strategy works all the time. So there's no excuses here. Okay, let's look at this question quickly. So question 10. Now we have a situation that says, right. We need to express TR in terms of theta and K. Now if we look at TR, where is TR? Now if we're looking at this in terms of theta and K, it means we're looking at this triangle. So this means we are looking at that triangle over there. So we can clearly start by placing reference to it. So 10.1, we can say in triangle TRQ. Trick. What is happening in triangle trick? Yeah, we need to start by saying angle R in this particular triangle is going to be 120 degrees minus theta. This one is from sum of 3 angles of a triangle. At this stage, we want to cut to the chase. It's just 3 marks. And we cannot do anything without stating this, guys. Be very careful. So we can say then, we know that we are looking for TR. So if we're looking for a side, we can start with it. TR divided by sine of the angle opposite that side is angle Q in this triangle. We don't need to say TQR. Should be equal to, we choose a side that we know, TQ, divided by the sine of the angle opposite it. In this case, it's going to be angle R. Right, this is the sine rule of triangles. We know it. But be in the habit of stating things, man. So TR divides by sine of Q there, it's the sine of angle 60 degrees, is equal to TQ is K divided by sine of 120 degrees minus theta. Then we cross multiply this here to isolate TR, so we know that TR in fact okay, this one needs to be in theta. Okay, so what we can do there, we can say, well, TR is gonna be K sine 60 degrees divided by sine of 120 degrees minus theta. So we can say safely yeah, doch TR let's sort this one out. Sine 60 is root 3 over 2 times K, all divided by, in fact, I want to sort this out nicely. At the end of the day, this 2 is going to end up in the denominator multiplying that sign. So this is the same as root 3K. Of course, guys, if you don't know how to simplify, so this is going to be 2 sine 120 degrees minus theta. We need to eliminate as many of the other angles as we can. Unfortunately, the one in the denominator is a compound angle, so it won't go away easily. So we don't have to simplify that. If you don't know these things, folks, ndicela ungambuzi into sevan ndikubonise ukuba kungoba kutheni. Besaba nobani no root 3 times K. This is root 3 over 2. All of it would be divided by sine of 120 degrees minus theta. This would be over 1, isn't it? That's when we expand that issue. So we get root 3 over 2K times, we flip, this is 1 over sine 120 degrees minus theta. The numerators multiply, denominators multiply, and we end up where we are. So this needs to come quick, okay? If the numerator ends up with a fraction, its denominator will multiply the original denominator. Don't sweat, right? Right. Now this was 3 marks, folks. So knowing that we can set up the sine rule in this specific triangle. Remember, this is not just the sine rule in general. So this time it's applied. We get a mark for this. And of course, folks, substitutions. But I think this one is much better. As much as it is volunteer. Okay, it was not volunteered. That's the answer. But I think the also key thing was to find that angle. The rest is the gymnastics of choice. Substitutions are not really a big deal at this stage. So yeah, that's it for those 3 marks. Let's do the 10.2. Okay. Now we need to show that RS is equal to 3K divided by 2 into the square root of 3 cos theta plus sine theta. Now where is RS? This is the dude. Now where is this RS? Okay, So we are looking at that triangle. Can you see, guys, what did we do here? We started to calculating all these angles. Of course, we were not asked, but we knew we needed to. Of course, this time we're just doing it as a way of making sure we understand the diagram. But when we respond to questions, we need to show what we did specifically to answer the question rather than in general. And then we start from a structure or a figure that has at least two angles and a side. Can you see that blue outlined triangle gives us that situation? And can you see, in a way, we kind of were asked this time, but we could have been asked this question without that one, and this could be just easily 10 marks straight up. So if that was the case, remember, this question can be asked again, but someone may just say 10 marks and not ask this question. That becomes your problem. So we worked towards the common side between two recognizable figures as well. As we can see, this is the triangle and that yellow triangle. And now we're looking for the side in the yellow triangle. Can you see that? And we can see that we used a bit of a simplification here. So let's see, in triangle TRS, dress, or stru, STR. Right, what can we say about this triangle? It's a right angled triangle, and we know we want the opposite side. We have found the numerator, the what you call the hypotenuse side, and we are given the opposite angle to the side we are looking for. We can easily say sine of angle T. Here we don't need to say RTS because we specified what we are working at or on. So sine of angle T is the opposite RS divided by the hypotenuse, which is TR. This one needs no justification. So we know that we're dealing with sine 60 degrees is equal to RS is our interest. TR, okay, this time maybe let's just cross multiply this thing straight away. Stop wasting time. And we can say safely this implies that RS is going to be basically TR times sine of angle 60 degrees. So this implies that RS is TR is root 3 times K all divided by 2 sine 120 degrees minus theta times sine 60 degrees. Right, so this implies that we've got RS equals root 3 times K divided by, now we know that we've got compound angle expansions here. Ndisacinga ke kodwa ngoba intoni endingayenza apha. Ikhona into endingayenza before ndi-expande laa nto, before indenzele ama-tie-tie. Okay, maske siyicenge kancane sithi 2 sine 120 degrees minus theta times sine 60 is root 3 over 2. Right, from special angles. We cannot forget this. So this implies that I have RS equals, now numerators multiply, root 3 times root 3 is just 3 times K divided by, this becomes 4 sine, okay, let's just go for it now. I'm lazy to waste time. 4 sine, now we expand that compound angle identity, is going to be sine of the first angle times cos of the second angle. Then the sine remains negative. This becomes cos of the first angle, sine of the second angle. All right. Yo, seliphelile ixesha kanjalo nje. Masisqueeze. So this is 3k divided by, now we've got 4 into, we know that sine of 120 is basically root 3 over 2 is the same as sine of 60 in the second quadrant. So that's the same here. It's going to be root 3 over 2, right? And then times cos theta minus, maybe let's not rush to get rid of this square bracket. So this is going to be minus cos of 120, the same as cos in the second quadrant. Cos of 60, this is a half, right, times sine theta. So we end up with RS equals 3k divided by, now we can clearly see that that sign, negative times negative, is going to give us positive. So essentially, space. Although guys, you're not supposed to clutter things like I'm doing right now, there has to be a space between these sub-questions, but I'm just trying to finish on this page. So this is going to be 4 into, now we've got root 3 over 2 cos theta plus half sine theta. Now we can see that this implies that RS will be, now this is 4, we can factor out by taking the highest common factor, which is a half here. The half is going to multiply the 4 outside. Let's try. Yeah, bafethu ayisandikhalela ngongidinwe nyani nami. Sendinwe nyani ngoku. Sendinwe nyani ngoku. And we still have Euclidean geometry to handle. Okay. So this means 3k over 4 times, we take out the half, we remain with root 3 cos theta sine theta. Now we know that these ones will do the things, and then we end up with our RS equaling 3k divided by 2 into root 3 cos theta plus sine theta, as was proposed. I tried, it just wasn't trying to gel. Alright guys, so here we are. Now what do we have? We have 7 marks. Great stuff. So essentially, yeah, the factorization gets a mark. The angle expansion gets a mark. Using special angles, whether for this and for the other one, maybe a mark. 4 marks. Special angle there, 5. So 1, 2, 3, 4, 5. You can say substitution, 6. The end result, even though it was given, it still matters. Yeah, it does. So 7 marks in the bag, guys, and that's the total 10 marks for this question, which could be asked directly 10.2 without 10.1. If we follow that strategy, we never go wrong. But when questions are nicely scaffolded, we just deal with the issues. Again, that's a very good guide that one can follow. It always works. All right, guys. So, yeah, the man is tired now. Let me just show you some examples one can look at. And perhaps if you struggle, you can hit me up as well. All right, guys. So, can try this question 6. And of course, my students know we did it during the lessons. So try this one. Usually the question 7, this is usually question 7. It's hardly complicated. It's hardly more than 2 questions, at most 3. So don't cry here. But it can be anything. Remember, things can change. It doesn't have to be the same thing that you know. All right, guys, so here's another question that one can try. Okay, can try this one and show us your might. So there's plenty of questions. This document is going to be in the description with these highlighted, suggested, questions for a student to attempt. All right, guys, here's another one. This question 7 is worthy of an attempt. As you can see, questions can come in different ways and different flavors. What matters is that if we understand the approach and we know what to do, we have studied enough, we know enough, we can do enough, okay? So, of course, guys, I'm not going to go through all these for the sake of trying to have you guys do these things. Even on the description, even on the comment section of this video, if you're not my student, for these questions I'm highlighting, you can solve them. If you run into problems, remember this channel is also a way of communicating. You don't have to be my student per se, as in the ones that I teach regularly. You can just say, okay, for that particular question, this is what I did. Is that right? Or perhaps I'm confused when I get here. I will try to give as much of a comprehensive answer as I can on the comment section. Remember, guys, there are no limits to how we can communicate. Even if we don't know each other, we don't really have to know each other nowadays. The networks are just there to connect us. As long as what we're doing is good and we're not wasting and passing time. Yo, ndikatera. So, yeah. Look at it to stretch by 2 minutes or so. Try this one as well, guys. And of course, see how it goes. All right, folks. So here's another one. Perhaps we can say, okay, if you can handle business here, folks, should be fine. Because remember these shapes that are studied in grade 11, measurement and stuff, it can come. It can come. Remember in maths, guys, everything from grade 1 until grade 12. We have a right as the examiners, listen to me, including myself there, I am not an examiner. They can bring it whenever they want, and you as a student is your responsibility to do the things that must kind of be done, whether you like it or not, nice or not, you just have to. This is why math is just a nightmare, guys, for people who are lazy to think and lazy to carry the right information and are very happy to carry rubbish in their heads. Social rubbish, nonsenses all around, excuses and excuses and excuses, and ignorance, noise. That's what we have so far. In fact, noise trends much faster than reason. And it is mistaken for intelligence, by the way, which is sad. A lot of noisemakers are taken for intelligent people, of course, under the guise that, there's a freedom to what? What is this thing? Freedom to what? Expression, freedom of expression. But you're expressing nonsense. Must we really applaud that? No. If you're busy talking trash, must we then have a time to listen to that? Of course, the media, institutions are busy giving airtime to absolute rubbish and noise in this country, and they are not giving the light where it needs to be shown. I don't understand. I am yet to see this media, what you call what is the word they use, these politicians, when they honestly want to make noise even more, what is called the media ganene, that the mainstream media. I'm yet to see mainstream media fighting to, interview YouTubers who are actually teaching the nation, some sensible things, like, channels of a nature like mine. Of course, I don't like media attention. I don't know how to speak in front of multitudes because, guys, my arrogance is just going to start coming out and the whole thing is going to go south, okay? Because I don't like stupid questions asked, and especially by the media. I have time for students. Students, you can ask anything, stupid or not. I take it because I know that is the beginning of me drilling some sense into you. But media, no, I don't like stupid questions, so they must not ask them. And there are certain things that have a personal touch and take, in my opinion, and I should not air that into the public because you know how the public is so fragile. But yeah, there are some good people I've seen that I believe, though, they should be more popularized by the mainstream media instead of these stupid politicians who have failed in the ANC. They went on to fail in the EFF and then continue to fail in another party like MK for Floyd and, what is this, DA for Maimane, you name them. They all sound smart, but are they actually smart? I wonder, because people who are just wandering around all the time, I don't understand them at all. I would get it if they were to say to me, I got hired. That was just a job. Someone just called and hired me. It's different from going and joining something because you believe in it. All of a sudden, you no longer believe in it. Imagine if we were to believe in these people. By the way, they were very influential in the ANC. They stood a chance to make the right changes in this country, because why do you go and join people who are not in charge of the country and claim you have all the right ideas to change this country? It just shows you are weak, man. It just shows you are weak. Now I'm talking to those who are politically inclined, of course. Those who are not, please close your ears right now. Because for me, honestly speaking, you cannot tell me you believe in the ANC when it suits you, and now when it no longer suits you, you don't believe in it. Now it has to be changed. And then whatever you changed into, you no longer believe in it now, it has to be changed. I mean, come on, we're not fools. We know that all of you are just empty vessels with loud mouths. Very ignorant at best, because you just go and read for the sake of coming to make speeches and all. You don't read because you want to know and understand, which you can just ooze all of that no matter in what position and situation you are. So for me, politicians like those are of no significance in society and in South Africa. Yes, we can applaud them because we are all ignorant in society, but those are not people worthy of airtime by mainstream media, and they're not worthy of, our functioning of our vestibular cochlear nerve and all the nuclei in the brainstem, all the way to the gyrus of Herschel. You get it? You get it. We're wasting neurons functioning there. Our action potentials are wasted when we listen to those people. They have nothing to offer. They're just hungry for power and, of course, relevance. But they have low self-esteem, in my opinion, because people with, grounded self-esteem and people who are sure of themselves, they would know that if they want to change this country, they should have stayed in the ANC. Yes, there's lots of rot in the ANC, But guess what? It is the majority part in this country. And so anyone who needs to change anything in this land, the only chance they have is to be there and there to be influential. And that means you need to spend time there. You can't just go there tomorrow and then you're in charge of things. No. You've got to go there, work the ground, understand how this thing works from the ground and start working your way up, understand how this thing works all the way to the top. Once you know it all, you know how to make those changes. And you don't have to be loud. You don't have to be, forcing your ideas. Sometimes you just do it smartly. Look at Mr. Mandela. ANC was not as efficient as people may think it has been, even when it was, during the times of what you call, I won't mention, the ANC had its own internal issues, divisions, factions, if you name them. People didn't want to listen to certain individuals. But you see, it took people who can take the bull by its horns, like Babu Mandela, to stand their ground, even to their own kind. The ANC, if I was to put it, not necessarily color, kind as in party affiliation. They had to stand against even the common vision of the ANC to liberate this country. But you will find fools going around. He's sold out, he's sold out. There's always a sacrifice if you have a cause to chase. It's like studying. You will sacrifice some comforts that young people enjoy if you want to become an individual of independent standing in the future. But if you want to enjoy what others enjoy and you think you can juggle that with studying, you are playing. You're going to suffer in the future. You will suffer. I will tell you now, it's not even a probability, it's a certainty. Diyashumayela ke ngoku. Thini amen. Amen. Alright, okay. Alright guys, 3D structure, senshumayele kakhulu. Kodwa ke ngizama ukuthi nje ke in a nutshell guys, I feel like people are doing good work. I'm not talking about myself. I'm not doing good work. I'm just scratching the surface. But there are people who are actually doing the greatest of work, and you can see it. I feel these are the people who we should be seeing on SABC 3 being hired to do lessons, every day, in fact, because I don't understand why we have so many news about killings in Israel, wars in Ukraine. Isinceda aphi mani le nto besisiva ngeendaba zemilo? Ayikho isinceda khona. What we can do though is to learn from the consequences of those wars later on. When it's all said and done, we could then start to understand, how did the war begin? How was it fought? What got into the play there? What was the outcomes? Could we avoid these kinds of outcomes when we have no choice but to confront the situation like those people have had to? What are the best ways to confront those situations to minimize damage that we can see? It could be a lesson, but instead of entertaining it now in its height, it's a waste of time because a lot can be confusing. There's no learning that we can achieve at this point because it's already happening and it's dangerous. Now we have news about this. Instead of just putting time for students, hire these good guys who clearly need jobs, because there's money for a stupid dialogue in this country. And I don't understand, what is this dialogue, by the way? Because we're going to talk about what we already know. And there has been failure to pay attention to those very things. And there's very slow responses to very urgent needs in this land, because people just want to eat. They just want to eat. And even when they eat, they don't get enough. They're like pigs, gluttons. Ithi yakhalaza. Idla ikhalaze yakho ayonele. Zihakho nje tyhini. Ngicaphukisa, ngingabusaya futhi kakhulu ngoba ngaske ndilume kakhulu ndishiye kuvuza igazi ngoba ndiyinja enomgada. Niyazi nje nomgada ndiyiyo ke mna. Ndiyinje nomgada. Mgada ke, that's rabies. I'm a rabid dog. I bite a wound that doesn't heal. Yeah. And you will be trying to deal with me, but guess what? My mgada is already dealing with me. So you're wasting your time trying to deal with me. The mgada, the rabies is already dealing with my brain, man. It's already deteriorating this brain of mine. So, all right, guys. I think I have tried, guys. So now the last bit of an hour, it's going to be perhaps 5+ hours of doing this. We're going to try and hit some ideas about, Euclidean geometry, and then I'm going to point out some, problems that one can try, because I cannot do it all. Even if I do it, that would be a disservice to you. Because the reality is, it's not about you watching me, because I'll be wasting your time with you watching me, and only to find that 90% of what I'm going to show you is not even going to be in the exams. Now you've spent time trying to understand what I'm doing, and the next thing, it's not coming up, and you have wasted time looking at it, and perhaps you could have practiced something that you could think of yourself, and maybe it would just come, you see. But if you're smart, you'll just listen for the sake of understanding how things are done, and imitate that, if not emulate that, and it just might work. But again, it only works if you engage. If you passively just sit on the fence and see things happen, it's not helping, it's just wasting your time. So please don't be hung up on watching my videos, and numbers and all, thinking you're gonna master this thing. No, you're not. If you don't engage, if you don't do the reading, you don't do the practicing, and you aim at becoming independent of me in doing your work, you see. But if that is the thing that you want to depend on me, aye, ngekho wena. Alright, guys. Hey, kusile and andikakalali. Ndizoyigqiba nini le nto, ndilibele ukubhuda apha. Okay, sisabhuda sinjalo. Athi ndikudlalele kancane nje, ndidlala kancane, sisebreak nyana, masikhathi sithatha ikhefa nyana, kodwa ikhefa engayokhefu. So wenza i-Euclidean ngokusekileyo. Hayi, i-statistics nizozenzela bafowethu, ngeke soze ndiyofika kulaa topic. That statistics is statistical. It's statistical. My keyboard though, it's not a keyboard, it's a digital piano. A digital piano needs some service, man. Kune-notes ezidlala into endingayazi. Oh, ithini la nguMakazahara? Uloliwe dudula. Hayi, angisakwazi ukucula ne. Uloliwe. Shonila before ndiphambane ndizawucela nenyongo ndiyiloza ndinjalo. Eyiqathele guys, yazi ngaske ndivele ndilale qhamu. Kodwa ngofuna ndiyigqibile le video. Alright guys, let's get to Euclidean geometry. Now I'm gonna cut the nonsense and cut to the chase. Right. Alright guys, Euclidean geometry, we need to know our theorems. So let's see. Complete the statements below by filling in the missing word or words so that the statements are correct. Okay, good. So let's see. Question 7. So the angle subtended by a chord at the center of the circle. So this is the angle at center equals 2 times angle at circumference. So the angle subtended by the chord at the center of the circle is 7.1.1. Now I'm just gonna write the missing statements, but I suppose one has to write the full thing. So it's subtended by the angle subtended by a chord at the center of the circle is equal to the angle is equal to 2 times the angle subtended by the same chord at circumference. Let's not say too much. At circumference. Yeah, that's the one. So guys, we need to know how to state theorems. So this is the emphasis on this question. We need to know to state the theorems, prove them, and apply them. The angle between the tangent and the chord is equal to the angle subtended by the chord in the alternate segment. Okay, so again we need to know the ten-chord theorem in terms of its full statement, right? Not just the shortcut that we use when we apply it. Now the opposite angles of a cyclic quad are supplementary, or you can say, yeah, I think that's the word that is being looked for. They are supplementary. Okay guys, keyword here is please know how to state theorems. There's no excuse for not knowing. 7.2. Right, it says in the figure below, RDS is a tangent to the circle at O. So there is our RDS. What is RDS? If you join medicine, RDS is what we call what? It's respiratory distress syndrome, and it's bad, it's deadly. That's how respiratory disease kill people, through RDS. So that's not a word you want to hear about your patient. Okay, if BC is equal to DC, it's indicated, and CDS is 40 degrees, again indicated. Calculate with reason. Do you see the statement says calculate with reasons? So folks, we need to make an effort to show a calculation. But again, sometimes the very examiners themselves ask crazy questions in a very crazy way, because at times you find that there's no way one can show a calculation. So what the hell? What the hell? So please, examiners, learn also, folks, if you are one of them who's listening to this lousy person, which is called me, talking to you, of course, not really worthy of doing so, but I am doing it anyway. Please, guys, learn to ask questions the right way, because many of you don't know how to ask questions the right way. Okay? Please, those of you who do the quality assurance, the moderation, the coordination, you name all of these things, proofreading, checking, whatever, please, folks, analyze questions for what they mean and what they are looking for. And if there's a discrepancy in how that can come about, then that question needs to be restructured, okay? So that it covers everything under it nicely. You cannot have a general question that says calculate, and the next thing, some of the questions in it do not involve a calculation. That's wrong. Okay. Right. Enough of the nonsense again. It came out without me trying to. Oh, of course. Yaphuncuka ngumsila wembulu xa ubona ubisi vele nje uphunculuke nje ngokuzama ukuqoqosha yaphuncuka. Right. We want BDC. Of course, guys, I'm going to just go about it however you want to see it, because sometimes I often work on the diagram, but okay, let me do the right thing. Before we calculate, let's first establish what angle is equal to what angle here. We know that this 40 degrees is equal to this B1. 10 chord theorem. Right. But B1, because this is now an isosceles triangle, this triangle, because that triangle BDC is an isosceles triangle, given that BC is equal to DC, we can then make the conclusion that indeed that D2 is also equal to B1 and so equal to D1. This means DC bisects the angle SDB or BDS. BDS is Bachelor of Dental Science or dental surgery. Yeah, Bachelor of Dental Surgery. BDS. Yeah, ibana. So funding this school. Now, that is what we can say. And of course, guys, what else can we say? We know and we fully understand that without a shadow of doubt, D3 plus D2 plus D1 is 90 degrees. Tangent is always perpendicular to radius. Great. Of course, guys, there's a lot, but you see, at some point, you just want to cut it. We know that this D1 plus D2 should be equal to angle A, 10 chord theorem. At this point, let's just answer some questions before we complicate our diagram. There's plenty. Angle at center equals to 2 times angle at circumference, but let's just go for it. Now we want BDC. Sorry, BDC, yes. Not BDS, man, BDC. BDC. Can you see that is essentially D, that is D2. BDC is D2. We know that, okay, BDC is itself equal to B1. Why is that? These are the angles opposite equal sides in triangle BDC. Of course, sometimes we need to state the sides, by the way, with given BC is equal to DC. So we can say, but we know that angle B1 is itself equal to angle D1, therefore equal to 40 degrees. This is the 10 chord theorem. Okay? Right. Now we can make a conclusion that indeed BDC is equal to 40 degrees. But now the question is, guys, is that a calculation? No. So how do we do this with the calculation? You see, these are some of the things I want to highlight. Don't worry about the time now that I'm wasting, but I'm just showing you guys that there are many ways of killing the cat, but sometimes there's a specification. So now we can say, okay, all right, okay. BDC plus angle CDS. This should be 90 degrees. Why? The tangent is always perpendicular to radius. See, that's going to involve a calculation. This implies that BDC plus this one is D1, which is 40 degrees, is equal to 90 degrees. Therefore, BDC is equal to 40 degrees. Now, guys, be very careful. There is a catch to these kinds of questions. They look simple, but they are dangerous. Simple questions are very dangerous if no attention is paid to detail. You see, what we did is correct, but you cannot present that answer here. If you do that, you get 0, because the question said calculate. It didn't say determine or find or what. See, kind of questions like that are open-ended. This is closed-ended. Calculate. We need to see a calculation. So this is the correct one to do. There it is. There it is. So 7.2.2. Now we need to calculate angle C. Again, you see angle C is good. This one is good in that it's going to force us to do a calculation of some sort, whether we like it or not. And there are many ways we can solve angle C. Right. So this is just for 1 mark. Now, angle C for 1 mark is amazingly crazy, I tell you. But because we found D2 in essence, this makes life a lot easier. So we can just say, well, we know that angle C plus D2, we can just say D2 this time, plus B1 should be equal to 180 degrees. This is the sum of 3 angles of triangle BDC. So this implies that angle C plus 40 degrees plus 40 degrees equals 180 degrees. Therefore, angle C is 180 minus 80 is 100. Yes, liraza. Iraza 10. Likhulu. Right. Nanso, guys, here it's the answer only, but without that reason, dead and buried. Right, but this is a grade 8 thing, so we're not gonna give it a mark for a reason, but we want to see it. See, guys, a calculation must come. Don't do other things. Of course, you can go about it by saying this 40 degrees plus the other 40 is equal to angle A, which is going to be 80 degrees. But now 80 degrees plus C is 180. These are opposite angles of a cyclic quad, because we can see that ADCB is a cyclic quad because all its 4 vertices are its circumference. Then we can work it out. At least whatever we did will lead to a calculation. Fact of the matter is, when the question says calculate, even if you can make statements before, we need to see a calculation at the end of the day. Nice. So we have 7.2.3. We now need to find angle A. Again, we could easily say angle A is equal to angle BDS, right? And so we can say angle A is equal to 40 degrees plus 40 degrees, which is equal to 80 degrees. The fact that there is a calculation here, perfect. Right? Right. But if we just say BDS is 40 and we don't see a calculation, questionable. You lose that mark. So these small questions are naughty, guys. But anyway, let's just do the easy thing. So we know that basically angle A plus angle C equals 180 degrees. These are the opposite angles of a cyclic quad. We can name it A, B, C, D, because all of its 4 vertices are at the circumference. So this is 100 degrees. No. This is A plus 100 degrees equals 180 degrees. Therefore, angle A is equal to 80 degrees. Fact of the matter is there is a calculation. This plus that is a calculation. Or we can use the 10 chord theorem. Maybe let's show it because this one also includes a calculation. Okay, let's get the marks first. This is just 1 mark as well. Wow, but such a very important reason like that, I win. Maybe this is not thought of. Maybe the second one was the one that was pictured because, but again, it has a reason, so wow. Anyway, we could say anyway, angle A is equal to angle D2 plus angle D1. Why? This is the 10 chord theorem, right? So this implies that angle A is basically 40 degrees plus 40 degrees. We need to show that calculation. Don't just show up with 80. You are going to lose the marks. With questions as fananis because these are too simple to mess around with. Right, so we've done that calculation. So we are happy we've performed a calculus. Now we want angle O1. Okay, so again, this is good because this we can do. Maybe let me squeeze it here. So angle O1, we know that angle O1 is equal to 2 times angle A. Again, this is now angle at center equals 2 times angle at circumference. Right, so this implies that O1 is going to be 2 times angle A, which is 80 degrees. Therefore, angle O1 is basically 160 degrees. See, good thing is this was a good question because it has indeed a way of performing a calculation. So this is very important. Statement and reason and answer. 2 marks in the bag, and there we are for that easy 9 marks that opens this question. So of course, guys, reason I'm choosing this is not that it's difficult or anything, but this time we're not really focusing on whether a question is difficult or not, but now we're focusing on what is necessary and how to perform the questions, the duties as directed by the questions. So this is just fortification, guys. There's plenty of videos on Euclidean. I've shown you difficult and easy. Approach always worked. So you do what you can and you go and cry if you choose to. Either way, I'll show you guys what questions to try now to try and get yourself in the groove. Unfortunately, I cannot do all. Okay, guys, so one can attempt this question 6, please, because these questions where we can calculate the numerical values of the angles can come in different flavors. There's a lot to be done. So please, folks, let's get stuff done. Okay, let's get stuff done. So try this one. If you struggle, let me know. If not, all good. Okay, guys, so this is another question to explore. Again, here, knowing how to, complete statements, or at least know some corollaries, theorems, axioms, you name those things, and know the difference, by the way, because you may be asked that. Sometimes it can come. Even the theoretical aspects of this can be examined, So be careful, know the difference between a theorem, a corollary, an axiom, and yeah, there's plenty of these things. Please, if you don't know this, guys, I will also put the link of what you call the study guide, Mind the Gap. I know a lot of people take that study guide for granted. It has a lot of things that you need, students. Familiarize yourselves. Instead of buying these expensive study guides you like, that study guide is actually what you need, and you get it for free, guys. Stop this thing of suffering, man. But the good study guide that I know of is definitely this Kevin Smith mathematics study guides. Yeah, I've seen the physics ones. I never knew there was physics ones, but I saw them. They are good. They are good. So please stick with that dude if you want an expensive, useful study guide. The answer series is also good. Yeah. I don't like the maths one though. I really don't. But the physics one is excellent. Yeah. So please try question 8, guys. It's a good one, and I'm going to leave it to you guys. In fact, I would say, even if you don't want to try any other of these questions I'm going to show you, please do this one. You're going to learn a thing or two here. Right. Okay, let's get to some other questions now. Okay, guys, so let's get to business. So let's check this question 8. Now, question 8, this is a proof of a theorem. Please, guys, be able to do it. Just going to demonstrate it for the sake of completeness sakes. Because we stated them, we need to know how to prove them. So the first thing that we do here is to construct a diameter. We have to construct this diameter. This is LM, this is LKM, we can call it N. Right, now any construction that we do, guys, it must be broken to show that it was not originally given, because usually we're using a pencil which is the same color as these diagrams. But if you've got colored pens, then it's much easier. Colored pencils, sorry. So this is what we're going to need to draw. And when we do this, it's going to divide this angle, the obtuse one, into 1 and 2. Right? And it splits that angle L into 1 and 2 as well. Right, and of course we know that there's properties here. This is equal to that, These are ready. And if we have ready, we know that this angle is going to be equal to that angle, as well as this angle is going to be equal to that angle. These are angles opposite equal sides. Now we start doing the things using the exterior angle of a triangle, focusing on. So we see those two triangles, so we're going to work on them nicely to prove our theorem. Okay, so we know that we are given circle, center O, as shown. I'm not going to say a lot. And we are required to prove that KOM, komyiso, is equal to 2KLM. Iklim. Okay, that's the labis. What I claim. Of gan propose mean weapon. Dan shalan bet. ndandiliba ndilikhume ngifike ndivule laa toti yeclaim ndifake imini fese kuneminwe emibini phaa but sandandilithanda ubisi. Isimanga sesoba bendingalifuni ubisi xa lungamanzi, bendilithanda xa lingumgubo okanye livuthiwe ngamasi. Senjalo ke phofu nangoku. Right. So we need to prove that angle KOM is equal to 2 times angle KLM. Right, we make a construction. Construction here, we will just draw diameter LON, right, as shown. Again, I'm not going to say a lot. There's a sketch there that is given for annotation. Then we get into the proof. Now, when you get to the proof, we will say in triangle MLO. Right, dim low. We know that basically OM equals OL. Ready? And we will have a conclusion that therefore angle M should be equal to angle L1. These are angles opposite equal sides in a triangle. Right. Perhaps it's a conclusion. Nice. So, if this is the case, we've got a statement to make, but what, mister? We know that angle O1 is going to be equal to angle M plus angle L1. This is the exterior angle of a triangle. So this implies that we can express this in terms of L1. Okay, maybe let's make it a conclusion. We can say therefore angle O1 is equal to 2 times angle L1. We just want to cut to the chase, but we can say angle L plus angle L, then 2 times angle L1. Either way, we want to express that angle in terms of angle L1. Okay, you can say here in triangle LOK, lock. It will lock like a harmon. Retloring here, OL is equal to OK. Retlaring, and then hocho over here, how jwalo. Angle K is equal to angle L2. These are angles opposite equal sides in a triangle. So we understand that here also. We understand that O1 is equal to angle K plus angle L2. This is the exterior angle of a triangle. This is one of the somewhat longish theorems to prove. We can say, well, after this, we know that we can go on and say, then therefore angle O2, not O1, sorry. Angle O2 is going to be equal to 2 times angle L2. We can say then O1 plus O2 is equal to 2 times angle O1 plus angle O2 is going to be equal to 2 times angle L1 plus 2 times angle L2. Simultaneous equations now. So we know that what is O1 plus O2 is the angle COM that we were given. It's going to be equal to 2. We factor out the 2, we get angle L1 plus angle L2. So we can say therefore komiso S 3. How do you say multiply? I don't know. Angle L1 plus angle L2 is basically KLM. Proof is done. So here we need to know this, guys. I'm just showing this for demonstration purposes, just to remind you guys, this needs to be followed like this when a proof is to be done. You first state what is given, you then state what is looked for, we then see a construction, and then we get into the proof. And how we do this, we split what we have into 2 triangles that we solve simultaneously to get to the answer. So all of these techniques from algebra, guys, are not gonna go away just because, you know what, this is geometry, as many say. I don't know how the marks come about. Sometimes it's boring, but I know that the construction gets a mark, and deriving this equation is a mark. Deriving that equation is a mark, and factorization is a mark, and essentially aligning these two nicely, that is solving simultaneously in a way. So this is 1, 2, 3, 4, 5. We're getting 6 marks. Well, maybe any of the ready and stuff that we spoke about. I mean, we can even give the answer even though it's given. Who says it doesn't deserve a mark? Right, so let's get to the second part of this question. So we've got 8.2. So 8.2 says, in the diagram below, O is the center of the circle. You can see it. P, Q, R, and S are points on the circumference. So we call these concyclic points. And if they are concyclic, it means we can make up a quadrilateral. And we can see these points are exactly 4. When they are 4 and they are all joined. So this means this diagram right here. This quadrilateron is a cyclic quad. So when you say points are concyclic and they make up a quadrilateral that has its vertices at the circumference, that's another way of saying this is a cyclic quad. So please know the terminology. As I said, if you are lacking this, I will attach Mind the Gap study guide link in the description. So guys, this is going to be a jam-packed session. This is a true revision. Remember, this is meant to take you through to your finals, guys. So get this done. And of course, my students, we're going to work through all the trial papers that we can find, but only for you guys who attend. So we're going to work these in the group, in our lessons. And we need to work all of them if you guys want to win. And we need to do that. Of course, I'm going to do most. You're going to do the rest and communicate with us all in the group. Yeah, but those who are not there, you will find those solutions elsewhere. I am not going to present too much for now, but maybe later I may start, doing these things. But I don't know if I'm going to be able to do these things next year. Hey guys, I have bigger plans for next year, so I don't know. But the channel will still be relevant, even for the next 15 years to 20 years. This channel is still going to be useful, so if it doesn't go away, then you should be able to get it done. But of course, if somebody decides to have it deleted because of the things I say or the things I do, well, too bad for you guys. So that would be a cyclic quad in a way. Now, TOQ is a straight line. We need that. TOQ is a straight line. And as you can see, it's a line that passes through the center. Can you see that? The vibes of the line from center, unless we find other things. Let's find out. It says such that T lies on PS. Okay, that's fine. Then PQ is equal to Q1. Yeah, is equal to QR. Okay, fine. And then Q1 is equal to X. Obviously, we've got an isosceles triangle here. So there's our isosceles triangle. And we've got plenty others within that triangle. Okay, we can see that one because these are ready. So they are equal. So we will see that this angle Q is going to be equal to that angle R1. All right, the R1, it's a muscle and that. The R1, the R1. The tunya. It's a muscle, the R1. The R1. The R1, tunya. It's a muscle, the R1. The R1. Cien. Now we can see that O2 is essentially going to be 2x because that's the exterior angle of that triangle we just outlined, the smaller one with the red E. So there's lots of things that we can say. But now this time, guys, we try to do as much as we can and stop before we do too much. We also know, maybe we need to say this one. Sorry, we also know that this one is equal to that one. Okay, that was the intention of shading that first one. Okay, at this point, guys, we're not going to say too much. We just want to cut to the chase. Okay, this is now 8.2.1. Calculate with reasons angle P1. If we look at angle P1, where is it? It is that one. It is that one. And we are told to calculate this in terms of x. Okay. So how will we do that? We can clearly see that we have a way around it. See, we proved angle at center equals 2 times angle at circumference, as you can appreciate here. If I can just cut this line like so, just for the vibes. What do you see there? Maybe I can still bring back my 2x. Can you see there? Angle at center subtended by chord RQ, which is O1, is going to be 2 times the angle at circumference there. We can use that. Was there any other way we could do this? No. For now, I don't see it. For now, I don't see it. So let's use that before we start wasting time. So we know something that, come on, we know that essentially angle O1 is going to be equal to, okay, all right. I'm thinking now. We're going to say angle O1 plus angle R1 plus angle Q1 should be equal to 180 degrees. Sum of 3 angles of a triangle. So this implies that we have angle O1 plus angle R1, so we're going to just go for x, and x is equal to 180 degrees, and then we'll just say Q1 is equal to R1 equal to x. This is because of angles opposite equal sides in triangle ROQ with radii OR equals OQ. Sometimes you can have a loser no dlwabevu le reason ngoba ayi ininzi into efuna siyibhala apha but i-marks zimbalwa. So you can say this implies that angle O1 is equal to 180 degrees minus 2x. At least we are performing a calculation because the question said calculate. We can say then we know that 2 times angle P1 should be equal to angle O1. Angle at center equals 2 times angle at circle. Now this implies that 2 times angle P1 is going to be 180 degrees minus 2x. Therefore, angle P1 is going to be 90 degrees minus x. Okay, of course, guys, whatever other means necessary to solve that problem, if you can see it, do it. If you can't, don't do it. Because you're gonna die. I don't want you to die. No. Cannot let you die. It's not me. It's on me to let people die. So of course, guys, what is important is this one. This statement is quite powerful. And the answer. Not to say the others are not, but unfortunately, the marks are just the way they are structured. But it doesn't mean we cannot use other theorems, even if we don't get marks for them. Remember, in Euclidean, every statement must be followed by a reason. Whether it is mark-worthy or not, it's immaterial. But that particular statement does not exist without a reason. Let's remember that. Show that TQ bisects PQR. Show that TQ bisects TQR. It means now we need to prove that these ones are equal. How will we prove that these ones are equal? Uyasihlukumeza Mr. Sir Policeman. Policeman. Okay, we can do it. We can do it. We will focus in triangle PQR, the isosceles triangle. We know that essentially P1 equals angle. We can call this one QRP or PRQ equal to 90 degrees minus x. Now these are angles opposite equal sides in a triangle. We were given that the sides PQ and that one are equal, so we don't need to say that. So we can say then we know that angle Q2 plus angle Q1, that is a unit, plus angle P1 plus angle QRP. We should get 180 degrees. This is the sum of 3 angles of a triangle. Now we go on and say, well, Q2 plus Q1 is x, plus P1 we got 90 degrees minus x, plus that one is 90 degrees minus x equals 180 degrees. So this and that take care of each other. We remain with angle Q2 equal to, so now this is 180 minus 180 is 0. Then we just transpose the 1x. This is equal to x. Therefore, we can say TQ bisects angle PQR. The reason is that angle Q1 is equal to angle Q2 equal to X. Okay. Please, even the most obvious thing, you just have to state it. You just have to state it. Okay. Right. So we were getting 3 marks. So what is this thing here? This is cool. This is cool. Maybe that. Whatever. Or we can say substitutions here. It is not that much of a big deal. As long as we get the right answer and it makes sense, we get our 3 marks. So 8.2.3. Now here we need to show that STUA is a cyclic quadrilateral. Where is STUAR? Here is STUAR. Let us see where is STUAR. Okay, there is our STUAR. It's this bluish or blue quadrilateral there. Okay, how could we prove STUAR is a cyclic quad? Well, we've got issues. Remember we talked about O1 somewhere. O1 becomes our key to success. Do you see, sometimes knowing how to choose the right fight to fight? So we already know if we can prove that O1 is equal to this angle. See that? If that we can prove, wonderful. Exterior angle of a cyclic quad. Let's use it. Quick and fast, furious and angry, if that is all. So we know first and foremost that look here. We can see that, well, PSR plus angle PQR equals 180 degrees. Why? These are the opposite angles of a cyclic quad. Let's say it. Of cyclic quad, we know that this is PSRQ. We were told those points are concyclic and they form a cyclic quad, and it is so a cyclic quad. So this means PSR plus, what is that angle? This is X plus X is equal to 180 degrees. You can say therefore PSR is going to be 180 degrees minus 2X. Therefore PSR is indeed equal to angle O1, né? Because each equals 180 degrees minus 2x. That's the only reason. Otherwise, there was no direct issues there. If this is the case, we can make a conclusion that indeed STUAR U3 komiso is a cyclic quadrilateral. And why is this the quadrilateral? It's because this is the converse of exterior angle of a cyclic quad. Right? Normally we are told something is a cyclic quad, and therefore we deduce that the exterior angle is going to be equal to the opposite interior angle. But at this point we proved by other means necessary that actually the exterior angle of a particular quadrilateral was equal to the opposite interior angle. And conversely, we can say that that is a cyclic quadrilateral. Right. So please know how to use converses as well. They provide for some very nice and concise reasons. Then it would be the case if that was not there. But again, however you phrase your reason, guys, I understand that there are some shorthand techniques to answer those kinds of questions, but remember, they are not the only way you would answer, okay? Do not find yourselves limited by some silly guideline. Guidelines are just what you would do if you don't know better. You hear me? I'm telling you now. Guidelines is what you can do if you don't know any better. Because you cannot find yourself doing less than what is in the guidelines. Because then that is punishable. You cannot do less than in the guideline. But you can sure surpass them guidelines. You're not limited by them in terms of the upward movement. But in terms of the downward movement, you cannot be below guidelines, because remember, guidelines are standard stuff. So if you fall below standards, that's substandard. Now that's not acceptable. But if you go beyond standards, well, yeah, it's allowed. It's allowed. So if you're not giving anything substandard, no one has a right to do anything. Doesn't matter who. If they are thinking they have something to say, well, they have another thing coming. Bring them to me. You get it? So that's a mark. This is a mark. And this whole conclusion and its reason becomes the last mark. Of course, guys, you can see these were the nice 15 marks. As you can see, Euclidean geometry is not entirely ugly all the time. It can be quite interesting and quite nice, depending though on whether you follow your craft with due diligence, because if you don't, you will be dead. You will be done for. All right, guys, ngicela ukhe ndiyophunga itiye ndikhe nditye noba likhekhe nyana liyi-1. And then siqhubekeni, because hey, mninzi umsebenzi ofuna siwenzile ke apha kule yona. Yabona ke this one sizosebenza sangodlala, because this is what causes problems for students and teachers included. So I just want us to just take our time, to work through these problems. Of course, we're going to work through just a few, not all. And then after that, I will highlight what you can try, okay? All right, let me just make myself a cupping of tea. All right, guys, so let's continue. So I've had a bit of a break, Nyana. So in the diagram, points DE lie on sides AB and AC respectively of triangle ABC such that D is parallel to BC. Use the Euclidean geometry methods to prove the theorem which states that AD over DB is equal to AE over EC. Of course, guys, here what needs to be done. This needs to be done. That needs to be done. So we join those, right? And after we've joined these, we draw perpendicular heights, like so. It's going to be very close. And like so. Okay, that's not very perpendicular, is it? Okay. Again, we're doing stuff. So that should be perpendicular and that should be perpendicular like that, and we do the things. Okay, excuse the diagram being small. I am not going to go through the proof, guys. I have gone through it in the channel multiple times. I don't know why I'm writing higher grades. This is standard grade stuff. Okay, right, so let's have a look. 10.2 is this focus for this question, because we need to know how to handle questions like 10.2. So 10.2 says, in the diagram, ADE is a triangle having BC parallel to ED. It's already indicated. It is also given that AB over BC is 1:3. So if this is 1, we can say this is A, and that we can say 3A. Right. And then we're also told AC is 3 units, so that's indicated. EF is 6 units, also shown. FD 3 units, also shown. And CG is X units. Okay, fine. And then we are to calculate, given reasons. See again, the question says calculate. Given reasons, the length of CD. Okay, not a problem. So if we look at this triangle, so if we look at that big triangle, EDA or ADE, let's just call it ADE. So this is 10.2 with 10.2.1. So we want the length of CD, so we can use this triangle in triangle ADE. Okay, so we can see that it's easy to just go for the jugular here. We can even say CD over, if we look at that, we're gonna say perhaps AC. This should be equal to, maybe we can say CA if we like. It's not a big deal. CD, okay, CD over AC, it's not really a big deal. It's gonna be equal to BE divided by AB. Right, the reason here, this is the proportionality theorem. And it only works when BC is parallel to ED. Otherwise, any other line that is not drawn parallel would not give us the proportionality theorem. So never forget the parallel lines. For someone may lie and give us wrong things. Now CD is our target, divided by AC, which is 3 units. This is equal to BE, that is 3A, divided by AB, which is A. And of course, these do the thing. And we cross multiply that. So CD is going to be 3 times 3. This is 9 units. Right. Very easy. Statement and reason. Substitutions and answer. Okay. So 10.2.2 says calculate the value of X. Okay. You can see that it's a bit of marks there, so we need to think about it very clearly as to how we're going to solve this. So we know CD and we know X. Right. So what are we going to do here? Well, what we can do, we can actually find AG, right? We can find AG. And once we find AG, we then calculate CG. Easy. So we can say in triangle ADE still, but looking at it in terms of now that line FG parallel to AE, we can say in there, looks nice and easy to suggest that basically AG, which is what we want, divided by AD to avoid that GD is going to be equal to EF divided by ED. Again, this is prop theorem with FG parallel to AE. Alright, so we substitute. AG is basically 3 plus x divided by EF is going to be 6. No. What is this now? This is divided by AD. AD, remember, it's going to be 3 plus CD, which we found to be 9, equals EF, which is 6 units, divided by ED, which is going to be again 6 plus 3. So we need to show some calculations nicely so that we can work out our solutions. So this is 3 plus x over 12 equals 6 divided by 9. Right. So we know that we will cross multiply here and solve. So when we do that, we are going to have basically, maybe let's simplify this a bit. So 3 goes 2 times and it goes 3 times, okay? That makes life a lot easier. So this means we get x is equal to 2 over 3 times 12, right? And all of this divided by, no, not divided by, but minus. All of this minus 3, ne? Because we're going to have to transpose that. Okay, so therefore our x value is going to be this once, this 4 times, 2 by 4 is 8, 8 minus 3 is 5 units. Okay guys, I hope I'm not making any errors. But yeah, if you see any, please shout. At this stage, it's injury time. Now, we have 10 point... You want to tell me that I've finished this page? Aibo. We've got 10.2.3. We have to find the length of BC. Okay? BC is this length over here. Okay? How do we find that? Obviously, proportionality works, but in such a way that we can say that side over the entire side of ED maybe is going to be equal to A, like AB divided by AE. So this is more like similarity in a way, but it's still proportionality also. So we can still say in triangle ADE, what do we know? We know that essentially, what are we looking for? BC. Okay, we can just simply say BC over AB is going to be equal to ED over AE. Again, remember proportionality theorem always works. As long as the right approach is used, you can say BC parallel to ED. Now, what do we know? We substitute. BC over AB, this is A, is equal to ED. ED is 9 over AE. This is 4A. Okay, so we just cross multiply there. So what are we going to have? BC is equal to 9 over 4 units. Again, we can go on and do what we call this We can go on and do decimals, but they're not necessary here. Let's see, is it terminating? 9 divided by 4. Yeah, it's 2,25. Okay, that's fine. It's actually terminating. Okay. Great stuff. So this one, I don't know why 4 marks, but yeah, whatever statement, maybe a reason, substitution, and answer. Right. Move on. So 10.2.4. We now have to find this ratio right here. Okay, so this is what is inclined to the higher grade stuff or status, but it's not really that high a grade that is needed there. So we want the area of triangle ABC, okay, and triangle GFD. So it's these two. Right, so what is common about these triangles? We can see that this angle is equal to that angle. Yeah? So those are corresponding angles. You see? Yeah. And that is the best thing we can do. Now what are we missing? We're missing GD. But GD, since we know the value of X and we know CD, we know what GD is going to be. So we can just set up the area rules on those two triangles. So we can say, well, area of triangle ABC divided by area of triangle GFD is going to be equal to, the numerator is going to be half, say half AC times BC times the sine of the included angle C, divided by half of GD times FD times the sine of the angle D. Right, so what we're going to say, that and that quickly goes away. So we will say then this is equal to AC times BC times sine of angle D. I'm just going to write angle D quickly, divided by GD times FD times the sine of angle D. Then I put a reason here and say angle C is equal to angle D. These are corresponding angles with BC parallel to FG. Easy. So we continue. AC is 3 units times BC. We found out this is basically 9/4. And then all of this is divided by, oh wait, yeah, after this, these ones take care of each other. So GD is basically going to be, let me see, GD, by the way, what did we find CD to be? 5 units, no, 9. CD was 9 units, so this is 9 minus X, which we got 5, right, times FD, which is 3. Okay, so this is equal to 3 by 9, that's 36, divided by 4 is, wait, 27. Okay, I was surprised now what's going on. So this is 27. multiplied by 1 over, now this is 4 times 3, that's 12, isn't it? Yes. So 3 goes here 4 times and 3 goes there 9 times. So basically the answer here is 9 over 16. Now this is the ratio, we stop it here. Okay guys, I may have made a mistake perhaps. You never know with these kinds of calculations, but at the same time, the approach is clear. We need to find some common things so that we can eliminate. Then we use the sides that we can determine the values of or the sizes of. Okay, so essentially, setting up the area rule for each, we get a mark, and stating that these two are equal, and the reason they're corresponding angles, that's a mark. Calculating that side, what is this side? GD, yes. Calculating GD, that is a mark. And the final answer, that also is a mark. So I'm trying to think now. What do I do now? I'm supposed to get 5 marks. Maybe the area rules for each. Right, that makes sense. So we can have our 5 marks. Again, guys, this would have been an easy 23 marks to score. Saying that 6 marks of this is just a proof, which no one should say they do not know how to do. And the rest was just questions that we needed to work through. Great stuff. All right, guys, so here are some questions that you may want to try before you get to the next exam, and try to use the similar idea as we are using here. Of course, they come in different flavors, but this helps to get you ready to write the exam tomorrow. Here's another one that you guys can try. Remember, guys, don't always think you have to try the difficult questions. Sometimes it's not about the difficult questions per se. It's all about building the momentum and getting to the rhythm. So some easy questions can just do the job better than the difficult ones, which dent your understanding a bit. They even dent your confidence. Sometimes you feel overwhelmed and lost. So some easy questions during practice are nice, provided they are used as a means to see how this thing works well and how to then see beyond that in the tough questions. Okay, as I said, those who have our group's WhatsApp access, drop a question there, we sort it out, and yeah, do your best. All right, guys, so here's another one that you may want to try. Again, it's a very similar question to the ones we have done. So there's a ratio of areas there, then there's a ratio of the sides. So again, try these questions, guys. Don't give up. Just put the fight. You will see these things become a little less difficult once you can do your best, and sometimes get stuck, then somebody helps you, then you become better. But if you don't try, you will think you have it all under control, because it's easy to watch somebody do this and it's easy to think you understand, but to actually do it, it's another thing. So do the things, guys. Okay, guys, let's have a look at this next question, just to build up some strength. Right, question 11 says ABCD is a parallelogram. So what is a parallelogram? We know in a parallelogram we've got two opposite sides that are equal and parallel to each other. So that side is going to be parallel to that, and they will not just be parallel, but they are equal. So that's what we know about a parallelogram. What else do we know about a parallelogram? We also know that the diagonals of a palm bisect each other, at a common point. So we see that these intersect at point F. Right, so this is just pure revision, guys. So please don't be afraid when you see these scary structures. It's just properties of these geometric figures. Now, FE is drawn parallel to CD. We can see that. AC is produced to P. Once we produce a line, it becomes a complete straight line. Right, such that PC is equal to 2 times AC. Can you see that? PC is equal to 2 times AC. So if I may show this, although this is going to be a bit rough to do, but I can say this AC, like that, going around, and that. This is giving us the ratio, basically. If we divide by AC, we will see that this is 2:1. So we can say this is 2A, and then we can say that is A. Mind you, the A is for AC, okay? Right, so this is very important to not forget. Then we are told AD is produced to Q, okay? AD is produced to Q such that DQ, AD is produced to Q such that DQ is 2 times AD. So if this is B, this is going to be 2B. Okay, always choose a multiple when given a ratio, because the ratios again can be given indirectly as an equation, different from how it is normally given, but still see that this is the same thing. All right, so what can we do with what we have? Well, there's not much. We just try to respond to the questions. So 11.1 says show that E is the midpoint of AD. Now the question is to show E is the midpoint of AD. How could we do that? We will say here in triangle ACD or ADC. Right? What can we say about that triangle? We will first say, well, we know that AF is equal to FC. Why is that? We know that diagonals of a parallelogram bisect each other. Okay? And we can see that happens at point F. So we can say essentially, therefore, E is the midpoint of AD. Again, what is this? This is the converse of the midpoint theorem of triangles. Because we know that the midpoint theorem will tell us that if we've got a line drawn parallel to the third side and essentially cutting the one side in half, it will also cut the other side in half. Of course, this is some special case of the proportionality theorem, okay? So as long as we know that this is part of the midpoint theorem, we go for it, okay? Converse or midpoint theorem, it doesn't matter, guys. Sometimes that one gets me confused as to what is the converse and what is the theorem. I just understand how it works more than I probably understand how to state it. Yeah, okay, that's the one, guys. It's not a lot, it's just 2 marks. As we can see, we get a mark for that and we get a mark for that. Straight and 2BS. 11.2. We need to prove that PQ is parallel to FE. Okay, All right, okay, that's not a problem. We can see that, okay, in triangle, let's show it nicely. So in our blue outlined triangle, we can see that this is APQ. What we will see is that, well, AC over CP is going to be equal to A over 2A, which is going to be equal to 1 over 2. Right, because these ones are going to do the thing. You can say also, we understand that AD over DQ is basically B divided by 2B. And the B's do the B things and leave us alone, please. This is a half. From here we can see that essentially AC over CP is equal to AD over DQ. Right, because each one is a half. And if this is the case, we can conclude that CD is, this was PQ. CD is parallel, not CD, man. Yeah, CD is parallel to PQ, right? What is the reason here? This is the converse of proportionality theorem. Right, no issues about it. Now, we can say since FE is parallel to CD, right? That was given. We can say therefore PQ is parallel to FE. Each is parallel to CD. Right, so again guys, try to make your arguments as valid as possible. Don't just jump to conclusions without being clear as to what is connected to what, where, and how. Right, so this is just 3 marks. Of course, this stuff was given, guys. Although we just had to work it out, it was essentially given. We could have used those given equations to still get to the same answers. It's not a big deal. But this conclusion is key. Okay, maybe this conclusion is key. In fact, this was given. Let's not even bother. I think this is the story right there. Makes sense? Yep. Or one could still consider these together as perhaps the extra mark. Let's get to the last one. So 11.3. Now 11.3 says if PQ is 60 centimeters, okay, and we need to calculate the length of FE. So this is not really a big question. Don't even cry, because we know that the midpoint theorem with FE kicks in. So all we need is the size of CD. So we can say safely that CD divided by PQ should be equal to, we can say, okay, let's not do crazy things. Let's not do crazy things. Let's say CD over AC should be equal to PQ over AP. Right, This is proportionality theorem. We know that CD is parallel to PQ now, right? So we go on. This implies that CD over AC, we said that was A equals PQ. This is 60 divided by AP. This becomes 3A. Cross multiply that. We can see that CD is going to be 60 divided by 3. This is 20 centimeters. Okay, we can say therefore, or we can say however, or we can say then. Let's just say then we understand that FE, or let's just say 2 times FE, or in fact FE is equal to half the side of CD. You can just say midpoint theorem. Midpoint theorem, right? Easy in that triangle. So this implies that FE is going to be a half of 20. Therefore, FE is 10 centimeters. Don't forget the correct unit of measurement given. So again, guys, this is key. Perhaps substitutions are key. Getting this is key. That statement and reason and the final answer. So not a very difficult 10 marks to score, but at the same time it just shows that one needs to stay awake and know how to pick the right fight and fight it the right way. Okay guys, please do as many examples that include these kinds of structures. It is usually a part of the exam. Alright guys, so let's have a look at this question 9. Again, just to drive home the idea of proportionality theorem when combined with circles. Of course guys, I'm not going to exhaust all questions, but I will highlight those that you as the student at home practicing for the exam can have a look at after seeing this video. Right, 9.1. I'm rushing now. Let's go for the stuff. In the accompanying figure, AB is the diameter of circle ADCB. ADCB, and we can see these points are at the circumference of the circle. And we know that they essentially would form a cyclic quad if they were to be joined at DC like that. But that's not the case now. So they are just concyclic points. Now, concyclic points can either give us a cyclic quad, or in a way, they can give us what we call angles in the same segment. Right. Now, chords AC and BD intersect at E. We can see it. EP is perpendicular to AB. Again, it's indicated here. Right. So, question is, what can we do with this business right here? Okay, we always ask ourselves that question all the time. Now let's see. We know that this angle equals this angle. It is angles in the same segment subtended by, in fact, this is crazy. They're subtended by the diameter, so they will be 90 degrees. Angles in the semicircle. They are together in the same segment, okay? Not a problem that we can see. And now this is already suggesting something, you know. So what we see there is 2 cyclic quads within what would have been a cyclic quad, because that angle is equal to that. So the exterior angle is equal to the opposite interior angle. So this is a cyclic quad. That 2 and that, the opposite angles, are supplementary. So that becomes a cyclic quad. Right, so if this is the case, we can safely conclude that this angle is equal to that angle. That's also an exterior angle of a cyclic quad now that we know it. And likewise, we can say this angle is equal to that angle. That's the exterior angle of a cyclic quad. Again, guys, we don't want to mess up the diagram by making it too messy. We just stop before we go too far. Right, let's get to the questions. 9.1, prove that triangle BPE. So we are looking to compare those two triangles. These outlined red. Okay, so we need to prove that they are similar. Okay, we know that this is easy. In triangle BPE and triangle BDA. Okay, what can we say there? We know that B1 is common. All right, easy. Next one, we know for a fact that essentially angle P1 plus P2 is 180 degrees. These are angles on a straight line. Okay, this concludes that basically 90 degrees plus P2 equals 180 degrees. Therefore, angle P2 is 90 degrees. Okay, be methodical, guys. Don't jump to conclusions. Show us the way. Show us the way you walked so that you yourself can see when you're making mistakes, or at least you want to trace a mistake. Right, now what can we do next? We can say also we know that angle D equals 90 degrees. Why? This is the angle in the semicircle. Right? So angle in the semicircle is 90 degrees. We can say therefore we get that D. Okay, maybe we started with BPE. We can say P2 is equal to angle D, right? Each equals 90 degrees. Now, we need two sets. The third one will fit in, guys, so it's pointless to even look for it. So what we need to say is just that, therefore, these two triangles, BPE is indeed similar to triangle BDA. Reason, angle. We don't really need the third pair. It almost always fits. In fact, not almost. It always fits into place. Right, 3 marks. So, folks, I think perhaps knowing that P2, but this one is too weak though. Maybe this one is much better. That is true, and then linking the two, and then maybe the answer, I don't know, whatever. Anyway, guys, at this point, it's injury time, so let's just go to 9.2. 9.2 needs us to show that BP over BD. So where's BP? This one. Over BD. Okay, BD is this one. Okay, is equal to PE over AD. Okay, is that so? It looks like these triangles we just spoke about. Let's start it nicely and say BP over, now we look, BP in this triangle is opposite angle E3. E3 would be equal to angle, E3 would be equal to angle A1 plus A2. And the side opposite that is BD. Okay, so this is good, BD. This is equal to, we look at PE this time, over. Now PE is opposite B1. B1 is common. The side in the big one is AD. Remember, the sides that make up these proportions are the sides opposite the equal angles. So remember that. Each proportion like this or ratio is made up of the sides that are of the sides that are opposite the equal angles in the two triangles. So this is why you don't need to really care too much about how these triangles are named. So we can just say similar triangles in 9.1. Easy. We don't have to say much, so statement and reason is good enough. Right, so 9.3. 9.3 says we need to prove AB squared. Where is AB? There is AB. So we're saying the square on AB is going to be equal to BD squared. Where is BD? BD is here. All right. So BD squared, of course, this looks like Pythagoras theorem, isn't it? Yeah, it looks like Pythagoras theorem. But now, Pythagoras theorem in the big red triangle would then have to include this side squared. Right? Right. So AD squared. But what we see now is a big business here. But this big business is not such a bad big business, you know. It's not a bad big business because we can clearly see that from above we can actually isolate AD. If we can isolate AD, we will end up with PE times BD. Can you see PE times BD over BP? So in a way. But now in Pythagoras, we square that, so this whole thing is going to work out. So let's start nicely and say, well, in triangle ADB, there we understand that AB squared is going to be equal to BD squared plus AD squared. This is Pythagoras because we saw that that is a right angled triangle. Now we've got a story, but we understand that BP over BD is equal to PE over AD. This is proved above. It follows that when we cross multiply here, we will see that AD is going to be equal to BD times PE divided by BP. Right, we can say then this means AB squared is equal to BD squared plus, instead of AD here we will write BD times PE divided by BP all squared. Therefore, AB squared is equal to BD squared plus. Now, exponential rules come in. We square everything that is a product and a ratio. Nice and easy. Okay, not a very difficult question, but it may look scary from a distance. Again, it's not about doing difficult questions per se. It's all about doing the work the right way. How would we score marks here? Well, stating this in terms of Pythagoras, that's key. Isolating AD is key. Then substituting and all the squaring here. So 5 marks. Wow. Interesting, if not interesting. So we can say fine, maybe these ones and that one. I don't know. I really don't know. Either way, sometimes you get a mark for statement and reason, you know. Maybe we can say this is the answer and say here what was key was to make the statement and the reason for it. You see. Okay guys, this was not a very difficult 10 marks. As you can see, alright, so do as many questions as you can find, sometimes that may look similar or not necessarily similar, but where we just dance around some ideas where we have to handle some hectic stuff. Alright, now let me just show you what you can do next. Alright guys, you can take down this question and enjoy it. And of course, if you struggle, I'm here, whether in the comment section of this video or in the WhatsApp group if you are in our group. This is another question to look at. And of course, try to understand how you are moving from one step to the next. And the question may have a diagram that looks complex, but you can see the mark allocation is not necessarily scary. But remember, examiners can hide the complexity of a question by allocating small marks for 2 reasons. First, to confuse you, to think it's simple and you get stuck in it and waste your time. To check if you are able to make the right decision at the crucial moment. Second, to say even if you lose marks here, you should not lose a lot, because they know it's almost impossible for all the students to get it right. So again, try it out and see what comes out. Struggle, let us know. We will help. Okay guys, let's have a look at this question 11. It looks a bit interesting. Let's just see. Sometimes I like these very unusual questions. You know, makes the learning experience all worth it. But guys, I'm so tired, I need to sleep. Hey. Now ABC is a right angled triangle and it's indicated 90 degrees in that vertex with B equals 90 degrees. D is a point on AC such that BD is perpendicular to AC. BD is perpendicular to AC. Again, it's shown. And E is a point on AB such that DE is perpendicular to AB. Again, that is shown. E and D are joined. Nice. Right. So what can we see immediately when those are joined? If this is 90, that is 90. So these lines are parallel. Why? Because the corresponding angles are equal. That and that are corresponding angles. Whenever corresponding angles are equal, the 2 lines are parallel. Right, so what else can we do? Well, you can see that there's more given. AD is to DC. AD is to DC is 3:2. So if we say this is 3A, this is going to be 2A. Please choose a multiple. It's not a length, it's a ratio. And it's always the simplified ratio, meaning it may have come from something else. Right, and we're also told that AD is 15 centimeters. Okay, great. Now, we need to prove that BDA is similar to CDA in terms of those triangles. Okay, let's see. So we're comparing those two triangles, BDA and CDB. Okay, so what we have here, this is 11.1 in triangle ABDA and triangle CDB. What do we have? We know and understand that these are angles on a straight line, so they should be each 90 degrees. Well, we can start by saying essentially angle, I 3 marks, or corresponding angles are going on, and they're not going to help us there. The corresponding angles do not help us, but angles on a straight line will. All right, let's just say, well, we understand that technically D1, okay, let's just call it BDA, plus D3 equals 180 degrees, angles on a straight line, right? So this implies that BDA plus 90 degrees is 180 degrees. Therefore, BDA is going to be 90 degrees. Very important to say this. Right. After this, we may have to conclude that indeed BDA is equal to angle D3 on the other one, because each is 90 degrees. Well, we could have said it, but in fact, I don't know why I didn't say it. Should have said that, but it doesn't matter. Now, the next piece here is quite interesting, is it not? Yes, it is interesting. The next piece here is a bit silly. The next piece is a bit naughty, but perhaps nice, you know? Yeah. I'm trying to think now what would be good to do here. All right, so this one was easy, and in fact I made it a big deal, but what can we say next? What can we say next? Now I can take this angle, add it to this one, I get 180. Sorry, 90, because these are complementary angles in the big one. And then I take that same angle and that, and then I would see that, okay, let's see, this and that is 90 in the big one, which means this is going to be 90 minus that angle. And then this and that are 90, and then, yeah, that works. That works. We can say also, I know that angle B2 plus angle C plus angle D3. In fact, let's not waste time, guys. Yeah, let's just say B2 plus angle C equals 90 degrees. Okay, maybe you won't understand. Maybe you won't understand. Equals 180 degrees. Sum of 3 angles in a triangle. At this stage, now uyazibonela uba zeziphi ezi angles umuntu ozokumakisha. B2 is what we're interested in, plus x plus 90 degrees equals 180. Therefore, B2 is 90 degrees minus x, okay? Great, we can say likewise. We also understand that angle A plus angle ABC plus angle C is equal to 180 degrees. Sum of three angles of a triangle, or in a triangle. So angle A plus 90 degrees plus x is 180 degrees. Therefore, angle A is basically 90 degrees minus x. Can make a conclusion that therefore B2, where does B2 belong? In BDA? No, angle A is equal to angle B2. Right. H is equal to 90 degrees minus x, okay? If we prove two pairs similar, we can say therefore triangle BDA is indeed similar to triangle CDB. Again, this is angle, angle. So just two pairs is good enough, guys. As you can see, these 3 marks are not that cheap, although you would think they are. No, they are not. So yeah, it's blood, sweat, and tears, I suppose. Is blood, sweat, and tears. Tears. There are many ways, of course, one could have done this, but it doesn't come cheap either way. Right, so this is very important to conclude. This is very important to conclude. And of course, as you can see, the rest is our problem, guys. Yo, interesting stuff, I tell you. But perhaps the last one, it's a weak one. We can think and look into getting the others. But again, they are similar. So which one will we mark? Which one will we ignore? Right. So 11.2 says calculate BD and leave the answer in set form. Okay, we need BD. All right, we can use the proportionality of these sides. So we want BD. BD belongs to the one triangle. And if we look at BD in terms of the small one, it's opposite angle C. But angle C is now equal to angle B1 in essence. The side opposite that is going to be AD. This is going to be equal to, we can now look at we want the side that we know, CD, divided by CD is opposite that B2. B2 is equal to A, side opposite that is BD. Alright, so again we can say similar triangles in 11.1. Right, we cross multiply. This implies that BD squared is going to be AD times CD. This implies that BD squared is AD, we're told it's 15 centimeters, into CD, or DC. Hey, yafika ingxaki. Okay, let's see. CD is 2 portions of 3 parts. So basically this is 2A over 3A. Ne? Or maybe let's say we need the value of A. Okay. Yeah, I think we need the value of A so that we can find what that is. So we can just write it as 2A. Okay, no problem. We can say, but We know that 3a is equal to 15. That was what we were given, right? Right. Yeah, so this means that a is 5 centimeters. We can say then BD squared is 15 times 5 times 2. This implies that BD squared, not BD squared, but BD is going to be the square root of 15 into 10. Therefore, BD is going to be the square root of 150. So this is 5 root 6, but now we're told to leave our answer in said form. So we can do that. So this is 5 root 6 centimeters. Okay guys, so hey, yeah, it's nice questions to look at, but time is not really allowing us. This is important. So calculating the value of a is important, and the answer. The rest is the problems of the problem. Okay, all right, okay. Let's do the last one. Whoa. Okay, the thing just blinked a bit. Let's answer 11.3 now. Now 11.3, we need AE, this one. We need that one. And again, we leave the answer in set form. So how are we going to do it? Well, we have found BD. We know AD, but we don't know ED. We don't know ED. So this means our best shot is to find ED or to find BE. Okay, if we can find BE, that could work. But now how will we do that? Well, let's see what we can do. If we look at this triangle, if we look at that triangle, we'll appreciate that that triangle looks similar to this one, right? Right, because this E2 is going to be 90 degrees and that is 90 degrees. And we know that this B2 is going to be equal to D2 alternate angles. And so the two pairs match and everything works out. So we can prove similarity here, then work out ED or BE, whichever we choose. But I think the best thing is to find ED so that we can zoom into this triangle next. Right. So let's start and say, well, in triangle BED and triangle BDC, I don't really care here, but I just happened to I just happened to do it. I just named them. I don't care how. Right, number one, I know that angle E2 is equal to 90 degrees. At this point, okay, let's not be silly. Angle E2 plus angle E1 is equal to 180 degrees. this is angles on a straight line. Right, so this implies that angle E2 plus 90 degrees equals 180. Therefore, angle E2 is 90 degrees. We can say, therefore, E2 is going to be equal to D3. H is 90 degrees. We can say also, we know that essentially line BC is parallel to ED. We can say this is because corresponding angles are equal. We state them. This is angle E1 equals angle B1 plus B2. These were given equal to 90 degrees. So we can say this implies that angle D2 is going to be equal to angle B2. These are alternate angles with essentially BC parallel to ED. Okay, not cheap stuff, guys. Expensive things here. So we can make a conclusion that the triangle BED is similar to triangle BDC. Angle. Now this then gives us what we need. What do we need, guys? We need to find ED. ED over, now ED is opposite B1. B1 is equal to angle C in essence, and the side opposite that is BD. It's going to be equal to, we're looking for a side that we know in this triangle. Why do I feel like I shot myself on the foot now? Why? Why? It looked like it was taking me home, but now it's not. It is not taking me home. Because there are just too many sides I don't know here. Dang. AE. You winner. Okay. This question looks crazy now. What is going on? Hirahalang biano. Yeah, this looks crazy, man. It looks crazy. I'm thinking and I'm not really finding a quick way. Except for a long way again. You know? Except for a long way again. Okay, guys, let me think for a second. I think I went about it the long way, which is not going to help me. Yes, it's going to be long and tiring, but I don't have time now, guys. See, what I'm thinking is that I use this triangle to find BC. Because I already have CD. Then if I can do that, I can then find this side in the big triangle using Pythagoras. From that Pythagoras, I can use the proportionality. Yeah, let's do that. It looks a bit more clearer. This is punishment. Yes, this will work, guys. Sometimes this is the only way. This is the approachable way, but it can be lengthy. I don't think I like it. Let's get to business now. 11.3. We can say in triangle BDC, we know that BC squared is going to be equal to BD squared plus DC squared. Pythagoras. So this implies that BC squared is going to be equal to BD. We found out it's 5 root 6 squared plus DC. We saw that DC became 2 times 5, which is 10 squared. You can say therefore BC is going to be, now we're taking the square root. We're moving fast. Okay, maybe let's do it. Hey. Sometimes you've got 5 root 6 10 squared. Let's just be patient. This is the square root of 5 root 6 squared plus 10 squared. This gives us 5 root 10 centimeters. We can say here also, we know that in triangle, in fact, let's not waste time, let's just go for the jugular. We also know that AC squared is equal to BC squared plus AB squared. This is Pythagoras again. In triangle ABC. Right, so this means AC, we found that to be 15 plus 10, right, all squared, equals BC, which is what we just found, 5 root 10 squared plus AB, which is what we know we want. Okay, so this implies that AB is going to be the square root of basically 25 squared minus 5 root 10 squared. So therefore AB, so we've got the square root of 25 squared plus, no, minus 5 root 10 all squared. So this gives us 5 root 15 centimeters. We can then say, when did we ever mention that parallelity there? Never. Wow. We still need that parallelity before we can say something. We can say, well, we know that basically B1 plus B2 is equal to angle E1, right, equal to 90 degrees. This is given. This proves that essentially BC is parallel to ED. We can say corresponding angles are equal. Now we can say then yo we can say now here AE over the whole side of AB is equal to AD over the whole side of AC. Prop theorem with AD parallel to BC. We just proved that. We substitute AE is our interest divided by AB, which is 5 root 15. It's going to be equal to AD, which is 15, divided by AC, that's 15 plus 10, that's 25. Right, we cross multiply this. We'll see that AE is going to be 15, 5 goes 3 times, and 5 goes 5 times, into 5 root 15. And we can see that that will go. Therefore, AE is going to be 3 root 15 centimeters. Okay, again guys, yeah, I bailed, but this still took a bit longer than was expected. I think here what is more important is this, 1, 2, 3, 4, 5. So of course one of the Pythagoras or Pythagorean theorems needs to be given a mark, I suppose. Can give it the 6 marks in the bag. All right guys, that is it. It's not so easy, but doable. So this was a rather expensive 12 marks, to score. All right guys, at this juncture I would like to perhaps do one question which is a bit more in the type that you guys get scared of, and we call it a day. It's too much now. All right guys, so let's take this one as the last one for today. And what will remain now, I'm going to point at some questions that you may want to have a look at. Remember guys, this is not necessarily just purely for tomorrow, okay? This will help even for the preparation of the finals. So take this as, a long-term plan rather than a short-term kind of plan. You may skip around, choose things. Of course, I'm suggesting things. I think, let me not talk and start doing the work, because if I start talking, I will never finish. Right. Let's look at this question 9. I am feeling a bit beat now. Right. So I think we've done quite enough for Euclidean. You should be a bit happy-ish. There's many questions in the channel, guys. You should have seen how things are done. There is no way I can exhaust all these questions. This one says in the diagram below, ABC is drawn in the circle. Okay, there is ABC. We see it. It's a cyclic triangle, if you will. And remember, once you see a cyclic triangle, you want to look for the 10-chord theorem. Is there any 10-chord? This looks like what would be, let's read. TA and TB are tangents. Yes. So these are tangents. Come on, Wenaman. Are you straight line, Naledo? I see, so too. Into endingayazi. Okay, masiza mukugqibela. Yes man. Yeah, wena asiyeke yangiqhela. So these are tangents. If these are tangents and they come from outside, it means they will be equal. Tangents from the same point to the same circle. And if this is the case, this is highlighting the fact that that angle is going to be equal to that angle. Okay, nice and easy. What is next? The straight line THK. THK is parallel to AC. Parallel to AC, okay? With H on BA and K on BC. Yeah? AK is drawn. AK is drawn. And let A3 equal to X, okay? Now we've already made our connections that tangents from the same point outside the circle are going to be equal, making those two, the angles opposite the equal sides in triangle TAB or BAT. But the 10 chord theorem would still hold true for that kind of a situation. Okay, we see you, we see you, we see you. What else can we say and do? Sometimes there's not much, okay? Sometimes there's not much. But in terms of parallel lines, we see that this is going to be equal to that. Right, so if that's the case, these are the corresponding angles with those lines parallel, okay? This already says this is also a cyclic quad, this triangle. It becomes a cyclic quad, is it not? Because if we look at that angle being equal to K, that means there's a circle around B, K, and H. Okay, but that's just a thought for now. Right, these are things to think about, things to consider. Anyway, guys, we can see the damage that we can cause here. So there's more, but I'm seeing these alternate angles. This one is equal to that. These are alternate angles with these lines parallel. Is the letter Z, if not Z. 9.1. We need to prove that K3 is equal to X. Wow, we've done it. So we can say, okay, all right, okay. We know that essentially angle C is equal to angle A3 and so equal to X. This is the 10 chord theorem. Right. They said, but we understand that angle C is equal to angle K3. This is because of the corresponding angles with TK parallel to AC. Okay, therefore, yes, K3 is equal to X. Done. Okay, so that's it. Nice and easy. So there's not a lot to say here. Statement, reason. You can say statement, reason. The answer is pretty obvious, right? 9.2. Prove that AKBT is a cyclic quad. Okay, so AKBT is this big one. So that is the cyclic quad that we need to prove, right? So what can we say, guys? We can clearly see that this guy is equal to that guy. So those become the angles in the same segment. If they are equal, then there is a cyclic quad. As you can see, it's just 2 marks. All right, so we can safely say, well, we understand that K3 is equal to A3 equal to X. This is proved above. So you can say, therefore, indeed, AKBT is a cyclic quad. we can say converse of angles in the same segment. Okay, that's it. So obviously linking those two, even though we can say each is equal to x, in fact I should have just said that rather than proved. Okay, right, so that's much better. So 9.3 says we need to prove that TK bisects AKB. Okay, TK bisects AKB. So it means we need to prove that essentially K2 is equal to K3. And of course, if this is a cyclic quad, this indeed becomes equal to that. Reason is these are angles in the same segment subtended by chord TA in that cyclic quad. So we can say, well, we know that basically B2 is equal to, but do we know anything about B2? Yes, we do. B2 is equal to angle K2. Right. Did we mention B2 here? We did not, so we need to start mentioning B2. Okay, we can say this is equal to K2. Right, these are angles in the same segment. Right. In cyclic quad AKBT. Right, we can say also we know that that same B2 is equal to angle A3. Why? Because we see that we can say, perhaps let's start by naming the two things that are equal. We can say also we know that TB is equal to TA. These are tangents from the same point, okay, outside the circle. So this implies that B2 is equal to A3. Right, what can we say? Angles opposite equal sides in triangle TAB. There was a drink called a tab. Where is it? So now guys, what do we know? We know that B3 is equal to wait. We proved above that K3 was equal to A matot. Okay, we just need to prove that K2 is equal to X. If this is equal to A3, so we can conclude that therefore we appreciate that K2 is equal to X, and therefore we can say TK bisects AKB. Why? Because K2 is equal to K3. As a result, I am very tired. Very. But sometimes you got to work even when you are tired so that you can win, guys. So this is good. And this is good. This is good. And that is good. So easy for marks. No complications, nothing. Right, so let's do the last one. We do the last one. We are told that, no, it's not the last one. Goodness, oh, I'm in a hurry. We need to prove that TA is a tangent to circle passing through A, K, and H. Let's locate that. Okay, so if we look at this outlined blue triangle, we need to prove that this is a cyclic triangle. And indeed, you see this is equal to that, so the converse of the 10-chord theorem. So that's fine. So we can say, well, we understand that K2 is equal to A3. Okay, we can say H equal to X. So, or we can even say proved above, because we proved A3 is equal to K2. I mean, you can say H equal to X or proved above. It's not a big deal. We can make a conclusion that indeed TA is a tangent to circle passing through A, K, and H. Reason, this is the converse of 10-chord theorem. Okay, good stuff. So again, folks, by just linking those two and the last statement with the reason is good. So last question says, S is a point in the circle such that point A as K. Okay, we can see there is point S. So it says now A, S, K, and B are concyclic. Let's do the construction. What colors? Maybe brown. So A, S, K, and B. So we go to K and then B. So we can go on. This is what this is suggesting. Okay, we go on and on and on and on and on. So this is saying those points are concyclic. Now, if these points are concyclic, it means that becomes a cyclic quad. Okay. All right. Okay. All right. So now it says, explain why ASBT, ASBT, wena ngathi ufuna ukweSpanish nje wena, some highlighter kanjani lo ASBT wakhona. ASBT. So this is going to cut stuff like this now. Of course, this is not necessarily here. It's on Moshe Lagepa. I know it. So this ASBT, why is it a cyclic quad? All right. Why are those points concyclic? This question, but anyway, if we look at this and look at it good, My idea of fun here, although I don't know if it's gonna work, guys, some questions can be horrible. I am definitely stopping after this. I'm not taking any more questions. So let's see, ASBT, why is it concyclic? Now, how do we use our first issue there? We see that this BS part is a chord, should we say a diagonal of our quadrilateral ASKB. And we also have AK intersecting that. So that should, in a way, create angles in the same segment. What do those angles help us with? So what we will see nicely is this. Let's look for something. Maybe black is black like Mimos. But we will see that if this business here is a cyclic quad, it means this angle must be equal to that angle, right? Because those become angles in the same segment. So let's have a look at it nicely. Okay, we've got the black thing out. So we know that that angle should be equal to this angle. Those are angles in the same segment, provided that we were told the points B, A, S, and K were concyclic. Essentially, they were joined, so they form a cyclic quad. Okay, now that seems okay. Now, if we look again, we will see that this very same angle that we are looking at, which is ASB, for example. Okay, not yet. I want to see, but if that angle, remember we had a yellow cyclic quad still. The yellow cyclic quad, I know that angle K2 plus K3 plus that angle T1 plus T2 are essentially opposite angles of a cyclic quad, the yellow one. We proved it already. So we can use that to get us somewhere. So we know that, okay, this is a silly question, but just for 2 marks, I don't know, maybe I'm missing something, 9.5. To do this 9.5, we can safely say, fine. We can say, well, we understand that this angle, can say angle ASB, right, is equal to angle AKB, right. Now these are angles in the same segment of cyclic quad ASKB, right, because we were told those points are concyclic. In essence, they make us a cyclic quad. Now we can say, all right, okay, this implies that basically ASB is equal to 2x, because AKB is x plus x, which is 2x. So there's no need for us to explain much. We will say then, but we understood that angle T, okay, let's not even call it T1 plus T2. We can say ATB plus angle AKB was equal to 180 degrees. These are the opposite angles of cyclic quad. That one was what did we call it? AKTB, right? Because we proved it above to be a cyclic quad. So this implies that angle TB is going to be 180 degrees minus x. Let's move on to the speed of light. Kuyabaneka liyaduduma izulu. Hey, ungena amanzi endlini. We can say then, okay, then we will understand that the very same angle ATB plus angle ASB, sorry. ASB. Not x when I'm at 2x the spices. Right, so now this is ATB. What did we get ATB as? This is 180 degrees minus 2x plus. Now ASB. ASB is tolbangbani go 2x naye. So kwenzeka imilingo, yes, therefore ATB plus ASB is indeed a supplementary sum. Now, if it is a supplementary sum, we can then conclude that indeed these points A, S, B, and T are concyclic, right? Right, but maybe let me do the honorable thing, just move this up a bit. There's no point in squeezing myself like that, so that I can have enough time to make the conclusion. Yeah, that is the one. So maybe we can wrap off this part now. So we can say after this, could we move this further up? Yeah, but let's just conclude. We can say therefore A, S, B, and T are concyclic, not concyclic. They are concyclic. This is the converse of opposite angles of cyclic quad. Okay, that's the converse of opposite angles of a cyclic quad, because we proved that those became supplementary, and essentially proving that that should be a cyclic quad. And if that is a cyclic quad, the points at the circumference become the vertices of that quadrilateral at the circumference, which makes it a cyclic quad. So that was a bit of a silly question. It's a low-key higher grade question, guys. You wouldn't notice, but again, the examiners made it hidden by even making sure that the constructions, if one is lazy to make constructions and see for what they are, dead and buried. Okay, guys, we've finished 7 hours of revision for Maths Paper 2, which we tried to honestly point you in the right direction, which I hope you guys have been helped greatly by this. And of course, folks, let's just see what else you could do to practice more. All right, guys, so please, here are some suggestions. You can have a look at this question and enjoy it. Please make sure the properties of geometric figures are well understood, because these kinds of questions heavily rely on that, and of course everything else. So try these. If you have any troubles, show me. And what I can do after your prelim exams, I will try to perhaps walk through some of these problems, maybe during our classes, maybe for the channel as well, because obviously I need to keep the channel growing, because eventually we need to make it a channel that can be very useful for at least high school education. For now, that's the focus. I don't know if I'll keep up, but we'll see. So I have to post. So be on the lookout that some of these questions I'm suggesting here may just show up as, featured videos in the channel, because I have done a lot of work by now. It's nice for me to just pick a single question, deal with it, and leave you to think about all the ideas surrounding it. We did not even mark our stuff here, which is very crazy, right? Yeah, very right. But I think this is key. Without this one, we're not anywhere. The other one is not so much of a big deal because, you see most. This was supposed to be 3 marks. Oh, I don't even remember. It was just 2 marks. So I think the reason here was the most important. The rest was just the gymnastics perhaps a student had to come up with. Right. So that's the story, guys. Or even, there's a lot of marks that could have been given, but again, the examiners were just protecting students, knowing very well they could easily not find this. It would be much more tough, because I know your eyes don't really look where they're supposed to. They wander around. All right, folks, not a big deal. We've marked it. So please try these questions and see how far you can go. And as I said, I will try to do most of these that I did not do now in the channel as individual videos and questions. Okay, guys, here's another one. This question, what I like about it, if at all I can make it more important, is that this helps a student to prove the similarity proportionality theorem story here. So this one walks a person through this, because we can make it interesting by asking some small questions leading up to the ultimate, which is usually what you could get in the exam. But again, it helps a lot. So, and then you walk through the second part, which could be quite interesting. We walked through this in the class, so I don't have to really do it for my guys, but I may do it, just for the benefit of everybody at a later stage. But try practicing and see how far you can go. All right, guys, I'm going to cut the video here. It's been a long 7 hours. I need to rest because I need to meet my students this evening so that we can practice a bit more. So, what can I say? What sayest thou when kunje? Maseburafu kanje. Vele kube rough kakhulu. I'm trying to think, guys, did we do analytical geometry during the classes? I don't remember, I really don't remember. But anyway, we will meet tonight and handle statistics as well as analytical geometry, because I think we didn't get to it. But again, this video will assist even long after we finished our class, in case you find yourself locked and not knowing what to do. I suppose this video can help, because some of these questions I'm highlighting, you may try, get stuck, or perhaps need an idea. I will try to be as available as possible, but not beyond midnight, guys. 12 midnight, people must go to bed. Whether they feel ready or not, it's best to rest that brain so that you can get the best out of tomorrow. At least survive the exam, if not, pass it very well. Or even better yet, excel in it. I'll see you guys again sometime in the near future. And for tomorrow, for those who are writing, good luck. If at all your luck still is on par with you and your desires and your desperation. But if your luck has run out, my friend, well, this video may resuscitate you and perhaps give you a perspective and a chance. If not, at least you know what is right and you know what to do. Please get onto it as soon as this is over. And make sure November is not a time you're going to face with surprises. You will go there with your head clear and knowing most of the work you need to know. And you know what? All the best for your future endeavors. Mna ndindim ndithi mazenethole. Kuthiwa njalo nakanene? Kuthiwa mazenethole. Hey, andisasazi nesixhosa uba kuthethwa kanjalo xa kutheni futhi. Hotsho hore he bana beso. Ke le lakaletsa mahlohonolo. Le katleho. Le hore le be le bophelo hore le ska kula he matsatsing ana le ngolang di-exams tsa lona. Le ska kula le be bophelong bo bontle. Almost good health, strong will, no issues spiritually, let no evil spirits interfere. In the name of the Lord and Savior, our Lord, the greatest, Jesus Christo. Yes. I must say, pop. Good luck, guys. And for those who are in my class, let's meet 7 p.m. sharp. Don't be late. If I don't seem to be on, guys, say 5 minutes after 7, call. My phone is next to my ear. Make sure it's under my pillow. I will hear it and wake up if I'm asleep. But then, keep working during the day. Take some breaks. But those breaks must not be watching movies and nonsense on social media. When you take a rest, you do some chores. Believe me, it works. But don't do heavy stuff like, moving furniture around in the house, digging holes and all. No, just easy things that you can do in the household. Clean your room, clean the kitchen, cook some quick meal there. Cooking is not that tiring at all. Cook if you can. We need a proper distraction, but one that doesn't destroy, the mood of studying. And then you eat. And then after eating, you go back onto business. And if you feel tired a bit, set the alarm. Take a nap. Okay, so that you don't continue tired. Take a nap. Let it switch off a moment. You'll be fine. Hey, guys. Seliphelile ixesha elininzi again ndiloqa apha. Papa yini. Ndibona kwixa elizayo.